Welcome! In this course, you'll learn how to build mobile apps with Ionic Framework and React. First of all, what is Ionic? Let's start from its homepage, that is ionicframework.com. From this page, you can probably guess that Ionic is a component library. We can see some UI components here as a sort of showcase. But actually, Ionic is a lot more than just a component library. This section explains it well. Ionic allows you to build cross-platform apps, which means apps that you can run in a regular web browser, but also build as Android and iOS mobile apps. And they are built with the web, meaning that you can write them using familiar web technologies like JavaScript and CSS. Ionic is free and open source, and it offers a library of mobile-optimized UI components. So again, the UI components are at the core of the Ionic framework, and they are components designed to display beautifully on all mobile devices and platforms. But in addition to the component library, Ionic provides some tools that let you build your app for Android and iOS, so you can publish it to the app stores, in addition to running it as a mobile website or as a PWA, that is a progressive web app. To make development easier, Ionic offers a set of tools, including a command line interface, that we can use to create new projects, build them, and run them. So this is what Ionic provides in a nutshell: a UI component library and a set of tools to build your app for different web and mobile platforms. Ionic also offers integrations for multiple web frameworks. The core UI library is based on the Web Components standards, and you can even use it with vanilla JavaScript, but they do provide official integrations for React and Angular at present. In this course, we'll cover how to use Ionic with React, so let's look at this React-specific page. Again, this highlights how, with Ionic, we can build both mobile and web apps from a single codebase. And we get a preview of some of the over 100 React components included with Ionic. Here we can see a card widget, but we can also look at a list example and so on. What I haven't mentioned yet is that Ionic apps can also access native mobile functionality. For example, in our code, we could take a picture using the phone camera, or schedule notifications to be displayed to the user, or again use geolocation features like get access to the GPS position. All these native APIs are available when building your app for Android or iOS, which can be done using Capacitor, that is another project developed by the Ionic team. Now, if you're familiar with React, you've probably heard of React Native. That's another way to build mobile apps in JavaScript with React. So how does Ionic compare to React Native? The main difference is that Ionic is entirely based on web standards. With Ionic, your app is always like a regular web app, even when you build it for Android or iOS. So your components will be rendered as HTML or DOM elements. You can install elements using regular CSS. And this also means you're free to use pretty much any additional library designed for the web. Another advantage of using regular web technologies is that you can also use Ionic to build a mobile website or a progressive web app, in addition to native Android and iOS apps. So potentially you can target 3 different platforms, that is web, Android, and iOS from a single code base. The fact that Ionic apps can run in a regular web browser also means that you can develop them just like you do with regular web apps. You can use all the tools you're already familiar with, like the Chrome developer tools and so on. Finally, Ionic is backed by a company, that offers support and other services around Ionic. So if you need commercial support, for example, you can contact them. Okay, this was just a quick overview of the main features provided by Ionic. In the course, we'll gradually learn how to use those different Ionic features one by one. In the next section, we'll start with a regular React project and see how to add Ionic to it. In this section, we'll build our first Ionic React app, and we'll begin with a simple Hello World example. What we'll do is start with a regular React app and gradually add Ionic to that project. Later in the course, we'll also see how to use the Ionic CLI or command line interface. That's a tool that lets you easily generate fully featured Ionic projects. But for now, we'll start with a basic React project and introduce Ionic one feature at a time. So we'll see how to use some simple UI components like a button and a toast message. We'll talk about adaptive styling, that is how Ionic uses different styles for the same app, depending on whether it's running on Android or on iOS. We'll see how to customize the Ionic theme, so things like changing the default colors. Then we'll look at Ion icons, that is an icon pack provided as a separate package. And finally, we'll go from using just a few Ionic components here and there on our website to building our entire user interface out of Ionic components, so that our page will look more like a typical mobile app. In the next video, I'll show you how to download and set up the initial React project. As mentioned in the previous video, in this section we'll start with a regular React app and add Ionic one step at a time. As you might know, the quickest way to set up a new React project is to use the Create React App command line tool. You can run npx create react app in a terminal, and this will initialize a new React project for you. For this example, however, I'm providing you with an initial project to download to make sure you have exactly the same code I'm using in the videos. So if you look under Resources for the current lecture, you should see a file named helloworld.zip. And if you click on that link, it should prompt you to download the file. In my case, I'll save it in a folder called Projects, which is where I like to keep all my projects. But you can keep it wherever you like on your machine. Now I'll open this file in Finder. If you're on Windows, you can use the File Explorer. And I'm going to unzip it simply by double-clicking on it. So this created a Hello World folder that we can open in a code editor. Since I don't have a shortcut to open it in Visual Studio Code, I'll open it in a terminal first. By the way, if we list the contents of this folder, you can see that there's a package.json file, which means it's a JavaScript project you can manage with npm. Anyway, let's open it in Visual Studio Code so it's easier to see what's inside. You can see that the package.json lists React and React DOM as dependencies, and also React scripts as a dev dependency. React scripts is the command used to build and start the app. So this is a basic React project generated using Create React App, but I have removed all the unnecessary things like the React logo, styles, and so on. If we look at the JavaScript code, inside the source folder there's an index.js. This is the entry point, and it simply tells React to render the app component, which is the one defined in app.js. It's a very simple React component that simply displays a heading and some text. Now, before we can start our project, we need to install its dependencies. So I'll open a terminal, and I'll use the one integrated in Visual Studio Code. Here we need to run npm install, and this will download all the required packages, which can take a minute or two. Once it's finished, you should see a node_modules folder in your project, where it saved all the packages it downloaded. At this point, we can launch the app using the npm start command. This will launch a local development server and automatically open the home page in a browser. You can see our very basic app running here. Now let me put the browser in the last third of my screen and Visual Studio Code in the first 2/3, so we can see both the editor and the browser side by side. We can also hide the terminal. The dev server will keep running in the background. And let's focus on app.js that renders what we see on this page. I'm also going to open the Chrome Developer Tools so we can see any messages logged to the console, including possible errors. And with this, we're ready to start working on this project. As you probably know, whenever we change this code, like if we add some exclamation marks here, the page will automatically update as soon as we save this file. The React dev server provides hot reloading out of the box. Okay, we're all set up, and in the next video we'll start adding Ionic to this project. We have this initial React app running locally. Now we'll see how to add Ionic to our project. As we can see in this preview frame, Ionic provides a number of UI components that we can use to build our user interface. It includes simple elements like buttons and form fields, but also more complex functionality like tabs and navigation. Let's start from something simple like a button. We have some nice button styles available. Not only that, but there are different styles for iOS and Android. We can find some documentation for each component if we open the Components tab. Let's see what it says about buttons. At the top, it simply describes what a button is for, but then we can also see a preview of that component with some sample code. In our case, we want to use Ionic with React, so let's make sure we select the right framework. If you look at the code, you can see that we can import an Ion button component from a module called @ionic/react, and then we can display it simply by adding the Ion button tag to the JSX code that renders our React component. Note that in React there's a specific convention for how components should be named. In other frameworks, or even in plain JavaScript, the component is called Ion-button, all lowercase. This is a naming convention sometimes called kebab case, and in many places in the documentation you'll see components written in this way. But React follows a different convention called upper camel case, where Ion button is written as a single word with capital I and B. It's a small thing, but I just wanted to make sure you don't get confused if you see the same component written in different ways in different places. Now let's get back to our application and see how things work in practice. Before we can use any Ionic component, we'll need to add the Ionic package to our project. So I'm going to stop the development server by hitting Ctrl+C. Now we can add the Ionic package by typing npm install @ionic/react. This will take a few seconds. There you go. Ionic React has been added to our project dependencies. We can start the React development server again with npm start. I'll leave it running in the background. The next thing we need to do is initialize Ionic in our code, and we can do that in app.js. Here we want to import some functionality from the module we just installed, that is Ionic React. And the first thing we need is a function called setupIonicReact. We need to call this function when our app is loaded. Note that we're calling it outside of the app component, so it will only be invoked once when this module is loaded. We also need some styles that we can import from the same package, but inside a CSS folder where there's a file called core.css. This contains the core Ionic style sheet. There are other CSS files as well, as we'll see later, but we always need at least core.css. Okay, so this is the minimum amount of setup we need to do in our project before we can use any Ionic component. At this point, we can go and add some Ionic components to our JSX code. For example, let's insert an Ion button here. Note that I'm using the auto-import functionality provided by Visual Studio Code, so Ion button has been added to the imports at the top automatically. Now, the simplest way to use an Ion button is to write some text inside it, like "click me." And if we save this file, you can see that the app reloads and shows a nice blue button with our "click me" text. Good stuff! We managed to get a first Ionic component displayed in our app. Of course, we can try and click this button, but there's no functionality attached to it yet. We'll add some in the next video. For now, let's just recap quickly what we've done. First, we installed the Ionic React package into our project using npm. Then we initialized Ionic in our app by calling the setup Ionic React function. And we also imported the core Ionic CSS file for the styles. Finally, we inserted an Ion button into the elements rendered by our app component. So these are the simple steps required to add Ionic to an existing React project. In the previous step, we added Ionic to our React project and used the first component, that is an Ion button. At the moment, this button is pretty useless because even if we click it, nothing happens. So let's make it do something. Let me split this into separate lines so we have a little more space. And we can now add an onClick handler to the Ion button, just like with the regular HTML button element. Here we can pass a handleClick function that we can go and define above. I'll use the arrow syntax here, but you can use the function keyword if you prefer. Now, what should we do when the user clicks the button? Let's start by simply logging something to the console, like a message saying clicked. If we save and go and click the button, of course we see the clicked message printed to the console. And every time we click, it will log the same message again. So far, it works just like a regular button handler in React. Now, let's make things a bit more interesting and display another Ionic component. We can quickly search the documentation using this box, and if we type Ion Toast, we can find a component by that name. As the description says, a toast is a notification that can be used to provide feedback or display a system message. If we scroll down, we can see a preview right here. Let's make sure to select React as the framework. We can show a toast in different positions at the top, middle, or bottom of the screen. If we try Present Toast at the bottom, you can see that this shows a small pop-up message at the bottom of the screen. So let's take a look at the code example. Note how, in this case, rather than a component, it imports a React hook called useIonToast. And then it calls this hook to obtain a present function that's the first element in the array returned by useIonToast. So then, to display the toast message, it calls that present function, passing a few options like the message to show. And that function is called whenever a button is clicked. We could do something similar in our own application. But before we do that, I want to show you that there's another way to use this functionality. We could import the IonToast component instead of the React hook. In this case, we would insert the IonToast into our JSX code like a regular React component. The downside of this approach is that we would need a state variable to keep track of whether the toast is visible or not, and only display the toast when showToast is true. That's why Ionic also provides a React hook instead. With useIonToast, there's no need to keep a separate state variable. The toast will only be displayed when we call the present function and then disappear automatically. So let's go back to our application and see how to make it work in our code. The first thing we need is to call the useIonToast hook that I'll let Visual Studio Code import automatically. The value returned by this hook is an array, which may seem strange at first, but it's an array because it contains multiple values. The first element is a function that we can call to display the toast, so I'll call it presentToast. There's also a second element that is a function to dismiss the toast, that is to make it go away, but that's not usually needed because the toast disappears automatically. So all we want is this presentToast function that we can call whenever the user clicks our button. PresentToast accepts an object with some options, like the message to be displayed. Let's set it to Hello World, since this is our first example. Then we can set a duration, that is how long the message should be displayed. We can set it to 1500 because this value is in milliseconds, so this means 1.5 seconds. There are other options available, but this will do for our example. So let's save and test how this works. If we click the button now, you can see the Hello World message popping up at the bottom of the screen, and it automatically disappears after 1.5 seconds. That's it. This is all we need to display a toast message with Ionic. The interesting thing here is that in this case, Ionic provides a React hook that simplifies the way we can use this component. The hook returns a presentToast function that we can call in response to the button click to show the toast message. So we're now using two different Ionic components in our app, and you can see that they work just like many other React components. For example, you can set an onClick handler to trigger some action when the user clicks an Ion button. In the previous step, we made this button display a toast message when clicked. Both the button and the toast message currently use the material design style, that is the default style. But Ionic has the ability to automatically change the style based on which platform our app runs on. The simplest way to show this is to enable device mode in the Chrome Developer Tools. This way, Chrome displays our page as if we were viewing it in a phone or tablet, and we can select different devices from this drop-down list. Let's select iPhone SE, for example. If we now reload the page, you can see that the button looks different. This is because, since we selected an iPhone, Ionic is using the iOS style. If we go and select an Android device instead, like a Samsung Galaxy, and then reload the page again, the button changes back to the material design style. Note how we always need to reload the page for the style to change, and I'll explain why in a minute. So this is what Ionic calls adaptive styling, which simply means using a different style depending on the platform. Material design is the style required for Android apps. You can find a specification on this website, that is material.io. There are instructions for each component, including buttons, and if you scroll down, there should be a demo as well. You can see what an Android button should look like here. It's fairly rectangular with just a little bit of rounding, the text is all uppercase, and so on. So Material Design was created by Google to make sure all the components for the Android platform follow a consistent style. For iOS, the Apple website has its own set of guidelines. If we take a look at buttons again, this page should have a few examples. There are actually different button styles on iOS, like plain or filled, small or large. But if you look at the medium filled example, it looks very similar to the button in our Ionic app when selecting iPhone as the device. It's more rounded than a Material Design button, its text is not all uppercase, and so on. Now, if we had to write our own CSS styles to make every component in our app follow these guidelines, that would be a huge amount of work. But thankfully we don't have to, because Ionic already takes care of all the styling. If we want to, we could see both styles at once by opening another browser tab with our app, then open the Chrome Developer Tools and select an iPhone in this case, since in the other window we selected an Android phone. So we can keep two browser windows open and see what our app looks like on both iOS and Android at the same time. If we click the button, you can see that the toast style is also different on iOS. The pop-up shows black text on a gray background, while if we try the same on Android, the toast is white text on a black background. So that platform styles apply to all Ionic components. Now let's close this window. Actually, let me first explain how Ionic decides which style to use. In JavaScript, you can find out which browser is running your app by checking the Navigator User Agent property. This returns a long string that describes each browser. On an iPhone, this value will contain iPhone somewhere, while if we look at the same property in the other window, where we selected a Samsung Galaxy as the device, you can see that in this case the user agent contains the string Android. So this is what Ionic looks at to decide which style to use. And it checks this property only when our app starts, which is why we need to reload the page whenever we select a different device in the DevTools. Let me show you in more details how the styles are applied. I'm going to move the DevTools to a separate window so we can inspect the HTML elements. Let's go and select our button in the page. If we look at the elements, you can see that the button is really an Ion button element, and it has a few CSS classes applied to it, starting with MD. MD is short for Material Design, so the MD class will apply the Android styles. Now let's see what happens if we select an iPhone instead. In this case, the first CSS class is iOS and not MD. So based on the user agent, Ionic detected that the app is running on an iPhone and therefore applied the iOS CSS class to all components. In the next video, we'll talk more about styles, including how to customize them. But before we get there, I want to show you how you can choose a specific style if you want to. When calling the setup Ionic React function, we can pass an object with some options. And one of these options is called mode. The mode can be either iOS or MD. If we set this to MD, for example, this means that our app will always use the Material Design style. If we save this change and go and reload the app, you can see that the button uses the Material Design style, even though we have iPhone selected as the device. So this could be useful if, for example, you only plan to publish your app as a website and you prefer to show the same style to everybody. But normally, especially when publishing mobile apps, you want to let Ionic choose the best style for each platform. Adaptive styling is in fact one of the main advantages of using Ionic for your app. We've seen how Ionic gives us adaptive styling, which means that on an Android phone this button uses the Material Design style, but if we run the same app in an iPhone, the button will be displayed in the iOS style. And by the way, if we are not running in a mobile device, but in a regular desktop browser, it will use Material Design by default. This is all great, but what if we want to customize the styles a little bit? For example, suppose we want to change the color of this button. We can fully customize the Ionic theme following the instructions in the documentation. By default, Ionic provides a color palette that we can use for our components with a few predefined colors. You can see that the theme has a primary color that by default is the same shade of blue that we saw as our button background, but there's also a secondary color that's a lighter shade of blue, and a few more options like success, warning, danger, and so on. So the first way we can customize the look of our components is to choose one of those theme colors. The Ion button, for example, accepts a color attribute that can be set to any of the theme colors we just saw in the documentation. If we set the color to primary and save, nothing actually changes because primary is the default color for a button anyway. But if we choose secondary instead, you can see that now the button background is a lighter blue. Or we could set the color to warning, in which case the button background will be yellow. But notice how the button text also changed to black to make sure the text is readable. If you remember, when using the primary color, the text is white. So it's interesting how setting a theme color doesn't necessarily change a single color, but it can actually change a few related colors, like background and text. Let's see exactly how those styles are applied if we inspect the elements using the Chrome DevTools. Let's inspect this button that is really an Ion button element in the HTML. Notice how it's been assigned a class called Ion Color Primary, and we can see the styles associated with that CSS class down here. This defines a few CSS variables like Ion Color Base that is set to the value of the Ion Color Primary variable with a shade of blue as the default. So this is effectively the button background. But there are other variables like Ion Color Contrast that's set to the value of the Ion Color Primary Contrast variable. This is the text color that in fact defaults to white. So Ionic makes heavy use of CSS variables for theming. CSS variables, also known as CSS custom properties, are a way to define reusable values in CSS. We can see an example here in the MDN documentation. You can define a CSS variable either at the element level or more frequently at the global level by using this root pseudo class. Each variable name starts with --, like in this case --main -bg -color. Then you can assign it a value after a colon, like in this case brown. Once you have a CSS variable defined, you can use it like in the example here at the bottom. So you could set the background color for a certain element to the value of the main bg color variable defined earlier. And you can use the var statement to extract the value of the variable, that in this case will be brown. All this is part of the CSS standard, and you can use it in any modern website. The reason Ionic uses CSS variables is that they make it easy for us to customize the theme. If we look at the documentation for colors, as we've already seen in our app, each theme color is really several related colors combined to form what's called a layered color. So the primary color, for example, is composed of a base property that by default is this shade of blue that by now we're familiar with. And this value is defined as a CSS variable called Ion Color Primary. But then a layered color also includes a contrast value that's used, for example, for the text displayed over the base value, and some other values like shade and tint that are used, for example, to highlight the button when you move the mouse over it. All these values are defined using CSS variables so that we can modify them if we want to. And the way we can do that is simply by redefining those CSS variables in our app, overriding their values with our own custom values. Now, since each layered color is composed of 6 different values, we need to make sure to override all the related variables. Thankfully, Ionic provides a color generator that we can use to easily create all the different properties for each color. For example, suppose we want to change the primary color. We can simply choose a different color here, like some dark red, and we can see straight away what this looks like in the theme preview on the right. You can change the other colors as well if you like, but the useful thing is that this also generates the code to define the necessary CSS variables. In our case, we only changed the primary color, so we just need the first group of definitions. Let's copy this code and use it to customize the theme in our app. Let me put the DevTools back at the bottom. So what we want to do in our project is create a new CSS file with our custom colors. For that, I'm going to create a new folder called theme inside the source folder, and inside here I'll create a file named variables.css. The file name is not important, you could call it whatever you like, but most Ionic projects follow this structure. The important thing is that here we want to paste the code we copied from the color generator and close the curly brackets. So here we are overriding the Ionic primary color with our own color, that is a dark red instead of a blue. The next step is simply to import that new CSS file into our app code. After importing the Ionic core CSS file, we want to import our theme variables.css. Note that we need to load our CSS file after the Ionic one because it overrides the default Ionic styles. With this, if we save now, you can see that the button background is now dark red. So it is using our own custom primary color. Not only that, but it has all the values required for a layered color. The text is white to provide sufficient contrast. If we move the mouse over the button, it shows a slightly lighter red, and so on. So that's how you can customize the Ionic theme. You simply define some CSS variables that override the default Ionic values, and you can use the color generator tool to easily pick each theme color, then generate the code with all the CSS variables. Now, I've focused on colors in this video because that's the main thing you may want to customize, but you can override other styles as well if you really want to, always using CSS variables. For example, it's possible to customize the font family, although I normally don't recommend doing that because fonts are part of what makes your app look like a standard Android or iOS app. You can also override some styles only for a specific platform. For example, you can set a certain color only for iOS by defining a variable for elements with the iOS CSS class instead of under the root pseudo class. So there's a lot you can customize in the Ionic theme if you want to. And you can do everything using regular CSS because Ionic uses CSS variables everywhere, making it easy for you to override them. We've seen how we can customize the Ionic theme so that our app can use custom colors and other styles. Now, another thing we frequently want in an app to make our user interface nicer is icons. Ionic provides its own set of icons called Ion icons. You can browse all available icons on this website, that is ionic.io/ionicons. And there's also a handy search box where we can type something, like play for example, and it will show all the icons that are associated with playing. As you can see here, these icons come in 3 different styles: outline, that are empty in the middle, or filled, or again sharp. Sharp and filled are actually quite similar, except that filled icons are more rounded. Now, suppose we decide to use this icon here. If we click on it, it will show a pop-up at the bottom telling us that this icon is in fact called play. So let's go back to our application and see how we can use that icon in our React project. Before we can use any icon, we need to install the Ion Icons package. So let's add that to our dependencies. I'll stop the development server and run npm install Ion Icons. That's the name of the npm package. Once it's installed, we can restart our dev server and then go back to our app component. So in this file, we can now import any icon we want from the Ion Icons module, but adding /icons, because this way we can import them as SVG data that's easier to use in React. Now, the icon we want is called play, so let's choose that one from all those available. Personally, I like to rename it and call it play icon rather than just play, just so that it's clearer that it's an icon, but that's optional. The important thing is that we can now use this play icon in our component. For this example, we can show it inside the button. Now, to display an icon, we can use an Ionic component called Ion Icon, and note that I let Visual Studio Code import it automatically. You can see that it was added on the first line. This Ion Icon component expects an icon prop where we can pass our play icon. Since we're using it in a button, we want to set another prop called slot that tells it where to position the icon. If we set it to Start and close this tag, you can see our new icon displayed inside the button before the Click Me text. If we set the slot to End instead, that will show the icon after the text. Or we can also set it to Icon Only, in which case we should comment out the text, because it's for displaying a button with the icon only. Anyway, let's set it back to Start for this example. There you go. And that's pretty much everything there is to using Ion icons. We simply need to make sure we have the right npm package installed in our dependencies, and then we can use any of the icons by importing them from the icons folder inside the module. Finally, we pass the desired icon to the Ion icon component. And to find out which icons are available, remember that you can simply do a search on the Ion icons website. We've seen how to use Ion icons in our project. The last thing we'll do in this section is turn our page into a full Ionic app. What I mean by this is that so far our app is basically a web page composed of normal HTML elements like a header and a main section, and then we inserted just a few Ionic components here and there, like a button with an icon. This approach is fine for a regular website, but for a mobile app it's better to build the entire user interface with Ionic components, so that it will look more like native mobile apps. Let's see how that works. So far we only imported the core Ionic CSS here. For a full Ionic app we'll need some more style sheets. Since there are quite a few of them, I listed them all in the README file. The full list is under Ionic CSS imports. So what we want to do is copy all these lines and go and paste them into our app.js code. Let's replace core.css with the full list. You can see that there are some comments as well. Core.css is always required for any Ionic component to work properly. Then there are 3 more imports that are needed to build a full Ionic app. There are also a few optional CSS files, and we'll come back to them later. Note that we still want our custom theme variables as well. In fact, let's add a comment here explaining that it's for custom styles. Okay, we can save this file now. And you can see in the browser that our app looks a bit different. For example, there's no spacing around the content. It will look better once we change this into a full Ionic app. What this means is that we want our top-level element to be Ion app. That's an Ionic component that I'll auto-import. And of course, we need to use the same as the closing tag. Ion app comes from the Ionic React module, and you can see that it's been added to the imports on the first line. Back to the JSX code. So an Ionic app always has Ion app at the top level, and then it typically has a header and some content. This is similar to what we already have, but instead of a regular header element, here we want an Ion header component that, as usual, I'll let the editor auto-import. As for the main content, we want to use the Ion content component. Make sure to select Ion content and not Ion context. Now, inside the header, we typically want a toolbar that is the Ion toolbar component, and this toolbar will contain the title. But instead of an h1 element, we want to use an Ion title. That's again another component provided by Ionic. Okay, so this is the basic structure of a full Ionic app. If we save these changes, you can see what our app looks like now. The title, that is my app, is now inside the toolbar at the top, and this is what mobile apps typically look like. There's always a bar with the title at the top. In fact, remember that Ionic does adaptive styling. So if we enable device mode, select an iPhone and reload the app, you can see that the toolbar looks different on iOS. The title is centered and the bar has a light gray background. While if we select an Android phone, like a Samsung Galaxy, the title is left aligned and uses a larger font as well. So by building our entire app out of Ionic components, we get a user interface that automatically adapts to the Android or iOS styles. Now, there's one thing that doesn't look so great at the moment. The button is very close to the header and to the left border. It would be nice to add some padding around the content. We can do that very easily by adding a CSS class called Ion Padding. With that class, you can see that there is now some space around the content. That looks much better. Now, where does this Ion Padding class come from? If you remember from when we added the CSS imports, there are some optional CSS files here. The first one is called padding.css. This is in fact what provides the Ion Padding class. So these optional CSS files provide utility classes that we can apply to any component. We can find out more about them in the documentation. If we search for util, we should find a page called CSS Utilities. And this lists all the available CSS classes. For example, there are some utilities for text modification, like Ion Text Center, that can be used to center any text horizontally. Now, the one we used has to do with padding, so if we select the right section, we can find Ion Padding. It applies 16 pixels of padding to all sides. But there are other classes you can use to add some padding only at the top or bottom and so on. So you have a bunch of utility classes you can add to pretty much any component to customize its appearance. But they're split into separate CSS files, so you can import only the ones you actually need. For example, in our case, we only use the padding utility, which means we're not actually using all these other imports, so we could comment them out. This way, our app should weight less, because it doesn't include CSS files we don't actually use. But this is just an optimization you can make before publishing your app. The main point of this video was to show you what a full Ionic app looks like. This is the basic layout of a typical app. You have an Ion app component at the top, wrapping an Ion header and an Ion content, and inside the header there's an Ion toolbar with a title. Inside the content you can have many other components, although here we only have a button. This is obviously a very simple example. We'll build some more interesting apps in the rest of the course, but the basic structure will be similar. In this section, we'll build another Ionic app, and this time it will be a non-trivial example. We're going to develop a biorhythm calculator, and to show you what that means, I'll use this online calculator from Casio. To calculate the biorhythms, we first need to know the person's birth date. Let's say somebody was born on the 1st of January 2000. We also have a target date below, that is today, the 17th of March 2020. Now, if we click Execute, this will calculate some numbers and plot a graph. The idea behind biorhythms is that each person's abilities go up and down over time, but following some predefined cycles. For example, if we take the physical well-being, that is the blue line, you can see that it peaks at this point, that is around the 25th of March. So somebody born on the 1st of January 2000 will be at the top of their physical form on the 25th of March 2020. Their next peak will be after 23 days, that is around the 17th of April, and this cycle goes on forever. So on the target date, that is the 17th of March, their physical ability will be at this level, that is pretty low. And it corresponds to this number, minus 0.5 something, because minus 1 means the rock bottom and plus 1 is the top. Now, just to be clear, this theory about biorhythms has no scientific value. It's a bit like astrology. Some people believe in it, but it's just pseudoscience. But it should be quite a fun exercise to develop our own biorhythm calculator and run it as a mobile app. Also, it will allow us to learn a number of new things. We'll make use of some additional Ionic components like input fields that will need to let the user enter their birth date, for example. We'll also create a few React components of our own, and we'll see how to style individual components. Then we'll briefly cover writing unit tests that will be useful to make sure we calculate the biorhythms correctly. We'll want to store some data to remember some user settings, and we'll use local storage for that. And like any non-trivial project, we may want to use some additional libraries, for example, for working with dates, and also for displaying charts. One of the advantages of using Ionic is that it's based on web technologies, so we can use pretty much any JavaScript library that works in the browser. Now let's go and set things up. Just like with the first example, I'm providing you with an initial project as a starting point. I'll just copy the project name from here so I don't have to type everything. Now in a terminal, I'll go into my projects folder, but you can use a different location on your machine, of course, and run npx degit GitLab Ionic React course /biorhythm calculator and put it into a folder with the same name. Then we can go into that new folder and open the project in Visual Studio Code. Just like our first example, this project was initialized with Create React App, but this time I already added Ionic React and Ionicons to the dependencies. Also, if we look at index.js, here I've already imported all the Ionic CSS files. And finally, if we look at app.js, this already has the basic structure of an Ionic app, with Ion app, Ion header, Ion toolbar, and so on. So we're basically starting from where we left off in the previous example. Now, as usual, we'll need to install all the dependencies, so run npm install and wait a minute or two. Okay, now that we have all the npm packages, we can start our app by running npm start and wait a little bit more for the Webpack dev server to start up and open our app in the browser. Okay, so this is our initial Ionic app. We are developing for mobile, so enable device mode. And let's keep the editor and the browser side by side as usual. All right, we're ready to start adding some functionality, and we'll do that in the next video. So we have this initial Ionic app set up and running. Now let's start implementing our biorhythm calculator functionality. To begin with, we can change the title to say biorhythms. I hope I spelled it right. Next, we want to add some real content. But what should we add here exactly? Let's have a look at that online biorhythm calculator. Here it's asking for a birth date and a target date. So we'll certainly need some input fields. If we search the Ionic docs for Ion input, we should find the right Ionic component. It should be the first result. As usual, the documentation page shows a preview with some input fields, and we can look at the usage to see some code. Seems like the most basic way to use this component is to simply write an Ion input tag without any properties. So let's try that in our own app. Let's put an Ion input inside Ion content, auto-import it, and just close the tag. Now, there's nothing visible in the page, but if we click at the top, you can see that there is actually an input field here, and we can type something in it. But obviously, if it's not clearly visible, that's not very good. To improve things, we could add some placeholder text, maybe, saying your name. So at least now there's some indication that the user should enter their name here. Still, we could do better. It would be nice to display a label before the input field. The best way to do that is to first add an Ion item component that's simply a container for other components. Then we can move the Ion input inside the item. And now, let me collapse the imports so we can see the code better. Now, inside the Ion item, we can add an Ion label component with the text of the label, say name. And you can see the result in the browser. So we use the Ion item component to group the label and the input field. Since we have a label now, we could remove the placeholder text. And it's worth mentioning that an Ion input can have a type, just like a regular HTML input element. And the type can be any of these values. That's a subset of the HTML5 input types. If we don't specify a type, then it defaults to text, which is the most commonly used. But of course, we can choose a different one, like password, that results in the text being masked when the user types something. Or we could use email, for example, which is very similar to text, but with email, mobile browsers will display a soft keyboard with letters more appropriate to type an email address rather than generic text. Anyway, let's go back to text since we're asking for a name. In fact, since it's the default, we might as well remove it. Now, we have an input field, but how do we make use of whatever text the user enters into the field? Let's add a simple paragraph here. Let's say we simply want to display whatever name the user entered. How do we do that? Well, pretty much in the same way as we would do it in React with a standard HTML input element. First, we need to import the useState hook, and then we can use it to get a state variable, let's call it name, and a setName function to update it. This is by calling useState, and we can pass an empty string as the initial value. Now we can use this name variable and display its value in this temporary paragraph. And we can also set it as the value of the input field. If we save at this point, well, name will always be an empty string, but if we change the initial value, you can see that both the input field and the paragraph below display Alice as the name. But we don't want to hard code a name. We want to know what the user types into that field. With a regular HTML input element, we can listen to the onChange event and pass an event handler that is a function that receives the event as a parameter. And here we can update the name to be event.target.value. Event.target is the input field, so its value will be whatever the user entered. This is the typical way to have a controlled component in React with hooks. So you might expect the Ion input component to work in the same way, right? However, this is not actually the case. If we enter some text into the input box, the value displayed in the paragraph below does not change. So this is a bit surprising. But the solution is actually very simple. Instead of the onChange event, we need to listen to the onIonChange event. This is because Ion input is not a simple HTML input element, but it's a more complex component, so the Ionic developers had to create their own event. If we look at the event object received here, it's now of type custom event. And this also means that instead of event.target, here we should use event.detail because a custom event has a detail object. But if we save now, With this small change, you can see that the value of our name variable updates as soon as we type a character, or even if we delete something for that matter. So there is this small gotcha when using the ion input component that we must be careful to use onIonChange and not onChange. In general, it's always a good idea to look at the documentation page for each component. All events are documented there, and if there is an event called onIon something, you should be using that one instead of the usual one emitted by native HTML elements. But with this small caveat, using an Ionic input field is very similar to using any other input element in React. In the previous video, we added an ion input component, and we've seen how to bind the user input to a React state variable. We've also seen that we can use an ion item component to group an input field and its associated label into a single row. Now, let's duplicate this item to see what happens if we have more than one field. In fact, in addition to the name, we'll need the user's date of birth in order to calculate their biorhythms. Now, let's leave this ion input here, but without binding its value. Let's just focus on what it looks like for now, not on the functionality. If we apply these changes, we can see the new field row with the date of birth. But if we type something into both fields, anything will do. Notice how the values we entered are not aligned. Each input box appears right after the label, and since date of birth is longer than name, then the second value is displayed more to the right compared to the first value. Now, there's an attribute we can set on an ion label called position, and its possible values are fixed, floating, or stacked. There's actually a fourth possible option that is not setting the position at all, and in that case the label is displayed inline, which is what we've seen so far. But let's try fixed now, and we'll want the same position for the other label as well. If we enter something now, you'll see that both values are vertically aligned, one below the other. That's because each label takes a fixed amount of space, so the name label is the same length as the date of birth label. Okay, so that's what fixed does. What about floating? It looks the same initially, but when we select an input box, you can see that the label shrinks and it stays above the user-entered values. So there's this little animation effect. Finally, let's try out the last option as well, that is stacked. In this case, you can see that the label is already above the input field in smaller text, and it always stays there. So we have a few options when it comes to positioning field labels. Which one to use is a matter of preference, but it's worth keeping in mind that when developing mobile apps, the space on the screen is limited. And if we choose fixed labels, that may limit the amount of text the user can see. Imagine if somebody has a fairly long name, it may not all be visible in this input box. So personally, I tend to prefer stacked labels because they allow more space for the input itself. Of course, it depends on what your specific fields do. I'm talking in general here. Floating labels also allow the same amount of space, but I don't particularly like that they move when you select the field. It's a nice animation effect, but it may be a bit surprising for the user. Anyway, this is just my personal view. You know what the options are now, and you're free to use whichever you like the most, of course. We recently added a second input field to our app to capture the date of birth that we'll need to calculate the biorhythms. At the moment, this is a text input, so the user can enter whatever they like. How do we make sure they enter a date, and in which format should they write the date anyway? A regular text field is not actually the best interface for entering a date. Thankfully, Ionic has a component for that. If we search the docs for Ion datetime, we can find the right page. Let's have a look at the preview on the right. To select a date, we're presented with like 3 spinning wheels where we can pick month, day, and year. This works like the native date pickers provided by Android and iOS. And it's a sort of user interaction that works well on mobile, where the screen is small, but users can touch the screen to spin the wheel. So let's see how we can use this component in our own code. Instead of an Ion input, we can simply write Ion datetime, import it, and that's it. Let's try it out. Again, we can pick some month, day, and year, and the selected date appears in the field. Pretty simple. Now, this currently shows month, day, and year in that order, which is the format commonly used in the US. If you live somewhere else in the world, you might find this format unusual. That's one of the tricky things when working with dates. Different parts of the world use different ways to represent the same date. This page is from Wikipedia, and if we scroll down a bit, there are 3 main varieties. Big Endian, that is year, month, day, Little Endian, that is day, month, year, and Middle Endian, or month, day, year. So how can we display the date in whatever format is most familiar to our users? If you target US users, you're in luck, because as we've seen, that's the default format. But with the Ion datetime component, we can easily specify a different format as well. We can pass a string with the format using these groups of letters to represent different parts of the date, like year, month, and day. For example, if we take the month, we can write a single capital M to have the month represented as a number from 1 to 12, 2 capital M's for a number that's always 2 digits, so it will show 01 instead of just 1. 3 capital M's result in a short name like Jan for January, and 4 capital M's will give you the full name like January. Right, let's see how we can use this format in practice. We want to set a display format attribute, and the value will use those special groups of letters we've just seen. For example, 4 capital Y's minus 2 capital M's minus 2 capital D's should give us the ISO format. That is, we have year, month, and day all written in numbers. Also note how the month and day are always 2 digits, so they have a leading 0 if necessary. After we select a date, we can see it represented in the exact string we wanted, that is, with year, month, and day separated by a minus sign. So the display format is used both for the spinning wheels in the date picker and for the string displayed after the user made a selection. Now let's try a different format. Say we want the day, the full month name, and the year, as is frequently used in Europe, for example. If we try now, we can see the day first, possibly in a single digit, then the full name of the month, and it will get truncated if it's too long, and finally the year. So this is nicer in the sense that we see the full month name, but it's annoying that it can get truncated. So let's try the short month name instead. This time you can see that the month is always 3 letters, which always fits the space available. So I think I'll use this format, but feel free to use whatever format is most familiar to you if you're following along with this example. Now let's talk about how to use this date. Just like with the name, let's start with a temporary paragraph where we simply want to display the selected date. This will be very similar to what we did for the name. I'll collapse this header since we're not going to touch it. So we'll want a new state variable, let's call it birth date, and a setBirthDate function returned by the useState hook. Now here we can pass an initial value, but what kind of value should it be? Should the date be a string? Or maybe it should be a JavaScript date object? What's the best data type for this value that will be used by the Ion datetime component? Let's have a look at the Ionic documentation again. If we scroll down a little bit, there should be something about the data type. Here they basically say working with the JavaScript date object is a pain, so we decided to use ISO strings everywhere to represent dates, which I think is a very good decision. Now, if you don't know what the ISO format is for a date, here are a few examples. If we want just the date, not the time, then we write year, month and day, all in numbers and separated by a minus sign. If it's not just the date, but has the time as well, then you add a capital T to separate the time part from the date part. Then you have hours, minutes and seconds separated by a colon. And finally, you can have the time zone offset as well. Now, there's no need to memorize this format, but it is an international standard and there are tools that make it easy to work with this sort of strings. So, back to our code. The question was, what should be the initial value for our date? Now we know that we can use a string. It will be an ISO date string, but it's still a string in JavaScript. As an example, the ISO string will be like 2020-01-31 to mean the 31st of January 2020. Now let's use this birth date variable. Let's display its value in this paragraph and set it as the value of the Ion datetime. If we save at this point, you can see that the Ion datetime component is displaying 31st Jan 2020, following the display format we set, while in the paragraph below it just shows the original value of the string, exactly like we pass it to useState. Next, let's handle the event fired when the user selects a date. And this is called onIonChange, just like on an Ion input component. The only difference is that in this case we want to call setBirthDate and not setName. Let's save this and test it. We can select some date and you can see that the value in the paragraph has updated as well. Interestingly, it has not just the date, but the time as well, even though all the time elements are zeros. Now, what if we don't want any specific date as the initial value? Well, we can just pass an empty string. That will tell the Ion datetime not to display anything to begin with. When the user opens the date picker, it will default to the current date, that is today, which is fine. In fact, if you look at the value in the last paragraph, it also has a specific time set. So it defaults to now, basically, the current time whenever the date picker was opened. Again, this is not a problem, but obviously we'll want to format the date in a more user-friendly way and not just display the raw ISO string directly. And we'll take care of that in one of the next videos. In the previous video, we started using the Ion datetime component. Now that we have a better idea of how to use some form inputs with Ionic, let's think a bit more about the user interface of our Biorhythms app. If we take this online calculator, we can enter a birth date. The target date defaults to today, so we don't need to change it. We click execute and we get some numbers with the physical, emotional and intellectual biorhythms. So we'll want something similar in our own app. In particular, we'll want to display these results somewhere on the page, maybe in some kind of container where they stand out a little bit more. If we look at the components provided by Ionic, there is something called an Ion card. If you look at the preview in the phone frame, a card is a container used to display some sort of information. It has a little border around it. It appears slightly raised thanks to some shadow, so it seems like a nice way to make some content stand out a little bit. Let's see how to use it in our app. Before we start, I want to clean up this user interface a little bit. We added those 2 paragraphs at the end just to show how to use values coming from input fields. Also, we don't really need to know the name of the user to calculate the biorhythms. We just need the date of birth. So let's simplify this example and remove the name altogether. I started with the name just to show you how to use a simple text input first, before introducing more complex components like the datetime picker. Let's save and check that everything still works. There's just an unused import somewhere. Ion input is no longer needed, of course. Okay, the name is gone. Let's remove this paragraph as well. And now let's see how to use an Ion card component. Make sure it gets imported. Inside an Ion card, we typically have an Ion card header. And inside a header, we can put an Ion card title. Let's just write the title for now. Then, after the header, we usually have an Ion card content. And here we can put whatever content we want. So that's what a very basic card looks like. If we want to center the text, we can simply add a CSS class called Ion Text Center. That's one of those CSS utilities we mentioned in the last section. And everything inside the card is nicely centered. So we're going to use this card component to display the biorhythm results. Instead of the title, we could display the current date maybe. That is the target date for which the biorhythms were calculated. And as the content, we could show a paragraph for each type of biorhythm, so physical and its number, just writing a mock value here, then duplicate this line 3 times because we need emotional with some other number and intellectual with its own biorhythm value. Okay, let's see what this looks like in the browser. I think that's a good start. We can improve the appearance later, but we have an initial UI where to display the biorhythm results using an Ion card component. Okay, so we added a card component to our app and we'll use it to display the biorhythm results. Before we go ahead and calculate the actual biorhythms, I'd like to do some refactoring because I think the code of this app component is getting too large. We should really start splitting the code into separate components, starting with the new card elements we just added. So let's create a new folder inside source called components. And inside components, we can add a file called biorhythmcard.js. This will be a regular React component. Now, I have my own user snippet called React FC that can generate the basic boilerplate for a React function component. So I'll just use that. User snippets are a feature in Visual Studio Code that allow you to quickly insert some code without having to type the whole thing. Maybe I'll add a link somewhere on how to create a user snippet, but you can just type the same code manually. For any React function component, you always need to import React, declare a function that returns some JSX elements and export it. Now let's save this file, and we'll want to import it into our app.js. So here we can add an import for biorhythm card that comes from a local module that is components biorhythm card. All right, now we can use this biorhythm card, and we want to insert it in the same place where we currently have the Ion card. Eventually it will replace the Ion card, but let's do one step at a time. In the browser, we can see biorhythm card in square brackets. That's the placeholder for the new component. Now we want to take all the code with the Ion card and move it to the new component. So I'll cut this code and go and paste it into the biorhythm card, replacing all the elements there. So this is what will be rendered as the biorhythm card. We just need to import all the Ionic components, otherwise we have some compilation errors. And I'll just use the auto import functionality as usual. Okay, that should fix all the errors. Let me quickly split these imports into separate lines so it's easier to see each one of them. And that's it. If we save now, we actually see two cards. We still have the old card as well because I haven't saved app.js after removing the old code. So let me save this file as well, and now we only have the new biorhythm card on the screen. Good. If we check the DevTools, there are a few unused imports, which is to be expected. We need to remove all the Ionic components that are no longer used in this file. And that should make the warnings go away. So far we simply moved some code from the app component into its own biorhythm card component. Now let's think about which props we need to pass to this component. For a start, we display a date in the title, and we could pass that in as the target date property. Note that I'm using the object destructuring syntax here to extract the target date from the props object passed to this component. So once we have the target date, we can display its value instead of the mock date we have at the moment. And if we save, we don't see any card title anymore. That's because we're not actually passing a target date prop from the app component yet. So let's define a target date variable here. And we can set it to a new date that will be the current time, that is now. But we also want all dates to be in the ISO format, so we can call toISOstring to convert it. And with this, we can take the target date and pass it to the biorhythm card component as a prop with the same name. Okay, let's see if this works. There you go. We see the current date and time as the card title. Now, we're showing the ISO string directly, which is not very user-friendly, so we'll want to format this date more nicely, and we'll do that in the next video. What we've done in this exercise is create a separate component called biorhythm card, then import it and use it in our app component. And this shows that obviously we can have multiple React components in an Ionic app. Just like with any other React app, there's nothing special to Ionic in this regard. We are at a point where we can pass a target date to our new biorhythm card component, and it gets displayed as the title there. But displaying the date like this as an ISO string will be a terrible user experience. We'll also need to deal with dates to calculate the biorhythms. So we could really do with some helper library to make working with dates easier. We're going to use day.js. There are quite a few different date libraries for JavaScript. Moment.js is a popular one, but it's also fairly big in size. So for this example, I chose day.js that has a similar API but is a lot smaller. Let's go back to our editor and start by installing day.js into our project. We'll need the terminal, stop the dev server, and then run npm install day.js. Okay, now we have day.js in our project. Before restarting the dev server, I want to show you a little bit how to use this library interactively. So I'm going to start Node as an interactive interpreter. If you run Node without any arguments, it shows a prompt where you can enter JavaScript code directly. I don't know if you ever used it like that, but I find it quite useful to quickly experiment with some code. So we're going to import the day.js library by requiring the day.js module. Node.js doesn't fully support ES modules yet. That's why we need to use the require function rather than an import statement. But apart from that, we can write regular JavaScript code here. So let's start by creating a variable now. That's the result of calling day.js as a function. If we call day.js without any arguments, it will return an object representing the current time. We can evaluate the variable, and you can see that it's an object with a number of fields, but it's not actually very human readable. So let's print out now to string instead. This looks better. It's the current date and time at the time I recorded this video, of course. Obviously, if you try it yourself, you'll see a different time. Now, we want to work with ISO strings, and there's also a toIsoString method that gives us a string in ISO format. The letter Z at the end means it's in the UTC time zone, in case you wonder, but we don't really need to worry about that. A day.js object also has a format method that we can use to specify a custom format. This works pretty much like the display format we've seen for the IonDateTime component. If we want the day, the short month name, and the year, for example, we can pass this string. So we could use this method to format the date before displaying it to the user. What else can we do? If rather than the current time we want a specific date, we can call day.js passing an argument, and this can be a date in ISO format. Day.js will parse it and build its own date object from it. Another thing we'll need to do when we get to calculating the biorhythms is finding the difference between two dates. So let's look at that. We still have our variable now that we can print out again. And this has not just the date, but the time as well. Ideally, we want the date without the time being 1742. We can use the startOf method and pass an argument saying the start of what. So startOf day should give us the same date, but with the time set to 0. This will be useful for our calculations. In fact, let's assign that to a variable called today, that is now, but at the start of the day. We can also manipulate a date by adding, for example, one day to it. And the result should be the 19th of February, because today is the 18th of February. Of course, we can add more than one day, and the second argument can be days in plural. It works in the same way. We can even add a negative number of days if we want to. Alternatively, we could use this subtract method. Finally, let's see how to calculate the difference between two dates. Suppose we have a date representing a month ago. So that would be, since today is the 18th of February, a month ago was the 18th of January. Let's print it out, just to show it's been parsed correctly. Now we can take today, that's the variable we defined earlier, and calculate the difference compared to a month ago. And we need to pass a second argument specifying which unit to use. And in this case, we want the number of days. The result is 31, which of course is correct because a month that includes the end of January has 31 days. To calculate biorhythms, we'll need the difference between the date of birth and the target date, so this method will come in handy. Okay, let's stop here for this interactive session and go and restart the React development server. We can now use this day.js library in our application code. The dev server is up and running. Let's focus on our code again. We want to format the date displayed in the biorhythm card, so let's go and add day.js here. We want to import day.js from the day.js module. And then we can add a function, let's call it formatDate, where we take a date as an ISO string and return what? We want to first pass the ISO string into a day.js object, then we can call the format method and pass a format string with day, month, and year. I'm using exactly the same string I used for the Ion datetime component. So the user will see all dates in the same format. Now we can simply use this new function to format the target date displayed in the card title. And if we apply these changes, we can see in the browser that the date is a lot more readable now. So that's it for this video. What we've done shows that we can add pretty much any JavaScript library we want to our Ionic project. But especially when developing mobile apps, it's important to be aware of how much weight each additional library adds to your project. That's one reason why we chose day.js for this example, because it's so small. And incidentally, if you want to learn more about day.js, you can just look at its docs, of course. The homepage is day.js.org. We're using day.js to format the target date that we display in the biorhythm card. It's now time for us to calculate some actual biorhythm results rather than displaying those mock numbers. So let's have a look at the online calculator again. Here we can enter a birth date, say the 1st of January 1995. We can leave the target date to be today's date, click execute, and we get some numbers representing the physical, emotional, and intellectual biorhythms. We want to do the same in our app. So how can we calculate those numbers? If we look at the Wikipedia page, there's a calculation section where we can find some formulas. We'll basically need to translate these mathematical functions into JavaScript code. We'll come back to these formulas once we are ready to write the code. Let's set things up in the editor first. Let's add a new file at the same level as app.js. Let's call it calculations.js. And here we want to write a function to calculate a biorhythm. As parameters, we'll need the birth date and the target date. We'll return a number. Let's start by always returning 0. So this is just the stub of our function. Let's export it as well so we can use it in other files. Now we could go on and write the implementation by translating those formulas we found on the Wikipedia page. But how will we know if our code is correct? How can we be sure that the number we're calculating is actually the right one and we didn't make a mistake somewhere? For this sort of functionality, it would be really useful to write some unit tests. So that's what we're going to do now. Let's save this file as it is and go and create a new file called calculations.test.js. Here we'll write the unit tests for the code in calculations.js. Now remember that this project was initially generated with Create React App, so the way it works for running tests is exactly as documented in the Create React App pages. In particular, it uses the Jest framework for the tests. We'll see how to write the test in a minute. Let's think about our test cases first. We are lucky to already have an online calculator that we can use as a reference. So we can say that we expect our code to produce the same results as this online calculator. In particular, if we calculate the physical biorhythm for somebody born on the 1st of January 1995 and for the target date of the 18th of February 2020, then we should get 0.5196. So that's our first test case. Let's go and write this into code. To begin with, we need to import the function we want to test from our new calculations module, and the function is calculate biorhythm. Then we can define a new test using the it function that's part of the Jest API. Here we pass a description of what this test verifies, and we're calculating a biorhythm. Then we pass a function with the actual test code. And here we want to get the result by calling the calculate biorhythm function. We need to pass it 2 dates, and we want to use exactly the same dates we used in the online calculator. So the birth date was 1995-0101, this is in ISO format, and the target date is 2020-02-18, right? Now we expect the result to equal the number we got in the online calculator. So let's copy the number for the physical biorhythm, and we expect our result to be exactly the same. This way we'll know for sure if our code works correctly or not. Now, to run this test, we need to open a terminal. I'll stop the dev server, but you could also leave it running and open a different terminal if you want. Anyway, we can type npm test to start the test runner. If we look at the output, there's one test failing, and you can see that it gives you a very detailed explanation of why the test failed. In particular, we expected 0.5196, but we received a result of 0. Now, the test runner runs continuously by default, so we can keep editing our code, and as soon as we save some changes, the tests will automatically rerun. We can now go and implement the actual calculation to make the test pass. So let's go and have a look at the formulas again. These formulas all use a variable named t, thus defined below as the number of days since birth. So that's the first thing we need to calculate, the difference between the birth and target dates. We can import our nice little day.js library to help us with date calculations. And in this function, remember that we received the birth date and target date arguments as ISO strings. So first we need to parse them into day.js date objects by passing the ISO string to the day.js function. And I'm also going to use the startOf method to make sure we get the time at the start of the day, because we only want to work with whole days, not hours or minutes. Let's do the same for the target date as well. Pass it into a day.js object and take the startOf day. Now we're in a position to calculate the difference between the target day and the birth day, calculated in number of days. So we have the difference. Now let's look at the rest of the formula. If we look at the physical biorhythm, we need to take t, that is the difference in days, multiply it by 2 times pi, then divide it by 23, and finally apply the sine function to the result. Let's see how we can translate all this into JavaScript code. The sine function is available as math.sine. Then we want 2 times the pi constant times the number of days since birth that we called diff, and divided by 23. Is that correct? Well, we just need to save this file and the test will tell us. The test is failing. Let's go and check why. It failed because we were expecting 0.5196, but we got 0.519583 and many more digits. So actually the two numbers are pretty close. It's just that the expected result we copied from the online calculator is probably being rounded to 4 decimal places. This is a common problem when comparing floating point numbers. Let's see how we can tweak our test to be a bit more lenient when comparing numbers. Instead of to equal, we can use to be close to. So we're basically saying it's okay if there's a very small difference between the expected and actual numbers. And if we save now, our test is passing. Good. Now, so far, we only calculate the physical biorhythm. We also want the emotional and intellectual ones. We could have 3 different functions, one for each type of biorhythm. But since we're always going to use all 3 of them at once, I'm going to create a new function called calculate biorhythms, plural. And I copied the signature from the other function because we'll still need birth date and target date. Here we're going to return all 3 values at once, so we can return an object with a physical property, that's some number, then emotional, that's another number, and intellectual, again with its own value. So that's the stub of our new function, and we won't be exporting this other function that calculates a single biorhythm. We want external code to only use calculate biorhythms. If we save now, our test will fail because it's still calling the old function. So let's update this test to calculate biorhythms, plural, and the result will be an object that we can destructure to extract just the physical biorhythm for now. That's the one this test is verifying. Now, the test still fails because the received value is 0. Incidentally, note how, since we're using to be close to, there's this additional message saying that the difference must be less than 0.005. That's the default tolerance used by to be close to. Anyway, to make this test pass again, we need to update our calculate biorhythms function to return a real biorhythm value. Now, all biorhythms are calculated using a similar formula, except for this divisor number here that is 23 for the physical biorhythm, but some different values for emotional and intellectual. Let's make this function more generic by passing in this number as a parameter. I'll call it cycle. So we divide by the cycle. And now we can set the physical value by calling calculate biorhythm with the birth date, target date, and the cycle, that is 23. And our test is passing again. All that's left is implement the other 2 biorhythms. But before we do that, we want to create some additional tests to make sure our calculations are correct. So we want a test for the emotional biorhythm, and another one for the intellectual biorhythm. Of course, we'll also need to check for the correct numbers. So let's go back to our online calculator and copy the value for emotional, paste it as the expected value of our second test, and then repeat the exercise for the intellectual value as well. This is 0.8 something. Save, and 2 tests are failing, 1 passed. This is expected. If we check the details, the physical biorhythm is green, emotional and intellectual are red. That's just because we haven't finished our implementation yet. Back to our calculations. The emotional biorhythm will be calculated exactly like the physical one, except that the cycle is 28 days. You can look this up in the Wikipedia page. Ditto for the intellectual biorhythm that cycles every 33 days. If we're lucky, this should fix all the tests. Yes, it does. And thanks to these tests, we can be confident that the numbers we calculate are actually correct. We can run these tests again at any time to make sure we don't break something when we make changes to our code. And it's an automated process, meaning that we don't have to start the application and test it manually by interacting with it in the browser. Writing unit tests is a very good practice, and I strongly encourage you to try it if you're not doing it already. We won't actually write many tests in the rest of the course because it does take time and there are many other things we want to learn about Ionic. But I wanted to show you that you can absolutely write unit tests in an Ionic app, just like with any other React app. Okay, we wrote the logic to calculate the biorhythms, and we have some tests to verify that the logic is correct. Now let's go and display these biorhythms in the user interface. I'm going to stop the test runner with Ctrl+C and then start the React development server again. We don't need these tests anymore, and I'll just rearrange these windows a little bit while the dev server starts up. Okay, now that it's up and running, we want to display the biorhythm results in the biorhythm card. So in this component, we can import the function to calculate the biorhythms, and it's in calculations.js that's in the source folder. So it's in the parent folder compared to where components are. And the function is calculate biorhythms. Now we can call this function before rendering the user interface. And here we need to pass the birth date, but we don't have it in this component, so let's add it to our props. Let's update the app component as well straight away. Here we already have the birth date, we just need to pass it as an additional prop to biorhythm card and save this change. Now we can pass this birth date to calculate biorhythms along with the target date. And what we get as a result is an object from which we can extract the physical, emotional, and intellectual properties. Okay, now that we have the numbers, we just need to display them, starting with physical, then do the same for emotional, and finally intellectual. Alright, let's see if this works. Interestingly, all the biorhythms now show none, that is, not a number. This means the calculation failed, and that's because we haven't entered a date of birth yet. We'll need to fix this scenario, but let's try selecting a date now and see what happens in that case. Okay, we see some numbers there. They do have lots of decimal places, and that doesn't look great from a UI point of view. So let's go and change that. We can use the toFixed method on a JavaScript number to limit the decimal places displayed. And we can show 4 of them, like the online calculator we used as a reference. Alright, let's try again. I'll just pick a random date. And it looks better now with 4 decimal places. Okay, we still need to handle the case where there is no date of birth yet. We don't want to display not a number to our users. I think the best way to avoid this situation is not to display the result card at all until the user has selected a date. So let's go and do that. The app component is where we include the biorhythm card. Here we can simply display the card conditionally based on the value of birth date. If birth date is truthy, which means it's not an empty string, then we display the biorhythm card. Okay, let's try this out. There's no card anymore, but if we select a date, then we see the card with the biorhythms. Good. I wonder if it actually looks nicer if we show the card above the date. Let's give it a try. I'll just move these lines above the ion item with the date field, and we'll find out. Again, there's no card initially, but after we select a date, we see the card at the top. I think it's better this way, because the user only needs to enter their date of birth once. After that, they'll just be interested in seeing the biorhythms, so it makes sense to display those first. All right, I'll leave you with a simple exercise. At the moment, we're always using today as the target date. It would be nice to let the user select a different target date, like in the online calculator we've seen. You can try and do that yourself if you like. In any case, we'll see the solution in the next video. I left you with a small challenge, that is adding another field to let the user enter a different target date. So let's see how to do that. I'm actually going to change the position of this label to fixed, because the date is always a short string. There's no risk of it taking up too much space. But this was just an optional step. Now let's go and add another field. We can start by just copying and pasting the existing ion item block. Then we want to change the label to say target date. Next, we'll need to modify this event handler. We actually need to change this target date to be a state variable, like birth date. So we'll call the useState hook. Now, as the initial value, we may still want to use the current date, because it's a good default. If the user wants to see the biorhythms for today, they don't need to select a different date. Now we can use the target date variable as the value of the ion date time. And instead of set birth date, here we want set target date. That's pretty much it. We now have two fields for the two dates. If we pick a date of birth, let's change the year. We see the biorhythms for today. But if I want to know what my biorhythms will be next week, for example, then I can select a different target date and see some different results. All right, that was pretty straightforward. In this video, we'll see how to use local storage to save small amounts of data in the client. At the moment, our user can select their date of birth and see today's biorhythms, but if they open our app again tomorrow, they'll need to enter their date of birth again. That's quite annoying, because somebody's date of birth is always the same, of course. It would be nice for our app to remember it. The app component is where we capture the birth date. Could we store it somewhere so it persists across page reloads? The simplest way to store some data in a web browser is to use the local storage API. In the DevTools, we can see the local storage here. Each domain has its own storage that contains key value pairs, although this one is empty at the moment. Let's quickly see how to use it in the JavaScript console. There's a global object called local storage, and we can call the setItem method to save a value. For example, we could save something under the myVar key with a value of myValue. If we inspect local storage now, you can see that this time there is a row with myVar as the key and myValue as the value. To retrieve that value, we simply write local storage getItem, passing the key that is myVar, and we get myValue as the result. So local storage is very easy to use and it's convenient for storing simple values. Now let me clear this test value and we can see how to use it in our own application. What we want to do is remember the date of birth entered by the user. Now, we could use the local storage API directly in this app component, but it's better if we keep that kind of logic separate. At the moment, we use the useState hook to keep the birth date in the component state. Wouldn't it be nice if we had a React hook that works like useState, but also saves the value to local storage? Well, that's exactly what we're going to do. We'll write our own custom hook. Let's create a new file called hooks.js. Here we're going to import the useState hook from React, because our own hook will be based on useState but add some more functionality on top of it. Now, a custom React hook is simply a function with a name that by convention starts with use. Our hook keeps values in local storage, so let's call it useLocalStorage. When using this hook, we want to pass a key, that's the local storage key for the item, and then we can pass a default value, that is the value to use if there is nothing stored in local storage yet. Now, we want our hook to be used just like useState, except for the extra key parameter. So let's start by simply wrapping the functionality provided by useState. We call useState passing the default value, and we return an array with the current value and a function to update the value, just like useState. If we save this file, we can go to app.js, import our custom hook, that is useLocalStorage, from hooks in the same folder. And now we can use useLocalStorage pretty much in the same way as useState. So we can replace useState with useLocalStorage. The only difference is that we need to pass an extra argument that is the key to use when saving the value to local storage. And we can call it birth date. If we save at this point, our application should work exactly as before, because our custom hook just calls useState at the moment. We can set a date of birth, but it gets reset if we reload the page. Now let's finish our custom hook implementation. In addition to calling useState, we want to persist the value. That means that our initial value will be the value we read from local storage under the given key. So if we previously saved a value, we'll use that one. But what if we haven't saved anything yet? In that case, getItem returns null, as it says in its documentation. So in that case, we'll use the default value supplied as an argument to our hook. The double question mark is the nullish coalescing operator if you haven't used it before. It means if the previous expression is null or undefined, then use the second expression. So this is the initial value we want to pass to useState. If there was a value saved in local storage, then we'll use that one. Next, we'll need to actually save the value to local storage somehow. And to do that, we'll need our own function. Let's call it setAndStoreValue. Here we take the new value and we call setValue, that is the function returned by useState, so it will update the value in the component state. But additionally, we save the value into local storage by calling setItem with the key and the new value. At this point, we can return our own setAndStoreValue function. So whenever the component code calls this setter function, we'll do whatever useState does, but also save it to local storage. Okay, let's save everything and go and test if it works. If we select a date of birth, I'll just pick a random year. We see the selected date in the input box as usual. But if we go and look at the local storage, we can see our selected date under the birth date key. So it's also being saved. Let's show the console again. And let's see what happens if we reload the page. It remembered the date of birth we previously selected. So that's working as expected. Let's try selecting another date as well. So we have the 25th of May now. And if we reload the app, it's still the 25th of May. Good. It's nice not to have to enter the date of birth every time, even just for development. There's just one more thing I need to mention. At the moment, this code is reading from local storage every time this hook is called, which typically means every time the component is re-rendered. This is not ideal. It would be better to read from local storage only once. We can do that by turning our initial value into a function that returns the value. Let's change the name as well to make it clearer that it's a function. So when we call useState, instead of a value, we can pass a function. And this way, useState will only call the function once when it initializes a value for a component, rather than every time the component is re-rendered. This is just to make our code more efficient. Let's do another quick test to make sure everything still works. If we refresh the page, the date of birth is still there. Okay, so what we've seen in this video shows two things really. First, we can use local storage if we need to store small amounts of data in our application. And second, we can write custom hooks to keep reusable logic outside of UI components. We wrote a custom hook to save the birth date into local storage so it persists across app reloads. And with this feature, our app is fairly functional. It does show the biorhythms, which is its purpose. It doesn't force the user to enter their date of birth every time, but it still looks quite bland. If we take a look at the online calculator again, you can see that it also shows a graph plotting the biorhythms over some time. Could we do the same in our own app? Well, if we look at the Ionic documentation, there's actually nothing about drawing charts. Ionic does not have a chart component or similar. But that's not a problem. Since ultimately we are working with regular web technologies, we can use any charting library designed for the web, like D3.js, for example. For this project, we're going to use Recharts, that is a library for React based on some D3.js modules. If we look at the examples, the first one is a simple line chart that already shows pretty much all the features we need to plot a biorhythms chart. So let's go and see how to use recharts in our application. As usual, we'll first need to install an npm package. So let's stop the dev server and run npm install recharts. Now we have recharts in our project. Let's start the dev server again, which takes a little while. Okay, now let's go back to our code. Let me just rearrange the editor. We want to display a chart inside this biorhythm card component. But drawing a chart requires a fair amount of code, so let's create a separate component. Let's call it biorhythm chart. And this will be a React function component, so I'll use my snippet to generate the initial code. Now we can go and import this into our biorhythm card. So import biorhythm chart from the module with the same name. And we can insert this biorhythm chart inside the Ion card content element. If we save these changes now, we can see the biorhythms chart's placeholder above the physical, emotional, and intellectual numbers. Now let's go back to our biorhythm chart. And here we'll need to import quite a few components from Richards. The first thing we need is a responsive container. As the name suggests, this is just a container, and we want to wrap everything in it. What it does is it allows to specify some dimensions. So we can say we want the chart to take up the full width of the page. As for the height, let's set it to 200 pixels. Next, we want to add the actual chart, that is a line chart component, and put it inside the container. If we save at this point, we should see that the chart is taking up some space in the page, even though it's still all blank. To actually draw something, we'll need some data, and let's start by creating some mock data. It's important to understand how to structure this data before we try to use it with real biorhythm values. So data is an array that will contain one object for each data point. And in our case, we want each object to contain these biorhythm properties. So let's copy and paste them into our data. But of course, we'll also need some values for each of these properties. So I'll just make up some numbers for physical, emotional, and intellectual. Now, this is just one data point, but to draw a line, we'll need more than one point. So let's duplicate these objects and put some different numbers for the second data point, and same for the last one. We want different values, otherwise we'll just see a flat line. Also, each object in this array represents the biorhythms for a different day, so we'll need to calculate the biorhythms for multiple days to display the chart. Okay, so we have some data. Now we can pass it as a prop to line chart. The prop is called data as well. Next, we want to draw a line, and I'll auto-import this component from Richards. We need to tell this line which property of our data elements to display. That's a prop called data key. For example, each object in our data has a physical property, so we can tell this line to plot the physical values. And if we save this file, we should see a line on the screen. The 3 points on that line correspond to the physical values in our data, that are 0.99, 0.37, and minus 0.10. Okay, in the same way, we can add another 2 lines to plot the emotional and intellectual values, and we should see 3 lines on the screen. However, it's not easy to tell which line is which, because they all have the same color. So let's add some styling. We can set the stroke attribute with a color to use for this line. Let's use green for physical, red for the emotional line, and intellectual will be blue. Let's see how it looks now. That's a lot better. So this is good progress. We have 3 lines for our 3 biorhythms. Let's add some more elements to the chart. We may want to draw an x-axis. That means a horizontal line at the base. Let's see what it looks like. We can see the x-axis, and it shows 3 ticks with 0, 1, and 2. Now, where do those numbers come from? Well, 0, 1, and 2 are simply the indexes of each element in the array. If we want to display something more meaningful, then we need to add another property to our data. In our case, we probably want a date property representing the day for which the values in each object were calculated. Obviously, each element will have a different date. Once we have such a property, that won't make any immediate change, but we can tell the x-axis to use the date as its data key. And now we should hopefully see the dates on the horizontal axis. We just see the last date actually, but I think that's just because there's not enough space on the screen. If we have a larger page, then we should see the other dates as well. Well, at least we see two of them now. Anyway, we'll tweak the appearance later. Let's stop here for this video. We've seen how to use recharts to draw a line chart. We are using some mock data at the moment, but in the next video we'll make it work with the real biorhythm values. So we have an initial chart with 3 lines showing the biorhythms over time, but at the moment we're just using mock data. It's time to think about how we can display real biorhythm values. If we look at our calculations file, here we have a function called calculate biorhythms that returns the physical, emotional, and intellectual values for a single target date. For the chart, we'll need another function that returns the biorhythms for multiple days. Let's call it calculate biorhythm series. And instead of passing a single target date, we could pass a start date along with a size parameter, meaning the size of the series or how many days to return. So in this function, we basically need to call calculate biorhythms repeatedly for every day between the start date and size days afterwards. And we'll want to aggregate all the results into an array. That is what we return from this function. So this series array should have the same structure as the mock data we used in our chart so far, but with real values. Now, to process multiple days, we want to begin with a start day, that is the start date isostring converted into a day.js object. And we may also want to take the start of the day to remove any possible time part from the date. Next, we want to iterate with an index variable that goes from 0 to size, incrementing by 1. Now we can calculate each target day, that will be the start day, plus I days, using the add method we've seen when we first looked at the day.js library. Now that we have the target day, we can calculate the biorhythms for that day by calling our calculate biorhythms function. And here we need to pass the birth date and the target date. But the target date should be an isostring, not a day.js object. So let's convert this into a target date that's an isostring. Then we can pass it to calculate biorhythms. Now, what do we do with the value returned here? We want to add it to the series array. This way, our series should contain one object for each day with the physical, emotional, and intellectual biorhythm values. Let's save and go and use this function in the biorhythm chart component. We need to import the new function first, that is calculate biorhythm series from /calculations because it's in the parent folder, and we can call this function before rendering the component. However, we'll also need some props here, because at the moment we don't have the birth date and the target date that we'll need to pass as arguments to calculate the biorhythms. Now, we'll also need to pass these props down from the biorhythm card. Here we already have the birth date, so let's pass it down to biorhythm chart and then do the same for the target date. Let's save this file and go back to the chart. So now that we have the dates, we can call calculate biorhythm series passing the birth date, and we cannot pass the target date as it is actually. We'll need to calculate a start date. So let's import the day.js library, and then we can use it to calculate a start date. Here we want to parse the target date. Now, let's say we want a series of biorhythms that covers about a month, and the target date will be at the center of this period. So what we can do is subtract, say, 15 days from the target date, because we want to take a period that starts 15 days before the target date and ends 15 days after the target date. We also want the start date to be an ISO string so we can pass it to our function. And finally, we need to pass the size of our data series. Now, we said we want 15 days before the target date, 15 days after, plus the target date itself. That makes it 31 days in total. So we'll get back an array with 31 elements, and this will be the data for our chart, which means we can now remove the mock data we created just to learn how to use recharts. All right, it's time to save and see what happens. That's pretty good. We can clearly see the biorhythm waves. There are a few things we can improve. For example, it may be better to show just the lines without all those dots. We can easily remove the dots by setting dot to false on every line element. That's cleaner. I don't know how well you can see it in the video, but it seems to me the lines are not very smooth. I can notice a small angle at the top of the green curve, for example. We can make the line smoother by setting the type attribute, and natural is one of the options. They should make the curve smoother by using interpolation. Looks good. Let me just split this code into separate lines and collapse the imports as well. Now, there's something missing in our chart. If you look at the x-axis, there are no labels. We used to show the dates there, but the data we're returning at the moment doesn't have dates. Each object only has physical, emotional, and intellectual properties. So let's add a date that can be the same target date passed as argument. All right, let's save and see what happens now. There is one date on the x-axis, but it's only the last one. Also, it's displayed as the full ISO string. So first of all, we want to format those dates in a nicer way. Let's write a function to format the date. Here we take the ISO string and we return the same date, but formatted with day.js. Let's just show the day and the month. We want to keep it short because it will be displayed on the x-axis, so I'll leave the year out. Now we can take the array returned by calculate biorhythm series and transform each item using the map function. We want to return an object with all the same properties as the original item, but overriding the date property to be the original date but formatted with our new function. Right, let's see what this does. Okay, we can see a few dates on the horizontal axis now, and they are short and readable. Something else we could do is show a vertical line over the target date, because at the moment it's not that clear when looking at the chart where today's date is. We can do that by adding another recharts element that's called a reference line. And on this component we can set an x attribute, which means at which point on the x-axis we want to draw this line. Here we can take the central element in our data array. Remember that the array has 31 elements centered around the target date, so the 15th element corresponds to the target date itself. And we want to take the date property of that element, because the date is the data key of the x-axis, so we need to use the same property for the reference line. If we save now, we can see a vertical line in the middle of the chart. So that's where the target date is, and it lets the user see where they are with their biorhythms. It's just a shame that the dates on the x-axis don't include the 19th of February, that is the target date. But we can change that as well if we want to. All those indicators displayed on the x-axis are called ticks. And if we don't like what recharts does by default, we can explicitly pass an array with the points where we want to show a tick. So if here we pass a single element with the date of the object at index 15, like for the reference line, then we see a single tick with the label 19th of February. That's good, but it would be nice to show some other dates as well, otherwise it's not clear which period of time is covered by the chart. So we could display the first date and the last date. The last index is 30 because the size is 31, but array indexes are 0 based. Okay, let's try this way. Now we can see the last date, but not the first one. I guess we need to pick an index that's not the very first, otherwise there's not enough room on the left side for recharts to show the label. Let's try with index 3, that is the fourth element. And to keep the symmetry, we may want to subtract 3 from this index, so take the fourth from the end. Okay, that looks good. At least now we get an idea of the time period displayed in the chart. As a final touch, I want to add a Cartesian grid component, which you'll see in a second what it does. It's easier to show than to explain. So it's a grid of lines. But actually, I don't want the vertical lines, so let's set vertical to false. Also, I'd like them to be dashed lines, so I'll set stroke dash array to 3, 3, which means draw the line for 3 pixels, then skip 3 pixels and repeat. Okay, I think this looks pretty good now. The Cartesian grid makes it easier to see the biorhythm values. The top line is 1, the middle is 0, and the bottom is -1. So for example, you can see that the blue line on the 19th of February has a value slightly above -0.5. Of course, we can also change the target date if we want to see what our biorhythms will be in a few days. And you can see that the chart updates with a nice animation effect, where the lines appear to move into their new position. Let's do a final test to make sure the chart looks good in an Android device with a small screen and on an iOS device as well. Okay, that's our nice biorhythm chart done. It was a bit of a long video, but I hope you enjoyed it. Drawing charts is a fairly common requirement. Here we plotted some biorhythms, but you could follow similar steps to create revenue or price graphs or many kinds of business graphics. All right, we have a nice chart showing the 3 biorhythm lines over time. However, at the moment it's not easy to tell which line is which, because each line has a different color, but the text below with the biorhythm values is all in gray. We could write each row of text in the same color as the corresponding line in the chart. For example, since in the biorhythm chart the line for the emotional biorhythm uses a red stroke, we could use red for the text with the emotional value as well. The quick and dirty way to do that would be to add an inline style and just set the color of this paragraph to red like this. This works, but using inline styles is not a good practice, because this way our styles are not reusable on other elements. A better approach is to add a CSS class to this element. Let's call it emotional. But then we'll need to write some CSS rules somewhere. So how does that work exactly? Remember that our project was initially generated with Create React App. So the Create React App documentation applies here. If we look at styles and assets, there's a page about adding a style sheet. Basically, we can just write a CSS file, import it into the component file, and make sure the class name matches the rules. But this is not the only option. We could also use CSS modules that will ensure all the styles are locally scoped to our component. In this case, you import the styles from a module.css file as a JavaScript object. And in addition to plain CSS, you can also use the Sass preprocessor if you like, that is SCSS files. Now, I won't go into the details of each possible approach because this stuff applies to all React apps, not just Ionic. But I wanted to make you aware of the options so you can read more in this documentation if you like. For our project, we'll use the simplest approach, that is regular CSS files. So let's go back to our application. And we want to add some styles for the biorhythm card component. So let's create a new file called biorhythmcard.css. Then we need to import this new CSS file in the component. So import biorhythmcard.css. Note how for CSS files we need to specify the extension, unlike for JavaScript files. Now we can save this, and in the CSS file we can add some styles. In the component code we use the class called emotional, so let's add a CSS selector matching that class. And here we can simply set the text color to red. If we save, the text with emotional turns red. So that works. Now, the risk with this approach is that this rule will match any elements with an emotional CSS class anywhere in our application, not just inside the biorhythm card component. For this small application, it's unlikely to actually be an issue. But one way to avoid that problem is to wrap the entire component in a CSS class with the same name as the component itself, and then use this class in all the CSS rules for this component. Personally, I prefer changing the class name to use the same case style as the other CSS classes, but that's not strictly necessary. Now, once we have this class on the root element of this component, we can modify our CSS selector to match only elements with the emotional class that are inside the element with class biorhythmcard. And the result is the same. But like I said, this makes it less likely that you accidentally apply a style to some other component in another part of the app. Now, since we are dealing with CSS, we can use the Chrome Developer Tools to inspect the styles on our page. If we use the inspection tool, we can select the paragraph we're interested in, and we can see that it has class emotional, and it's matching the CSS rule we just defined, so the color red is applied. Incidentally, we're not limited to adding our own styles. We can also override some of the Ionic styles if we want to. For example, there's maybe a bit too much space at the moment between each line of the text inside the card. That's because Ionic sets the line height of a paragraph to 1.5 when it's inside a card content. We can change that by defining our own rule, saying that for p elements inside a biorhythm card, the line height should be normal. And if we save, there's less spacing between each line of text now. So we can easily override any Ionic style because it's all done using CSS at the end of the day. Also, this example shows the advantage of wrapping the component in its own CSS class. Without the biorhythm card class, this new rule would apply to all paragraphs anywhere in the app, which is probably not what we want. Anyway, let's go and finish styling our biorhythm values. In addition to emotional, we have a physical biorhythm, and to match the chart, this should be green. Then we want an intellectual class with the color set to blue. Note that nothing changed after we saved. That's because we only added the CSS class to the emotional paragraph so far. Let's do the same for the other two paragraphs and change the class names accordingly. Let's save, and we should see the right colors everywhere. Good. Now you can clearly tell which line in the chart corresponds to which biorhythm. And this serves as a simple example of how to add some styling to a specific component. In the previous step, we added some styling so that the text displayed below the chart matches the colors used for drawing the lines in the chart, like red for the emotional biorhythm. However, now we have this situation where we're using CSS for styling the text, but for the chart line, we're applying the color directly in the component code. Could we style the chart line using CSS as well? Let's use the dev tools to inspect the chart line. Inside the Ion card content, there's a div with class Richard's responsive container. And if we look inside, there's another wrapper div, and then there's an SVG element. So the chart is drawn using SVG, or Scalable Vector Graphics. Inside the SVG, we can see some elements with class Richard's line. So these correspond to the line components in our code. The tag of these elements is G, which is an SVG group. Now, if we expand the second Richard's line, that should be the emotional one, the group contains a path, that's what draws the line, and it has stroke set to red. So now that we know the structure of the DOM elements rendered by Richards, we can style them using CSS. Let's add a new file called biorhythmchart.css, and then we want to import this new file into the biorhythm chart component. So let's import biorhythmchart.css. Following the same approach we used for the card component, we want to add a class name to the top-level element with the same name as the component, but all lowercase for consistency. We'll use this class name to limit the scope of our CSS rules. But before we do that, we want to remove the red stroke configuration and replace it with a CSS class. Let's call it emotional like we did in the card component. Now we can use this top-level CSS class in the CSS selector combined with the emotional class. And we want to apply the styles to the path element inside it. If you remember, when we inspected the elements, the line component is rendered as a G element. That's the one that will have our emotional class. But then inside the G, there is a path. That's what actually draws the line. So the path for an emotional line should have the stroke set to red. Now, before I save, notice how in the chart at the moment there is no red line. Since we removed the stroke attribute from the component code, Richards is just using the default color for the line, which seems to be light blue. If I save now, you can immediately see the line becoming red again. Okay, so the style is working, and we could repeat the same process for the other two lines as well, but before we do that, let's think about duplication. At the moment, in the card styles, we set the text color to red, and then in the biorhythm chart style, we set the path stroke to red. So we have the red value in two different places. Since we want the text color to be exactly the same as the line color, it would be nice to define this red in a single place and then reuse it. So what we're going to do is use a CSS variable for that color. Remember that in index.js we import all the Ionic CSS files. We can add our own global CSS file. Let's call it index.css. And we want to import it into index.js, so it will apply to our entire application. In this new style sheet, we can define some CSS variables that apply to the root scope. Remember that CSS variables start with --. Let's call this one emotional color. and its value is red. Maybe we could prefix all our variables and call them app something, just to avoid name conflicts. We know that all Ionic variables start with Ion, so if we use app everywhere, that should make it clear that they're our own custom variables. Now we want to go and use this variable in our biorhythm chart styles. So instead of red, we'll use var and the name of our variable. And if we save, nothing should change. The line should still be red. Okay, now we can do the same for the biorhythm card styles. Instead of using red, we use our emotional color var. And again, the text on the page is still red. Now, to prove that it's actually using the color from our global CSS variable, let's go back to index.css and try selecting a different color. If instead of red, we pick some yellow color, for example, just to make the difference obvious, if we save the new color, you can see that it's applied to both the line in the chart and the text below. So that's working as expected. Now, yellow is obviously a horrible choice, so let's revert it to red. And let's define the other colors as well for the other biorhythms. So we need a physical color, that's green, and then an intellectual color, that is currently blue. Now we need to go and use these variables. Let's start with the card. Replace the physical color and do the same for intellectual as well. Just need to change the name. Finally, we want to repeat the same process for the biorhythm chart as well. Here we still need to write the rules for the other two. Physical will use the physical color, and intellectual will use the intellectual color. Voila! Are we missing something? I think we still need to set some class names in the chart component actually. Let's replace the stroke with the CSS class everywhere and set the appropriate class names. There you go. That should be everything. We now have all the colors in a single place. So maybe we can pick some darker shade of green, for example. It's not that different, but a bit less saturated. We can do the same for the others, just to have some different shades rather than using the basic colors. So that's a darker red, and we can pick a darker shade of blue as well. Okay, I think that's enough. We've seen how to use CSS variables to reuse style values across our application. There are other ways to do that, like using the Sass preprocessor if you're familiar with it, but CSS variables work well enough and don't require extra setup. In the previous section, we developed this biorhythm calculator app. So far, we only ran it locally using the React Webpack server, as we can tell from this log message. WDS stands for Webpack Dev Server. That's great for development, but at some point we'll want to publish this app somewhere so that our users can access it. And that's what we'll look at in this section. We'll see how to deploy this app to a public web server and also how to package it as an Android and iOS app. The first step in all cases is to generate a production build of our web app. Like we said, so far we've been running it in the React development server, and it even tells us the development build is not optimized. To create a production build, use npm run build. So let's do just that. Execute npm run build. And this will create an optimized production build. Optimized means that, for example, it will minify all our JavaScript and CSS code, so it's smaller and faster for the browser to download. After running this command, we'll have a build folder in our project that contains all the static files we can deploy to a web server. There's an index.html, there's a static folder that contains a bunch of JavaScript files, and so on. Now, the build output also says that we can serve the build folder using the serve command. Serve is an npm package that provides a simple HTTP server. We can run it with npx, so it will automatically download it if you don't have it installed already. And we want to serve the build folder. This starts a local HTTP server that's running on port 5000. So let's go and check if this production build works fine. We just need to change the port to 5000. And voila, this is our production app. Of course, it looks the same as our development app, but it should be a little bit faster. Let's try selecting a date of birth and make sure everything works as expected. It all looks good. So this is how we can create a production build. We just run npm run build, and this will generate all the static files into the build folder. Now we could just take this build folder and upload it to a public web server so it's visible to the general public. There are many providers out there where you can host your app. Just for this example, I'll use Netlify that has a very simple user interface and a free plan. But you could use any other solution you like: Amazon Web Services, Google Cloud, DigitalOcean, your own servers if your company has some. Basically anything capable of hosting a static website would do. If you want to try Netlify, you can just click the sign up link, and after providing your details, you should see a page like this where you can manage your sites. One cool feature of Netlify is that you can create a new site from Git. So you'll give it a Git repository and it will automatically deploy your site, including updating it every time you push some changes. But there's also a simpler way to create a site, that is to just drag and drop a folder here. So that's what we're going to do for this example. I'm going to open the build folder in the file manager, then go back to the Netlify dashboard and simply drag the build folder and drop it on the page. This will upload the folder and create a new site for us. At the moment, it says site has not yet been deployed. That's because it's a new site, so it will need to provision some resources, but it shouldn't take too long. Okay, it now says your site is deployed, and we can see the URL for our new site here. It's called affectionatemcnultysomething.netlify.com, so it automatically generated a domain name for our site. Now, Affectionate McNulty is quite a funny name, but maybe we want to choose something simpler. We could set up a custom domain if we want, but for this example, let's see if we can edit the domain settings and go and change the name. Probably under Options, there's Edit Site Name. Instead of this long name, let's see if we can call it Biorhythms. Hopefully it's not already taken by somebody else. That worked. We now have biorhythms.netlify.com. Obviously, if you try yourself, that name won't be available anymore. But if we open biorhythms.netlify.com, we can see our usual app. And note that it's a secure site, so Netlify also provided a certificate for us. Let's give it a quick try. Select a date. And we can see the biorhythms, both the numbers and the graph. Good stuff! So now anybody in the world can open biorhythms.netlify.com in their browser and they'll see our app. This is probably the simplest way to make our app available to our users. Deploy it to a web server and it can be accessed as a regular website. We've seen how to deploy our Biorhythms app as a regular web application. Now we'll talk about how to package it as a native Android and iOS app using Capacitor. Capacitor is a tool recently developed by the Ionic team as a replacement for Apache Cordova. Cordova used to be the tool to use if you wanted to turn your web app into a mobile app, and you can still use Ionic with Cordova as well if you really want to. But Capacitor is now the recommended option. Cordova is a fairly old project and developers frequently complain of various issues when working with it. So the Ionic team decided to create a better tool that's easier to use. Now, how is it possible to take a web app and turn it into a native mobile app? To explain that, I'll give you a very quick insight into native mobile development. If you want to write an Android app, for example, you could use the Android Software Development Kit that provides some native components to build a user interface. So you have a library of UI components that you can use. Let's take a simple button as an example. In Android, you can define your user interface in XML. So you can write a button tag like this, and then you would write some other code in a programming language to add some functionality. For example, here it adds an on-click listener to the button, and this uses the Kotlin language. But you can do the same using Java as well. So that's how you would write your app using the native Android toolkit. But that's not what we want to do. We have a web app written in HTML, CSS, and JavaScript, and somehow we'd like to build it as a mobile app, right? Thankfully, Android provides a component called a web view. And a web view is a component that displays web pages. So it's effectively a web browser that we can incorporate into our own mobile app. If we look at the Apple documentation, on iOS we can also use a web view. It's called a WK web view, where WK stands for WebKit, that is the browser engine. And again, we can use it to display interactive web content, such as for an in-app browser. So on both Android and iOS, we could write a native app that uses a web view to display our web application. And that's essentially what Capacitor does for us. It can generate Android and iOS projects with a small amount of native code that launches a web view and loads our web content onto it. So that's the trick. Now let's see how to use Capacitor in practice. As usual, we'll need to install some npm packages. So let's run npm install, and we want Capacitor core. I'm going to pass the save exact option because I want to make sure we always use a specific version of this package. I'll explain why in a minute. Okay, Capacitor core is installed. Next, we want the Capacitor CLI, or command line interface. And in this case, we can save it as a dev dependency because it's a command line tool. It's not a library that we're going to import into our JavaScript code. That's installed as well. So at this point, we have Capacitor CLI under dev dependencies and Capacitor core under the regular dependencies. And it's important that we use the same version for both these packages, otherwise we may run into issues. That's why we used the save exact flag when doing npm install. Okay, we have some Capacitor packages installed. Now, what do we do with them? Let me expand this terminal because we're going to run some commands here. If we look under node modules, there's a .bin folder that contains executable commands, and the Capacitor CLI package added a capacitor command with a shorter alias called cap. So we have a capacitor command line tool, And the easiest way to use it is with npx that will automatically find it inside the node modules folder. If we run npx capacitor -help, for example, we can see all the usage options. But as we've seen, there's also a shorter command called cap that does exactly the same thing, but saves us some typing. Now, the first thing we want to do is run capacitor init to initialize capacitor in our project. We can find out more about init by running npx cap init -help. And here we can see all the options we can pass to the init command. So let's run npx cap init. Then we can pass a webdir option that, as the help says, is the folder containing our web assets. In our case, we know that our production assets are inside the build folder, as we've seen in the previous video. So we want to pass build as the webdir. Next, there is an npm client switch. This is optional, but we can pass npm here. Alternatively, you could use yarn, but I'm using npm everywhere in this course. More importantly, we need to pass two more arguments that are app name and app ID. As app name, we can pass biorhythms. This is the name of the app that will be displayed to the user, for example, in the launcher menu. Then we need an app ID. That's a string that should uniquely identify our app in the Android or iOS system. And the way to make sure it's unique is to use the reverse domain name convention. Let's say I own the example.org domain. Then I can write org.example, so I'm reversing the domain parts, and add a third part that identifies the app within my domain. So the rule is that you should only use a domain that you own. For example, if you work for, say, Microsoft.com, then all your app IDs should start with com.microsoft. Anyway, this will initialize capacitor inside our project folder. And it's very quick, because all it really does is it creates this capacitor.config.json file. Here it basically saved all the options we passed on the command line, like app ID, app name, and so on. This configuration will be used when we create an Android or an iOS project, as we'll see in the next video, starting with Android. Before we can build our app for Android, we need to install Android Studio. That's the IDE provided by Google for Android development. If you do a Google search for Android Studio, the first result should point you to the right page where you can download the IDE. Now, I must warn you that installing all the Android tools can easily take an hour or even more. So make sure you have enough time available when you go through this video. If you go and click the download link, it should automatically give you the right version for your platform. I'm using macOS, so it offers me the package for Mac, but if you're on Windows or Linux, you should see the appropriate version for your system. If we click the button, we need to accept a license agreement, and then we can proceed with the download. That may take a few minutes. I'll edit this video to jump forward in time. Once we have the package, we can go and open it. Need to wait a little bit for the system to verify the contents. Okay, as is typical on macOS, we can install this application by dragging its icon onto the Applications folder. If you're using Windows or Linux, the installation process will be slightly different, but you basically just need to follow the instructions provided by the installer wizard. Okay, once it's finished, we can close this window, open Launchpad, search for Android, and that's the Android Studio application. So I can click on it to open it. If you're on Windows or Linux, you can open it from the System menu or maybe from an icon on your desktop, just like any other application. We need to tell macOS that we do trust this app, and we should see Android Studio booting up. The first time you launch it, it may take a little longer to start. And when it does show up, it's telling us that we need to install some more stuff. We need the Android SDK or Software Development Kit. So let's click Next. Here we can customize the install location if we want, but it's fine to accept the default. Let's move on. This screen shows a summary of all the things it's going to download, and it may be worth having a look at these components. There's the Android emulator, some build tools, the Android platform, which means all the libraries required for building Android apps, the platform tools, and a couple more things. We'll look at these components again after they've been installed. Now let's go ahead and click Finish and wait for it to download a lot of stuff. You may want to get yourself some tea or coffee while you wait. All right, sometime later, once it's done downloading and installing everything, we can click the Finish button and finally see the Android Studio welcome screen. Now, if you select Start a new Android Studio project, this will create a new native app using Kotlin or Java as the programming language. But that's not what we want. We'll see later on how to use Capacitor to generate an Android project for us. Right now, I want to show you that under the Configure menu, there is an item called SDK Manager. This is where we can see which SDK components are installed. And it's also useful because from time to time, we may need to update the versions of these components. So here we can see that we have one SDK platform installed, that is Android 10.0, also known as Android Q, also known as API Level 29. So there are multiple ways to refer to the same Android version, but they all effectively mean the same thing. At the time of recording this video, Android 10 or Q is the latest stable version, while Android R is still in preview. So I'll be using Android 10 as the platform. Now, if we look at the SDK tools, here there are a few more components installed. We have some platform tools, the Android emulator, and build tools is partially selected. If we go and enable Show Package Details, we can see that there are many versions of build tools, and what's been installed is basically the latest stable version. We don't need to worry too much about exactly what each package does, but it's good to open this SDK Manager from time to time, check if there are updates available, and install any updates, as long as they are stable versions at least. Now, let me go back to the SDK Platforms tab. Here we've seen that we have Android 10, but there are many other versions available. If you want to find out all the Android versions ever released, you can Google Android build versions, and you should find a page in the Android documentation with a table listing all the versions. Here you can see that each version has a code name, a version number, and an API level. This is important because when developing an Android app, we need to decide what's the minimum version of Android we're going to support. If you look at the Capacitor documentation, for example, it says that it supports API 21 or greater. So looking at this table, we can tell that API 21 means Android 5.0, codename Lollipop. In other words, an Ionic app built with Capacitor will work on most Android devices, except those using very old versions. Anyway, back to Android Studio. We can close the SDK Manager now. And in the next video, we'll see how to set up the Android emulator. In the previous step, we installed Android Studio. Now we'll see how to use the Android emulator that lets us run a virtual Android device directly on our computer. If you have a real Android phone, you can also use that one for development without running the emulator, and we'll see how to do that later on in this section. But it's still useful to know how to use the emulator if you want to test your app on a different Android version, for example. Now, if we open the Configure menu, in addition to the SDK manager, there's also an AVD manager. AVD stands for Android Virtual Device, so each AVD is basically a virtual machine. We can create a virtual device by clicking this button, and the first step is to select the hardware model, meaning which phone type we want to emulate. And there are a number of predefined options here, like Pixel 3, Pixel 2, Nexus S, and so on. Each model has a different screen resolution, density, and so on. You can choose any one you like, but I recommend using one that has the Play Store enabled. Pixel 2 is the default selection, so let's just use that one. The next step is to select a system image. That's like the operating system of a virtual machine. And it basically means which Android version we want to use. As we've seen before, Android Q is the latest stable version, also called Android 10.0 or API level 29. So let's use that one. But before we can actually use it, we need to download it. And to download it, we need to accept another license. This system image is 1.1 gigabytes, so it will take a few minutes to download. When it's finished, we can continue with the creation of our new virtual device. So we selected the Android Q system image that is now installed. We can click Next, and here we can customize the device configuration if we like. The configuration includes things like the amount of memory, screen size, and so on. But we can simply accept the defaults and proceed with creating the virtual device. That's fairly quick. We can see our new Pixel 2 under Your Virtual Devices. And we can start it by clicking this play icon here. This will launch the emulator with our selected virtual device. After a while, we'll see this virtual phone appearing, but it will take some more time to boot the operating system inside the phone, especially the first time we run it. At some point, the Android system should be up and running, and we can use it just like a real Android phone. Open the launcher menu, go back to the home screen, and so on. Since it is just like a new phone and it's the first time we run it, it's also doing some setup tasks, so it's better if we wait until it's finished updating stuff. Okay, now we can complete the setup by going through this wizard. Need to wait a bit more. We don't need to copy any data from a previous device. We can skip the sign up as well. You can do it if you like, but it's not strictly required. We don't need a screen lock either. Nobody is going to steal a virtual device. And hopefully this should be the last screen. Finishing touches. Done. Now let's check the notifications again. We can set up a virtual SD card as well. We can use it as phone storage, and it needs to be formatted. Most phones have an SD card, so it may be useful to have one for testing. Do we want to move some content to the SD card? Why not? Doesn't really matter. And we're done. So that should be it. Let's clear all the notifications. And let's try opening Google Play. It's actually still installing updates here. I'm going to stop it and open the updates from here because I suspect it was stuck for some reason. There are 17 apps that need updating. Let's update them all and give it a few more minutes. Okay, it should finally be completely up to date. It's a bit annoying to set up everything, but it only needs to be done once. If we want to turn it off, we can hold the power button down, like on a real phone, and then tap power off. It should shut down in a second. Okay, so we'll be using this Android virtual device to test our apps. Now, if you want to, you can obviously create more than one virtual device. For example, if you want to make sure that your app works with older Android versions as well, you could create a virtual device running, say, Android 5.0 and test your app in the emulator, which is easier than finding an old phone that runs exactly that version of Android. Alright, now that we have all the Android development tools set up and configured, we can finally build and run our app on Android. Here in our project, we already installed Capacitor. The next step is to tell Capacitor to create an Android project for our app. Before we can do that, we need a production build, which can be generated with npm run build. But we've done that already in this project, so we can go on and tell Capacitor to add support for Android by running npx cap add Android. This will take a minute or two. Okay, once that's finished, we can see that it added a new dependency called Capacitor Android. Now, it's always better to pin this dependency. So remove the caret that means 2.0.0 or above and requires specifically 2.0.0. Of course, you can use whatever the latest version is, but make sure that it's the same as Capacitor Core and Capacitor CLI, otherwise you can run into compatibility issues. Okay? Other than this dependency, Capacitor added an Android folder to our project. This contains a full Android project that can be opened in Android Studio, as we see in a minute. And then there's also a .gradle folder. Gradle is a Java build tool. It's a bit like npm, but for Java projects and Android projects as well. Anyway, if we go back to our terminal, you can see that the output from the last command we ran says you can run npx cap open Android to launch Android Studio. So let's do exactly that. npx cap open Android. And this opens Android Studio, showing our new Android project. It's exactly the same thing as launching Android Studio manually and opening the Android folder that's inside our project. Now, notice that there are some background tasks running here. It's a good idea to wait for them to finish, since it's the first time we open this project. At some point, you may see this pop-up saying plugin upgrade recommended. Basically, that's because there's a newer version of Gradle available compared to the one Capacitor is using. But unless you're familiar with Android development, I actually recommend you do not upgrade. Just stick with whatever Capacitor generates. It's not a real problem. You can disable these notifications if you want by clicking the gear icon and then change this notification to no pop-up. So you won't annoy you every time. We still need to close this pop-up as well. Now let's have a quick look at what's in this Android project. There are 3 modules here, but app is the only one we may need to modify. Each Android app has a so-called manifest. That's this Android manifest.xml file. This contains various configuration settings for our app. For example, you can see here that there is a package name, and its value is the same app ID that we passed to Capacitor when we initialized Capacitor in our project, if you remember. So this package is what uniquely identifies our app in the Android system. Similarly, there is a label attribute here with the same value we passed as the app name to capacitor init. This is the app name that will be displayed to the user. And there are a bunch of other settings that you only need to worry about if you want to use specific native features. One thing we may need to configure is the app permissions. If our app needs to use the phone camera, for example, the user needs to give it permission to do so, either before installing it or at runtime. You can see that this project, as generated by capacitor, already asks for a number of permissions, even though our app doesn't really need all these features. We could remove all the permissions we don't need, but I'm going to skip this step for now. So that's the manifest. If we look at assets, there is a public folder inside it, and this contains all the files coming from our web app. You can see that there's the index.html, there's a static folder with the CSS and JS files. Basically, capacitor copied the build folder from our React project into this public folder. And this is the web content that will be displayed in the web view. It also copied the capacitor.config.json file. As we'll see, whenever we make some changes to our React app, we'll need to tell capacitor to sync the changes to the Android project. All right, so we have this Android project. Now, it would be nice to run our app, right? I'm going to run it in the emulator. So first I'll open the AVD manager that in this view is under the Tools menu. And then I'll just launch the virtual device that we created the last time. Let's wait for it to start up. Once it's running, we can move it to the right side here and maybe make Android Studio a bit smaller. Okay. Now, you can see that our Pixel 2 virtual device is in this list that shows all the available devices. So with Pixel 2 selected, we can click the Run button, and this will build the app. You can see that there's a Gradle build task running, so we just need to wait. It takes longer the first time because it needs to download all the Java dependencies. After the build, you should also install the app onto the device. We see the capacitor splash screen, and eventually we see our Biorhythms app. So it's been installed successfully. Let's check if everything works. If we go and select a date of birth, doesn't matter which year, we can see the Biorhythm results. Just like in the web browser, except this is now a native Android app. Pretty cool, huh? Now, we're running the app from Android Studio, so if we want to stop it, we can just press this button, and it will be terminated. But note that our app will still be installed into this device. If we open the app drawer, you can see our Biorhythms app here. This is one place where it uses the app name we passed to capacitor. The icon is the default capacitor logo for now. Anyway, we can also launch the app directly from here now. It takes a few seconds to start up, but we'll see later in this section how to make it faster. It's not that Ionic apps are slow to start, it's just that we're still missing something in our code. We'll talk about that in a separate video. For now, we managed to run our Ionic React app in the Android emulator, which is already a nice achievement. In the previous video, we ran our app in the Android emulator. This time, I want to show you how to run it on a real Android phone. I've recorded the screen on the phone itself and then used a video editor to show it on top of my laptop screen. If you're curious, the phone is a Motorola G5. It's not new nor very powerful, and that's a deliberate choice. When developing a mobile app, it's better to test it on less powerful devices, because if it works fine there, you can be confident that it works even better on faster phones. Now, the first time you use your phone for Android development, you need to enable developer mode. To do that, we need to open the Settings app. Then at the bottom, we can select System. And at the bottom of System, there should be an entry called About Phone. If we select that one and again scroll to the bottom, we should find the build number. Now, here's the trick. If we tap build number 3 times, it will tell us that we are 4 steps away from being a developer. And if we keep tapping 4 more times, then we'll see a message telling us that we're now a developer. Being a developer means that if we go back to the system settings, we can now see a developer options section. And under developer options, we can find various settings useful for developing and testing apps. Among these settings, there should be something called USB debugging. Here it is. If we enable this, we can connect our phone to our computer using a USB cable and debug our app using Android Studio. So let's toggle this option, and we need to confirm. Okay, so USB debugging is enabled. Now I'll press the Home button, and I'm going to connect this phone to my laptop using a USB cable. I'm plugging in the cable now. You can see that the battery is charging, but we also get this pop-up asking us if we want to allow USB debugging from this particular computer, as identified by a key fingerprint. We can select Always Allow, so we won't be prompted every time. Select OK, and this phone should now be fully connected to the computer. Let me move the phone screen out of the way a little bit. And if we look at the device list available in Android Studio, we can now see the Motorola G5. So if we select Moto G5, we should now be able to run our app using the real phone as the target. It will take a few seconds to build the app and then install it onto the device. We can see the splash screen. We still need to talk about how to make this splash screen disappear more quickly. We'll do that in the next video. But eventually our app starts successfully. And we can do a quick test by selecting a date of birth as usual. Let's change the year. And we should see the biorhythm results. Good. We got our app working on a real phone. Now, since we started it from Android Studio, we can also stop it from here. But the app will still be installed on the device. So if we open the Launcher menu, we can start our Biorhythms app from here. This means you can keep this app on your Android phone if you have one, and check your biorhythms every day if you want to. You can see if your physical, emotional, and intellectual form follows the same patterns predicted by the biorhythms theory. I mentioned a couple of times that there's something we can do to make our app start up faster on Android. It's time to actually look at this. I have the app running in the emulator, like we've seen earlier in this section. Now, if we tap the square button on Android, this will show all the apps that are currently running. And if we swipe up our Biorhythms app, that will terminate the app. If you simply go to the home screen, that will normally suspend the app, but it's still there in the background. By swiping it away, we make sure it's fully closed. Now we can go and open it again, because I want to see exactly how long it takes to start up from scratch. Okay, intuitively we can tell that it takes a few seconds, but let's do a more accurate measurement. Android Studio has this panel at the bottom that includes a Logcat tab. Logcat is the tool that shows all the system logs from the Android operating system. And there are always lots and lots of messages here. So it's better to filter only the messages coming from our app. Incidentally, note how it uses our app ID there to identify our application. We may also want to filter only the messages printed by capacitor, so that should reduce the noise a little bit more. I'm also going to enable word wrapping so we can see the full lines. And if we scroll to the end, you can see here that the last message from our app says splash screen was automatically hidden after the launch timeout. You should call splash screen.hide as soon as your web app is loaded. The splash screen is the initial screen we see while our app is starting that currently shows the capacitor logo. And what's happening at the moment is that capacitor is always displaying the splash screen for a fixed number of seconds, no matter if our app is ready sooner. Let's see exactly how long it waits. If we scroll to the top, the first message from capacitor that says starting bridge activity is logged at 11:51:55 and 900 milliseconds. Now, if we scroll to the end again, the line that says that it automatically hid the splash screen has time 11:51:59 and 544 milliseconds. So if we do a quick calculation, 59 seconds, 544 milliseconds minus 55 seconds, 907 milliseconds is about 3.6 seconds. That's approximately how long our app takes to start up at the moment. Now, if we go and look at the capacitor documentation that we can find under the Docs tab, capacitor offers a number of APIs that let us interact with native mobile functionality such as the camera, geolocation, and so on. One of these APIs is the splash screen. You wouldn't think of a splash screen as a typical example of a native mobile feature, but actually all iOS apps must have what Apple calls a launch screen that is separate from the rest of the app. So capacitor provides this splash screen API that uses the launch screen on iOS while also providing an Android implementation. Anyway, if we read this documentation, it says that by default the splash screen is set to automatically hide after a certain amount of time, 3 seconds by default. However, your app should boot much faster than this. And below there will be an example of how to hide it. But let's go back to our editor and I'll show you there. Note that I'm using Visual Studio Code now, not Android Studio, because we need to change our JavaScript code. Index.js is where we tell React to render our app component. So this is where we want to hide the splash screen. We can start by importing the plugins object from the capacitor core module. And this plugins object gives us access to all the capacitor APIs. We can extract the splash screen instance from that plugins object. And now that we do have the splash screen, we simply need to call its hide method after rendering the app component. So we're basically telling capacitor, our app is ready to be displayed, you can hide the splash screen now. Since we modified our JavaScript code, we need to build our web app again, as in doing another production build. Remember that this generates all the static files inside the build folder. And now we need to tell capacitor to sync the Android project. This basically copies the contents of the build folder into the assets folder inside the Android project. If you ever run your app on Android and don't see the expected changes, chances are you forgot to do a build and sync. There's also a way to use live reload while running your app on Android, but we'll talk about that in a separate video. Now that we updated our web code, we can go back to Android Studio And note that there's a background task running here. That's because it detected that we made some changes inside the Android folder. Once it's finished, we can try running our app again. Let me show the emulator that ended up in the background. Now we can redeploy our app. We can use this button that will restart it as well. Let's wait a few seconds for the Gradle build. Now I should install it. And we can already tell that it started up more quickly this time. But let's make the same measurement as before. Let's terminate the app and then go and open it again. So it starts up from scratch. Okay, now let's go and look at the system logs using logcat. Let's make sure we select the right process. We are already filtering for capacitor. Now we want to find the very first message, the one where capacitor says it's starting bridge activity. This was logged at 11:55:22:997. Let's note it down, and now we need to find when the splash screen was hidden. It's this line here that says plugin ID splash screen, method name hide. This is because we now call splashscreen.hide in our code. It's no longer automatically hiding the splash screen after a timeout. We hide it explicitly. And this happens at 11:55:24.422. So the difference between the time when we hide the splash screen and the time of the first log message is about 1.4 seconds. If you remember, the first time we tried, it was 3.6 seconds, so it's over twice as fast. And this using the emulator while I'm also recording my screen. On a real device, it's probably faster. So that's pretty good. It's quite a big improvement in performance, especially if you consider that all we had to do was add a few lines of code and call splash screen hide after rendering our app with React. So if you are building your app for Android, it's very important that you remember to explicitly hide the splash screen as soon as your app is ready to be displayed. We've seen how to speed up the start time of our app by hiding the splash screen as soon as our app is loaded. And we've also seen that after modifying our JavaScript code, we had to rebuild the app and tell Capacitor to sync the Android project. This is fine as long as we can develop most of the functionality by testing in a regular web browser and only build for Android once in a while. But if we're developing some code that needs to be tested on Android, having to rebuild the whole thing every time we make a change is quite painful. Thankfully, Capacitor provides a way to use live reload even when running on Android. If we look at the documentation, there is a section about configuration. We can configure Capacitor using a capacitor.config.json file. We already had a quick look at it, but on this page you can find all the possible options you can set with Capacitor. And in this file we can also have a server section with a URL property. If we set this option, then the app will be loaded from this URL rather than from the assets folder. So we can take advantage of this feature to load our app directly from the React Webpack dev server. Let's see how this works in practice. We can start the React dev server with npm start as usual, and this will open our app in the browser when it's ready. Here we go. Let me resize the editor so we can see the code as well. Now that we have the dev server running, we want to edit the capacitor.config.json file and add a server section, as we've seen in the Capacitor documentation, with a URL property. Now, as the URL value, we want to use the address of the React development server. In fact, note that there are two addresses here. We want the one visible on your network, not the localhost one, because localhost only works on this computer, but we want to connect to the server from an Android device. And even if it's running in the emulator, an Android device is still a different machine, so it cannot access localhost. Also note that this IP address will probably be different on your own network. And you may also need to configure a firewall if you have one running on your machine to allow connections to this port. Anyway, we can paste this URL into the capacitor configuration and save. Then we need to open a new terminal and do a capacitor sync because we modified the capacitor configuration. We can close this terminal now. And let me show the Android emulator and Android Studio again. Looks like it has refreshed the files, so let's run our app from Android Studio. As usual, this will take a little while. Note that it displays a toast message showing the server URL where it's loading the app from. But something didn't work while loading the page. The error says clear text not permitted. The problem is that our dev server uses plain HTTP, not HTTPS, so the connection is not encrypted, it's in clear text. And that's not allowed by default by Android for security reasons. What we need to do to fix this problem is edit the Android manifest file. And inside the application tag, we need to add a new attribute that's called uses clear text traffic. If you start typing clear, it should suggest the right option. And we want to set it to true to allow clear text traffic, or in other words, plain HTTP. With this change, we can try rerunning our Android app and wait a little bit more. And this time you can see that it did load the app successfully. Now, how do we know if it's using the dev server? Well, let's go to Visual Studio Code and make some changes. For example, we could just set the color on the Ion toolbar to be the primary color. And if we save, after a small delay, we can see that the app reloads itself and the toolbar is now blue. So that's pretty cool. We can edit our JavaScript code and see the changes in the Android app, just like with a regular browser. That makes our life as developers a lot easier. No need to rebuild the app every time. Just to recap, for this to work, we need to set a server URL in the capacitor configuration, and then, because Android by default doesn't allow plain HTTP connections, we need to enable this uses clear text traffic option in the Android manifest. Now, since these settings are only useful for development, you also need to make sure you remove these options when you create a production build. But that's how we can use live reload with Capacitor and an Android app. We've seen earlier how we can configure Capacitor to support live reload. We can set the server URL in capacitor.config.json to match the address of the React dev server. And this way, if we go and make some changes to our JavaScript code, like if we modify the toolbar color, the Android app will automatically reload and use the latest code. So we can develop our Android app pretty much like we do in a regular web browser. But when developing in the browser, there's something else we can do. We can use the Chrome developer tools. Turns out we can even use the dev tools to debug an Android web view. The trick is to open a special page in Chrome that has URL Chrome Inspect. So if we copy this special URL and open a new tab pasting that location, here we can see a list of devices that we can debug. There is a single device here at the moment that is Android SDK built for x86, which just means it's an Android virtual device running in the emulator. And inside that device, there is a web view in org.example.biorhythms that is the ID of our app. It also shows biorhythm calculator below, that is the page title. Now, if we click Inspect, this will open a new Chrome Developer Tools window. Let me make it a bit bigger. And if I show the Android emulator again, you can see how the DevTools window on the left shows what's basically a mirror image of the Android screen. We can use that mirrored view if we want to inspect any elements on the page, like the toolbar, for example. And here we can see all the styles, CSS classes, rules, properties, HTML elements, and so on. It works exactly like when inspecting a regular web page. Likewise, we can look at the console tab to see any log messages. For example, here there's a message logged by capacitor when we call the splashscreen.hide method. And of course, you can use all the other tools as well, like the network requests and so on. Also, in this case, we're looking at an Android virtual device running in the emulator on this computer. But this remote debugging feature also works with real Android devices. If you plug your phone to your computer using USB debugging, like we've seen earlier in this section, you can use the DevTools to debug an app running on your phone as well. All you have to do is enter the special Chrome Inspect URL into the location bar, and you should see all the available devices listed on this page. This can really be an invaluable tool for debugging your app while it's running on Android. After looking at Android, let's now talk about iOS apps. To do iOS development, we need the Xcode IDE that's published by Apple and only runs on macOS. You can find it in the Mac App Store. If we open the App Store and search for Xcode, here's Xcode. It's the #1 app under Developer Tools. It's free, so we can just click Get, and we need to sign in with our Apple ID. And now it should start the download. That's going to take some time. Once it's finished, we can click the Open button. And now it's telling us that we need to install some additional components. So click Install, enter the administrator's password, and wait a little bit longer. It's now opening Xcode. Here's the welcome screen. We can close the App Store window. Now, if you create a project from this screen, it will use Swift or Objective-C as the programming language. But just like with Android, we'll use Capacitor to generate an iOS project for us, and only use Xcode for building it and running it. Xcode also comes with an iOS simulator that we can open from the Xcode menu under Open Developer Tools. Let's try opening it. We can see a phone starting up. This will take a few seconds. Once it's ready, we can just use it like a real iOS phone. For example, we could open the Safari app, which may also be useful if you want to test a website in the iOS mobile browser. Then we can press the Home button to go back to the initial screen. If we look at the simulator menu, We can simulate things like rotating the phone, shaking it, or increasing and decreasing the volume, or even pretend to be at a certain GPS location, which may be useful for testing maps, for example. We can also choose which phone to simulate. It's currently running an iPhone 11 Pro Max, but we can select a different one, like a vanilla iPhone 11, for example. And this will start another simulator window. So we can close the first one. Here's our iPhone 11 ready to use. When we're done testing, we can obviously close it and also go and quit the simulator completely. Okay, so we have Xcode installed. In the next video, we'll create an iOS project for our app using Capacitor. Now that we've installed Xcode, we're ready to build our app and run it in iOS. So let's switch to Visual Studio Code. While running our app on Android, we added a server URL to enable live reload with Capacitor. Let's remove it now because we'll start by running a production build of our app. Next, let's open package.json so we can look at the project dependencies. Here we already have Capacitor, of course. So we can open a terminal and run npx cap add iOS. This is similar to what we did for Android. It will add iOS support to our project. Once it's finished, we should have a new dependency called Capacitor iOS. As usual, I recommend pinning this dependency to a specific version and make sure it's the same version as all the other Capacitor packages to avoid compatibility issues. Capacitor add iOS also created a new folder called iOS that contains an iOS project that can be opened in Xcode. If we go back to our terminal, we can run npx cap open iOS like suggested above, and this should open Xcode loading the iOS folder we just looked at. Okay, if we look at this project, there are two sub-projects, app and pods. Pods are essentially libraries. We don't usually need to worry about them. We're more interested in the app. Here you can see that there is the Capacitor configuration file. There's some native code like appdelegate.swift below, but again, we don't need to worry about that. There's also a public folder that contains all the static files for our web app. For example, there's index.html, and then there's a static folder with CSS and JS resources. So this public folder is just a copy of the build folder from our top-level project, and it's the web content that will be displayed in the web view when we run this iOS app. If we select the app project, we can see an interface where we can edit the project configuration. This includes settings like the display name that's already set to biorhythms because that's the app name we have in our Capacitor configuration. There's a bundle identifier that is effectively our app ID. So Capacitor calls it app ID. On iOS, it's called bundle identifier. And in Android, if you remember, it's called package name. They all mean the same thing. Here we can also set other things, like the iOS version we want to target is currently iOS 11.0. Also, we're targeting both iPhones and iPads. It's usually fine to leave things as generated by Capacitor, unless you have some special requirements. There are also multiple tabs in this configuration. In addition to General, there's something called Signing and Capabilities. Signing means that every iOS app needs to be cryptographically signed using a certificate issued by Apple. At the moment, it's using a certificate called Apple Development, which is fine for running the app in the simulator. But if we want to run our app on a real device, or even submitted to the App Store, then we'll need to get a proper certificate from Apple. Anyway, we'll just use the simulator for now. We can select which iPhone model we want to simulate. Let's pick the iPhone 11, then click this Run button, and Xcode will build our app. You should also start the simulator and run our app on it. Okay, that's our app running. It actually looks a bit strange. We don't see the app toolbar, and the date of birth label is getting truncated. But we'll fix those issues later. Now let's try selecting a date and see if the rest of the functionality works as expected. That looks good. We can see the birhythm graph. Let's try changing the target date as well. And the graph moves forward a few days. Now note how in Xcode we can see some logs. Let me expand this panel, but we can't see the emulator now. Let's try it this way. Okay, so we can see log messages from capacitor saying, for example, web view loaded. We can stop the app by using this button, but as you can see, the app is still installed on the device, and we can start it directly from here if we want. Of course, it also remembers our date of birth because we save it into local storage. And that's our app running in iOS. So we got our app running in the iOS simulator. However, there are a couple of visual issues. The toolbar is not visible, and the date of birth label is getting truncated. This is a good chance to see how to debug iOS apps. We've seen before how we can use live reload with capacitor to develop our app while it's running on Android. We can do the same on iOS as well. Let's start the React dev server with npm start. As usual, this will open the app in the web browser. And since we're here, let's check what it looks like if we select an iPhone in the Chrome device mode. You can see that everything looks fine here. We can see the header with the birhythms title, and the date of birth label is fully visible as well. So there may be differences between Chrome device mode and running it as a real iOS app. Now let's go back to our editor. We wanted to configure capacitor for live reload. So let's add a server object with a URL property. That should be the network address of the React dev server. Okay, let's save, and we need to tell capacitor to update the iOS project, so do a sync iOS. That's done. We can now close this terminal, and we can go back to the iOS simulator and Xcode and run this app from Xcode. It's starting up. Okay, the app is running again. Now let's go back to Visual Studio Code because we want to edit our React components. Let's start by fixing the date of birth. That should be easier. We can just make the text shorter by writing birth date instead. It's also consistent with the other label, that's target date. The app has reloaded, and we can now see the birth date text in full. That was straightforward. Now, fixing the header is going to be a bit more involved, because we'll need a way to see which styles are being applied, and we'll do that in the next video. Okay, we want to find out why the header is not visible when running our app in iOS. When talking about Android, we've seen how we can use the Chrome developer tools to debug an Android web view. Now, we cannot use Chrome to debug an iOS app, but we can do something similar by using the Safari browser. If we open the Safari preferences and select the Advanced tab, there's an option that says Show Develop Menu in Menu Bar. And by enabling that option, we get access to this Develop menu. Here you can see that it lists the iOS simulator that we're currently running, and it shows our Biorhythms app with an IP address that is where it loaded the web page from. So if we click this, it opens a window with the Safari developer tools. Let me bring back the simulator as well. And now we can inspect the elements of our web page. We're looking for the header that should be inside the app root dev. Here you can see that there's an Ion app element with an Ion header inside. So this should be the element we're looking for. If you look at the simulator, it highlighted the header at the top. So it is there, but it's so high in the page that it's mostly hidden below the iOS status bar, and we cannot actually see its contents. Why does this happen? Let's look at the computed styles. If we scroll down, there are a few CSS variables defined by the Ionic style sheets. For example, there's one named Ion Safe Area Top. Sounds like this may affect the top position of the header, but its value is currently 0 pixels. If we click on it, we should see where it's defined in the CSS rules. And it's this one. It's set to env safe area inset top. We'll see what env means in a minute. But first, let's try changing this value and set it to 44 pixels. You can see in the simulator that the header title is now visible because the header is pushed down by 44 pixels, so it's no longer hidden under the status bar. Now, I knew that 44 pixels works because I did some debugging before, but the real question is, why is it not working with the default value that is env safe area inset top? And what is this env thing anyway? Let's have a look at some documentation. This is from the Mozilla Web Docs. Env is a CSS function. It's a bit like var that we used before, but while var is to use a variable that we defined, env will use a value defined by the user agent, which means the web browser. So web browsers expose some environment variables that we can use in our styles with this env function. But here's the caveat. To be able to use these env variables, we need to add a viewport meta value. So we need a viewport meta tag in our HTML setting viewport fit equals cover. You can read this page for more details, but let's try copying this value and adding it to our web page. If we look at the project files, there is a public folder, and inside it there is index.html. This file was generated by Create React App. We don't usually need to modify this file because we mostly write JavaScript code, but our React app component is mounted on a dev element on this page. Anyway, here there already is a viewport meta tag. So we can simply add this viewport fit equals cover property that we copied from the Mozilla docs. Let's save and see if this makes any difference. Guess what? We now see the header title correctly. So, because some of the Ionic styles rely on those env variables, we need to configure this viewport meta tag appropriately. If you want to learn more about this viewport, of course, there's some documentation about that too. The viewport is the area of the browser window in which web content can be seen. And it's not always the same as the size of the page. The viewport can be bigger than the visible page if you have scroll bars, for example. But also mobile browsers frequently use a viewport that's bigger than the actual screen size. They can shrink the content to make more of the page visible. And they also let users zoom in or out, which changes the viewport size. This is fine for most web pages, but we have an Ionic app, and Ionic components are already designed to fit on mobile. We actually don't want the user to change the page zoom, otherwise they can mess up our layout. So there are some other viewport properties that we may want to set, notably the minimum and maximum scale and the user scalable flag. Let's go back to our code again. Here we already have the initial scale set to 1. This is the initial zoom level, and 1 means the original size. We can add a minimum scale set to 1 and a maximum scale also set to 1. By setting both minimum and maximum to 1, we're basically saying you cannot change the zoom level. For good measure, we can also set user scalable to no, which tells the browser not to allow the user to change the zoom. With these settings, we can be sure that our app will always be displayed exactly as we see it now. Now, if you generate a project using the Ionic CLI tool, as we'll see later in the course, all these properties will already be set and you don't need to worry about them. But if you add Ionic to a project generated with Create React App, like in this case, you will need to manually configure the viewport in this way. Now, let's do a quick test and select a birth date just to make sure the rest of our app is still working. And of course, we see our nice biorhythm graph. Okay, so we learned about the browser viewport and how it affects the env variables used by the Ionic CSS styles. But this was also a good example of how to use the Safari developer tools to debug an iOS web view. On Android, we can use the Chrome developer tools, and on iOS, we can use the Safari developer tools. We used Capacitor to generate both Android and iOS projects. So on Android, we have our app installed, but the icon for our app at the moment is the Capacitor logo. Likewise, when we launch our app, the splash screen image again shows the Capacitor logo. And of course, it's the same on iOS. Both the app icon and the splash screen display the Capacitor logo simply because that's the default image. But how can we customize those images? Obviously, we'll want to create our own unique logos for our app. If we open Android Studio, for example, in the Android project there is a res folder under the app module. Res is short for resources, so here we can find all the images used by our Android app. Under Splash, we should have the splash screen images, and there are several images for the splash screen alone, because they have different sizes. This one, for example, is 800 by 480, while if we select the next one, this one is smaller, it's just 480 by 320. The reason why we need different images is to support different screen resolutions. So on phones with a smaller screen, Android will use smaller images. Also, there are different sets of images for landscape or portrait orientation. So these ones are for portrait mode. And on Android, different screen resolutions are identified by all these abbreviations you see next to the file name. Like MDPI means medium density screens, HDPI means high density screens, and so on. There's a page in the Android documentation listing all the possible density values. And it's the same for the launcher icon, that is the app icon used to launch the app. There are different images for HDPI, MDPI, and so on. So in theory, we would need to create our app logo and splash screen images in all these different sizes. Now let's look at the iOS project in Xcode. In this case, the images are under app, and here there's an assets.xcassets. And xcassets is just a special folder that contains images. But here you can see that there are several versions of our app icon image. Apple uses a different convention for specifying screen resolution. So you have 2x, which means double the resolution of a standard display, and 3x, meaning a scale factor of 3. Also, there are different images for iPhone and iPad, for notifications, settings, and so on. And again, it's the same for the splash screen, although we only need 3 images in this case. Anyway, the bottom line is that we need a lot of different images on both Android and iOS. Now, thankfully, the Ionic team thought about making our life easier, and they created a project called Cordova Res. This is a resource generator. It can generate all the images for us. It's called Cordova Res because it was initially written to work with Apache Cordova, I guess, but it also works with Capacitor. With this tool, we need to create just 2 images, one called icon.png and the other one splash.png. We need to keep them under a folder called resources inside our project. And we don't need a config.xml, that's just if you use Cordova. Now, the icon image must be at least 1024 by 1024, and the splash image at least 2732 in each dimension. Once we have these 2 images, Cordova Res will take them and generate all the different sizes required by Android and iOS. Now, if we look at our biorhythm calculator project, there is actually already a resources folder that I provided as part of the initial project setup. And here there's an icon.png with a simple logo for our biorhythm calculator app. You can probably tell that I didn't spend a lot of time designing this logo. I just took an icon of a person and put a wave on top of it, basically, to give the idea of biorhythms. But it's already the right size, 1024 by 1024. And similarly, there's a splash image that's bigger. So we can use these images as an example. Now, somewhere on this page, it should show how to use Cordova Res with Capacitor. Here we go. So we can generate the images by passing these options, skip config and copy. Let's try this command in our app. I'll just paste it into our terminal, but this assumes that we have Cordova Res installed globally. We can run it with npx, so it will automatically download Cordova Res. And this should take a few seconds. Okay, it says it generated and copied the resources for Android. Let's go back to Android Studio. And we can see our new image as the launcher icon. Let's look at the splash image as well. It's our new one. Same for the portrait mode. So we can try reinstalling our app in the Android emulator. We just need to wait for the build to finish. And we can see the new splash screen while the app is starting up. If we go back to the home screen and open the app drawer, we can see the new app icon as well. Okay, so we customized all the images on Android. Now let's do the same for iOS. It's the same command, we just need to replace Android with iOS and wait for it to process all the images. Okay, it's finished. Let's go and check in Xcode. We can see that the splash images have been updated, and if we check the app icon, they are also using our new logo. Let's try rerunning our iOS app. Where's the simulator? It will take a few seconds to build. Here we see the old logo, but it's just a caching issue. In fact, we do see our new image now. I always see this problem on iOS, where it initially shows the old splash image, so I'll show you what to do if it happens to you as well. If we long press on the icon, we can delete the app, confirm. Now I'm going to close the simulator and then run our app again. So this will restart the simulator as well. We can see the new splash image now. I'm not sure exactly why the iOS system caches splash images, but restarting everything fixes it. In fact, we could also try closing this app completely and then starting it again, just to double check. It always shows the new splash image now. So that's it. We customized the images both in Android and in iOS. We just need to put two images in our project, icon.png of size 1024 by 1024 and splash.png, and then we can run the Cordova REST tool to automatically generate all the different variants and sizes required for Android and iOS apps. The previous videos were recorded using Capacitor version 2, but recently a new major version of Capacitor has been released, version 3.0. Now, most of what we learned using Capacitor 2 is still valid for Capacitor 3 as well, but there is one major change in the way plugins work. So in this video we'll see how to upgrade an Ionic React app to use Capacitor 3.0. And we'll do that using the Biorhythm Calculator app. The first thing we need to do is upgrade the npm packages. Now, the way I like to do this whenever I need to update some packages is to run npm outdated, and this will print a list of packages that can be upgraded. You can see that there are 4 packages that can be upgraded, and they're the 4 capacitor packages. Their current version is 2.4.7, and that's also the wanted version, which means what we declare in our package.json. But the latest version is 3.0.1. So let's copy that latest version and go and use that one in our package.json, replacing the old one everywhere. This way we're declaring that we want 3.0.1, but to actually install the new packages we need to run npm install, and this will download the latest versions. Okay, so we upgraded the existing capacitor packages, but we'll also need to install some additional packages, because the big change in Capacitor 3 is that all the plugins that used to be part of Capacitor Core have now been moved into their own separate packages. So whenever we want to use a certain plugin, we first need to install its package. Not only that, but there are some plugins that are always required by the Ionic framework, even if we don't use them directly in our code. These plugins are App, Haptics, Keyboard, and Status Bar. We can find the npm install command with all the right packages here, so we can copy it and run it in our terminal. Note that all the packages are under the @capacitor scope followed by the plugin name. Okay, so this added 4 new packages, and note that each plugin has its own version. So Capacitor app, for example, is currently at version 1.0.1. Now, these 4 plugins are just the minimum required by Ionic. But if we use other plugins in our code, we'll need to install other packages as well. In this example, we are using the splash screen plugin just to hide the splash screen as soon as our React app is ready. And in fact, even if the splash screen is not strictly required by Ionic, it's still a good idea to include it in our app. So how do we find out which package provides that plugin? If we look at the official plugins in the capacitor documentation, we can find the splash screen there, and this page tells us the package name. In fact, we can also copy the right npm install command from here, and then reopen our terminal and install the splash screen package. Okay, that's the package installed. Now let's have a look at how to use the plugin. We need to import the splash screen object from the package we just installed, and then we can call splash screen hide as before. Let's go and change our code. With the old capacitor version, all the official plugins were inside the core module, but now there's a separate splash screen package that will export a splash screen object. And this means we don't need to extract it from the plugins object anymore. Everything else can stay the same, it still has a hide method. Now, I'm actually going to make a small change here. If we look at the render method, we can pass it a third argument that is a callback invoked after the component has been rendered. So it would actually be slightly better to call splash screen hide inside that callback function. This way we wait for the app component to be fully rendered before we hide the splash screen. But that's nothing to do with capacitor 3, it's just a small improvement to our code. Now let's go and start our app and check if everything still works after we upgraded to capacitor 3. Let me show the DevTools as well. The app just reloaded itself and it seems to work fine. But this is running in the browser. What about building it for Android and iOS? If you want to upgrade your existing Android and iOS projects, then you need to follow all these instructions. And this is a bit complicated because it involves changing Java code, configuration files, and so on. So what I recommend instead, if at all possible, is to simply recreate your Android and iOS projects from scratch. Let me show you what I mean. In any case, we first need to make a production build of our React app. Now, I was talking about recreating the mobile projects. If you used capacitor 2 to add the Android and possibly iOS platforms, you'll have these folders in your project. What we can do is simply delete those folders. For Android, we want to remove the Android and also the .gradle folders, while for iOS it's just the iOS folder. And now we can run npx cap add Android, just like we did in a previous video, and this will recreate the Android folder, but with code generated by capacitor 3. Likewise, if you want an iOS app, you can run npx cap add iOS. And this takes a bit longer because it also installs some native dependencies. But anyway, now we have brand new Android and iOS projects. And from now on, we can build them exactly like with the previous capacitor version. Let's open the Android project, for example, just to show you that it works with capacitor 3 as well. The first time you open the new project, it may take a few minutes. Always look in the bottom right corner to see if there are tasks still running. Now, if you get an error about some missing Android package, open the SDK manager and make sure you have the latest versions of the Android packages installed. The first time I tested capacitor 3, I had to install the Android 11.0 platform. And you may also need a specific version of the build tools that you can see in this panel. The exact version will change over time, but if you get an error, it should tell you which version you're missing. Okay, the last thing I want to do is run the app in an Android device. And I'll use a tool called Screen Copy to show you the screen of the Android phone I have connected to my computer. Okay, so let's go and press the Run button, and this should build and install the app on the device. It's finally starting. And we can see our biorhythms app, where we can select a birth date, and it draws the biorhythm lines. Okay, that proves that our app is working fine with capacitor 3. I'm not going to run it in iOS as well, but it should work just like we saw in the previous videos. Once you upgrade to capacitor 3, following the steps we did in this video, everything else should work in the same way. In this section, we'll look at the Ionic CLI, or command line interface. It's a tool that makes it easier to create a new Ionic project, build it, run it, and so on. To use the Ionic CLI, we first need to install it, of course. And we can install it globally on our machine by opening a terminal and running npm install -g, which means install it globally, and the package is called @ionic/CLI. Let's wait a minute or so for npm to download everything. Once the package is installed, we can verify that it's available by running ionic -v, which should just print the version number. We can also type ionic --help to show some documentation on how we can use this tool. Under usage, you can see that we can type ionic and then a command, where the command can be one of those in the list below. For example, the start command can be used to create a new project. If we want more details about that specific command, we can type ionic start --help, and this will print an explanation of what this command does, then show the usage instructions and all the possible options we can pass. Let's look at the usage in more detail. We can type ionic start and then pass a name, a template, and possibly some options. The name is obviously enough the name we want to give to our new project. As for the template, we can pass blank, which creates a mostly blank project, or tabs, that creates a project using a tabbed interface, or any of the other templates we can see by passing the --lest option. We can start with a blank template, that's the simplest one. Now let's look at some of the options listed below. An important one is --type. You can use Ionic with different web frameworks, not just React, but also, for example, Angular. So we'll want to set the type to React in our case. There's also an option to enable capacitor integration. If we want to build our app for Android and iOS with capacitor, then we can simply pass this --capacitor option when creating the project. And you can look at all the other options yourself if you like. There are also some examples at the bottom. Now let's go and create a new Ionic project then. First, I'm going to change directory to my projects folder, which is where I keep all my projects. You can use whatever folder you want on your machine, of course. Now we can type ionic start. Let's pass my app as the project name. Then we need a template, and we can use the blank one. Next, we want to set the type to React. And finally, we could enable capacitor as well. Let's run this command, which might take a couple of minutes. Before completing, it's asking us if we want to create a free Ionic account, which gives you access to the Ionic forum and stuff like that. You can do that if you like. I already have an account, so I'm just going to answer no here. And with this, our new project should have been created. If we list the files in this folder, you can see that there's now a new folder called My App, which is, of course, the project name we passed to Ionic Start. So let's go into that folder and open its contents in Visual Studio Code. This is our new project. You can see various files and folders in the Explorer panel on the left. But we'll look at those later. First, let's see how to run this app. If we go and open a new terminal, and I'll use the integrated one, we can start the app using the Ionic command line tool by running the serve command. And this will start a development server, just like the one we used in our previous examples. The only difference is that using the Ionic CLI, the server runs on port 8100. But apart from that, it's exactly the same dev server used by Create React App. So here in the browser, we can see our initial app based on the blank template. It has a toolbar with a title and some simple content with a link to the Ionic documentation. Pretty simple. In the next video, we'll look at this project in more details. But for now, we created a new project using the Ionic CLI, and we got it up and running using the Ionic serve command. We created a new project using the Ionic CLI, and we're running it locally with the Ionic serve command. Now let's have a look at the structure of this project. If we start from the package.json file, here we can see all the dependencies that have already been installed. Since it's an Ionic React project, of course we have the React packages and the Ionic React one. We already have Ionicons as well. These are all packages we used in our first examples. However, there are some other dependencies we haven't used yet, like React Router and Ionic React Router. We'll talk about routing in more details in the next section. This project is also using React scripts. This is the same package used by projects generated with Create React App. It's the command used when starting the dev server, building the project, and so on. So a project created with the Ionic CLI is pretty similar to one initialized with Create React App. However, unlike our previous examples, this project uses TypeScript. If you haven't used TypeScript before, TypeScript is like JavaScript, but with some additional features. We'll talk more about TypeScript later. Moving on, we also have Capacitor Core because we enabled Capacitor when creating the project. And if we scroll down a little bit, under Dev Dependencies, there's also the Capacitor CLI, that is the Capacitor command line tool. The order in this package.json file is a bit strange, probably because it's auto-generated. I'll show you later on how I like to tidy things up a little bit. Anyway, these are all the dependencies. We already have all the Ionic and Capacitor packages we used earlier in the course, and a few more that we'll look at in the following sections. In addition to package.json, there is a capacitor.config.json. So this is the capacitor configuration file that we've seen before. If we want to build this app for Android and iOS, then we need to make sure to change this app ID and put our own identifier using the reverse domain notation, something like org.example.myapp if you own the example.org domain. Likewise, you may want to change the app name because this is what is displayed to the user, for example, in the app launcher. So we could write my app but in title case instead of just displaying the folder name. It's important to configure these settings before generating your Android and iOS projects with Capacitor. That's why I recommend doing this right after creating a new project with the Ionic CLI. Now let's go and look at the application code. There is a public folder that contains an index.html file, just like any project generated with Create React App. But in this case, there are a few extra things specific to Ionic. For example, it's configuring the viewport, like we did at the end of the last section, to make sure the page looks fine in mobile browsers, especially Safari for iOS. So that's already taken care of. Now, in the body of the HTML, there is a div element with ID root, which is where our React app will be dynamically inserted. Again, this is no different from any other React project. Now, let's look at the source folder. Here we can see that instead of JS files, we have files ending in TS or TSX. These are TypeScript files. The normal extension for TypeScript is TS, but it must be TSX if it also uses JSX, which is what we use for writing React elements, of course. Now, if we open this index.tsx, you can see that it looks very much like a regular JavaScript file. There are actually no TypeScript-specific features in this particular file. All it does is rendering the app component into the document element with ID root. Once again, nothing new here. Let's look at the app component now, that is in this app.tsx file. Here you can immediately see that there are a lot of CSS imports. In fact, it's importing all the Ionic CSS files that we manually added in our first example. So that's already done for us in this project. In addition to the Ionic style sheets, it's also importing a local variables.css file that's under the theme folder. If we go and look at that file under theme, you can see that it contains all the CSS variables we can use if we want to customize the Ionic theme, something we've done earlier in the course. But in this project, we already have this file, and we just need to change the values if we want. Now, this app.tsx is mostly like a normal JavaScript file, except for this small bit here where it declares that app is a variable of type React FC, where FC stands for function component. This is called a type annotation, but again, we'll talk more about TypeScript later in this section. Now, if we focus on the JSX elements, you can see the familiar Ion app component at the top. But then there are a number of components we haven't seen before, like Ion React router. A router is required when you have more than one page in your app. We'll cover this in great detail in the next section. All you need to know for now is that at the end of the day, this code simply renders this home component. And I can prove that to you by replacing all this stuff with the home component directly. Let me show the browser again so we can see the result in the page. If we save these changes, you can see that the app looks exactly the same as before. There will be just a few warnings in the console because of unused imports. If we look at the top of this file, we should remove all these components we're not using anymore. But this was just to show you that all this code does is basically just display the home component. Let's keep the original code anyway. So what's in the home component? You can see that it's imported from pages/home. Let's go and look at this pages folder then. Here we can find home.tsx, and this code should look more familiar. There's an Ion header, an Ion content, and other elements we've seen before. There's also an Ion page at the top that has to do with routing. So again, we'll cover it when we get to the section on page navigation. Obviously, we can edit this file and, for example, change the title to My App. And if we save the change, the page will automatically update, showing the new title. Now, in the content, it's displaying an Explore container. This is just a local component imported from the components folder. Let's look at that folder quickly. Here we have explore container.tsx, and this is a React component that renders the content you see in the page. Incidentally, this initial code generated by the Ionic CLI tends to change from time to time. So if you're seeing some slightly different code on your machine, that's probably just because the Ionic team made some changes to the blank template. But this is just an example of defining a custom React component. There's another TypeScript feature here called an interface that I'll explain in one of the next videos. I guess what they're showing here is how you can style a component simply by importing a CSS file named like the component itself. This is just what we did in our biorhythm calculator example. Like I said, this is just sample code anyway. As you start writing your own functionality, you're probably going to delete that explore container component. What matters is the main structure of the project. the fact that it already imports all the necessary Ionic styles, theme variables, it provides an app component that uses Ion app, and so on. So this is the initial structure of a project generated with the Ionic CLI. In the next video, I'll tell you about a few changes I always like to make to this generated code. We had a look at the code of this project as created by the Ionic CLI. Now I want to tweak this generated code a little bit. Let's start from the package.json file. But before we make some changes, I'm going to stop the dev server that was still running. So the sections in this package.json are in a pretty random order. Typically you have the scripts at the top before the dependencies. So let's move this block up and put it here. This way it's easier to see which npm scripts you can run in this project. Also, if we scroll to the bottom, we have dev dependencies here that logically should be after the normal dependencies. So let's move them here. Now, it's a bit strange to have a single dev dependency. There are other packages that are only used for building the project, like React scripts and TypeScript. So let's move those to dev dependencies as well. And fix the commas. What's next? There are some testing library packages that are only used for automated tests. And there are also all these types packages. These are used by TypeScript to handle libraries that are written in regular JavaScript, like React. Either way, we can consider them dev dependencies. This is just a conceptual distinction, really. But this way, it's easier to see which ones are the main libraries we use in our project, like Capacitor Core, Ionic React, and so on, and which packages are only used for building and testing. That are those under dev dependencies. Okay, so that's cleaner, I think. Now we can tweak these scripts a little bit. The eject command is something you never use in practice, so we might as well remove it. More importantly, we've seen that to start our app for local development, we use the Ionic serve command. So let's write it here, and then we can simply run npm start, like in most projects, and this will execute the right Ionic command. Similarly, for the build phase, we haven't seen this yet, but the Ionic tool provides a build command. So if you do npm run build, this should launch Ionic build. The test script can stay as it is. There is no special Ionic test command. Now, we installed the Ionic CLI as a global package on our machine. But if we're using it for this project, it would really be better to install it as a dependency of this project. So if somebody checks out our project code, they'll just need to run npm install to get everything they need to work on this project without having to separately install some other package globally. So let's go and add the Ionic CLI package. Before we do that though, since we modified the package.json file, I'm going to remove the package lock.json and then run npm install again. This is to make sure that what's installed matches what we have in package.json. Okay, now we can install the Ionic CLI by running npm install at ionic/CLI, and we want to save it as a dev dependency. Also, let's save the exact version, just in case there are some incompatibilities between different versions. Okay, the Ionic CLI should now be installed as a dev dependency of this project. And we can now start our application again, but this time we can simply run npm start because we changed the script in package.json to take care of launching Ionic serve. Okay, this opens a new browser tab that we don't really need because we already had the app running here. But the dev server started successfully. What else did I want to do here? Let's open app.tsx. Here we have all these CSS imports that I find a bit annoying whenever I need to change some code in this app component. So I usually move them into index.tsx instead. It's the same thing because the styles will still be applied to the entire application. But index.tsx is not something you need to modify very often. So I prefer to put all the CSS stuff here, which means that there's a lot less noise in the app component code. If we look at the page in the browser, this change should make no difference. This is just my preference. You can keep the styles here if you want, of course. Now, if we go back to index.tsx, there's another thing I always do right after creating a new project, and that's hiding the splash screen. If you remember, we've seen how to do that in the previous section. We need to import the plugins object from the capacitor core package. And then we can use this plugins object to extract the splash screen instance. And right after rendering the React app, we should call splash screen hide. So this makes sure that we don't show the splash screen for any longer than we need to. I recommend making this change at the beginning if you plan to build your app for Android and iOS, just so you don't forget. Okay, so that's the splash screen sorted. Now, if you do want to use capacitor, also remember to configure the right app ID in capacitor.config.json. But we already did this in the previous video anyway. So I think that's it. These are just some changes I recommend making to the code generated by the Ionic CLI, and especially the package.json file. Let's talk about some other commands provided by the Ionic CLI. We put two of them in this package.json, Ionic serve and Ionic build. We've seen already that Ionic serve starts the development server. I still have it running here. If you notice, Ionic serve actually runs React scripts start. React scripts is the same tool used by Create React App. So in this case, there's almost no difference between using the Ionic CLI and using the default setup of a normal React project. Now let's stop this development server and let's try running Ionic build. Notice how this also calls React scripts to create an optimized production build. When it's finished, we'll have a build folder with an index.html and all the static files we need if we want to deploy our app to a web server, like we've seen in the previous section when we published our app to Netlify. So for both serve and build, the Ionic CLI does really nothing different from what a standard React project does. However, we can also use the Ionic tool to execute capacitor commands. If we run Ionic capacitor --help, we can see all the possible options. Most of these commands are the same we used in the previous section when we ran capacitor with npx. But instead of npx, we can run Ionic capacitor, for example, to add Android support for this app. This will generate an Android project, as we've seen in the previous section. Once it's finished, we can see a new Android folder here that contains an Android Studio project. To open it instead of npx, again, we can use Ionic to run capacitor, and we can also abbreviate it as cap. So we can run cap open Android, and this will open Android Studio, loading our new project. From here, we can run it in the emulator or on a real Android phone, but we've already seen how that works. Now, you may be asking yourself, if Ionic Serve and Ionic Build simply call React scripts, and Ionic Capacitor simply calls the capacitor command, what's the point of using the Ionic CLI? We could just use those other commands directly. Now, one small advantage is that with the Ionic CLI, we have a single tool that can do all those various tasks. So, for example, we can always run Ionic help and see the documentation for all the possible commands. But the Ionic CLI can also do things that no single other command can do. One particularly useful command is Ionic capacitor run. Let's look at the help for this command. If you remember from the previous section, to develop our app with live reload in Android, for example, we have to start the dev server first, then modify the capacitor.config.json, setting the right server URL, and so on. This Ionic capacitor run can do everything for us if we pass the live reload option. You can read the full documentation on your own if you like, but we can call this command with Ionic capacitor run, platform, and then options. There are also some examples at the bottom. Before we run this command, let me open capacitor.config.json. Again, this is where we manually set the server URL to enable live reload. Now let's try running the app in Android with live reload. -L is just a short version of live reload, and the external option is so that it will use the external IP address of the development server. Otherwise, it will try to connect to localhost that doesn't work from an Android device. So if we run this, notice that it launched React scripts start that will start the development server. And then it automatically opens Android Studio, so we can run the Android app from here. But before we do that, let's have a look at capacitor.config.json. You can see that it automatically added the server URL and also clear text true that allows clear text traffic, like we manually did by editing the Android manifest.xml. So let's try running it in the Android emulator. Let me just resize this window so it doesn't hide the emulator. Now, if we click the Run button, at some point we'll see our app starting, and notice the toast message with the server URL. Here's our app running in Android. Now, to test live reload, let's go back to Visual Studio Code, and we can open the home page. Just for a quick test, we could change the title to say My Modified App, and as soon as we save, this should trigger a reload. In fact, we can see the modified title in the emulator. Okay, so live reload with the Ionic CLI works. We can stop this Android app now. And if we go back to Visual Studio Code, let me show you what happens to capacitor.config.json if we stop the dev server with Ctrl+C. Note how the server section has been automatically removed from the capacitor configuration. So the Ionic CLI automatically modifies the capacitor.config.json to enable live reload, but then it also automatically reverts the changes when it's finished. So this is a very useful command. I usually add it to the scripts in package.json, so I don't have to type the whole thing every time. And of course, it also works for iOS if you simply replace Android with iOS in the command arguments. This shows how the Ionic CLI acts as an orchestration tool. It doesn't simply call other commands, but it can also combine these other commands together, like starting the dev server with React scripts and opening the Android project with Capacitor with a configuration suitable for editing with live reload. As we've seen, the Ionic CLI generates a project that uses TypeScript code. It's obviously possible to use Ionic with plain JavaScript as well. That's what we did in our first examples, after all. But there isn't currently an option to tell the Ionic CLI not to use TypeScript when creating a new project. And there are some advantages in using TypeScript compared to plain JavaScript. So in this video, I'll give you like a 10-minute introduction to TypeScript for those of you who have never used it before. If you are already familiar with TypeScript, feel free to skip the rest of this video. So let's open our home component. That's what we see on the page. This file is almost entirely the same as a regular JavaScript file. The only TypeScript-specific feature is this type annotation that says that home is a React function component. But we'll see what a type annotation is in a minute. Let's start by removing everything from the content, so we can get rid of this import as well. And maybe let's add the ion padding class to this element, so we get some spacing around the content. Now, let's suppose that our app provides our users with an account where they can keep some money. So in this home page, we want to display the balance available to this user. And this balance will be a value that we get from somewhere, like from a backend API. But for this example, let's just hard code a value here, say 123. And then in the content, we'll simply display the value of this variable. Now, if we save, we'll see your balance is 123. Nothing fancy so far. However, since 123 is a sum of money, we probably want to format this number appropriately. So we could write a function called formatMoney that takes the amount as a parameter and returns a string starting with a $sign, assuming this account only supports US dollars for now. And then we can concatenate the amount, but always displaying two decimal places, as is typical for dollar amounts. Now, this is just an example, of course. There are better ways to format currencies, but let's focus on the language features. You can see that the editor highlights an error here. It says that the parameter amount implicitly has any type. We'll see exactly what that means later. But in the project, there is a file called tsconfig.json. This is a configuration file used by TypeScript. You normally don't need to worry about this file, but there is an option here called strict, and it's currently set to true. If we change this to false, we can basically tell TypeScript not to be so strict with its checks. And if we save this change and go back to home.tsx, you can see that the error has gone away. Like I said, I'll give you a more detailed explanation later, but setting strict to false basically allows us to write regular JavaScript code without TypeScript complaining. So now we can use this function to format our balance. And if we save, we can see the value properly formatted as a dollar amount. So this is how we would write such a function in plain JavaScript. One of the limitations of JavaScript is that there's nothing stopping somebody from passing a string instead of a number here. We could set the balance to bananas, and we get no warnings whatsoever that there's something wrong with our code. It's only if we run this code in the browser that we get an error. In other words, we only get an error at runtime, not at compile time. And the error we get is not particularly clear either. It says amount to fixed is not a function. So we need to look at our code and think, why is toFixed not a function? Oh, that must be because amount is not a number. It would be easier if the error message just said, when calling the formatMoney function, you passed a string instead of a number. That would be so much nicer, right? Well, that's one of the things where TypeScript is better than JavaScript. With TypeScript, we can declare that amount should be a number. So the syntax is after the variable name, we write colon and the type. And this is called a type annotation. With this simple change, the editor now immediately shows us an error when we call formatMoney, politely telling us that we cannot pass the literal string bananas because the argument must be of type number. So we know exactly what we did wrong, and we can go and fix it by setting this to a number. And this should fix our application. Now, of course, this was a silly example, But imagine that you write a function in one file, and then sometime later somebody else tries to use your function, importing it into some other file. They could easily pass the wrong argument type by mistake. So that's one thing TypeScript helps with. And declaring the type also has another advantage. It helps the editor provide suggestions when we type. Since the editor now knows that amount is a number, it can show us all the methods we can call on a number. Visual Studio Code is using the TypeScript compiler to help us write our code. In addition to declaring the type of a parameter, we can also specify the return type of a function. In this case, we return a string. And by writing this type annotation, we also make it easier for somebody reading this code to immediately see what type of value is returned by this function. Now, even if we don't specify the types, the TypeScript compiler can still help us in some cases. TypeScript does something called type inference, which basically means that the compiler will try to automatically detect the type of each variable based on the rest of our code. For example, if we inspect this function, you can see that the compiler automatically figured out that this function returns a string. How does TypeScript know that? Well, after the return keyword, there is a literal string, followed by the plus sign, which in this context means string concatenation. So this expression can only possibly result in a string. However, if we look at the amount parameter, TypeScript here detects that it has type any. Any is a special type, which means that this variable can be anything, basically. It's a bit like saying we don't really know the type of this variable. And that's because the amount is passed in as an argument to this function. So we cannot really know what type this will be, because it depends on some other code elsewhere where this function is called. So in these cases, TypeScript uses this special type called any. And in fact, if you remember, any was mentioned in the error we got initially when we had strict set to true in tsconfig.json. If we enable the strict option again, we can have another look at that error now. It says parameter amount implicitly has an any type. So with strict enabled, TypeScript refuses to accept code if it cannot automatically determine a specific type and has to default to any. But note that the error said implicitly. We can still decide to explicitly set the type to any. And in this case, there are no errors, even with strict enabled. So we are allowed to use any as a type in our annotations. And this can be used as a quick and dirty way to avoid compiler errors. We are basically telling TypeScript, don't worry about checking the type of this variable. We'll take care of that in our code. We know what we're doing. But most of the time, if we write a type annotation, we want to use a specific type like number. Now let's go and disable the strict checks again, because I want to show you another TypeScript feature. Suppose that instead of only supporting US dollars, our app now supports multiple currencies. So instead of a number, our balance could be an object that has a currency property with a currency symbol like British pounds, and then the amount that can be the number we had before. This way, different users could have their balance in different currencies. In that case, we'll also need to change our format function, because we won't receive a simple amount number anymore, but an object that we can call money. And let's not specify the type for now. Then instead of amount, we can use money.amount, and instead of the dollar symbol, we want to prefix it with whatever the currency is for this object. So this is how we could write this function in plain JavaScript without types. And if we save this new implementation, we can see our balance in pound sterling. And if we change the currency to dollars, of course it will be formatted with a dollar sign. Now imagine that somebody is trying to use our function, but for some reason in their object they forget to include the currency. At this point, we see no compile time errors, and if we save, so the code runs in the browser, we see no runtime errors either, but we'll show the user a balance of undefined 123, which is of course pretty bad. In a sense, this case is even worse than our first example, because here we don't even get an error, we just display the wrong thing to the user. Anyway, let's see how we can improve the situation by using TypeScript. We want to declare the type for our money parameter, but what should that type be? Well, we expect it to be an object with currency and amount properties, but there is no predefined type for that. It's not like a simple number or string. So in these cases, we can effectively create our own custom type by defining an interface. We need to give it a name, like money, and then we can declare which properties it should have. For example, we want a currency property that is of type string, and another property called amount that is a number. So an interface is just a definition. It describes which properties an object should have in order to be considered a valid instance of, in this case, money. Now that we have this interface, we can declare this parameter as of type money. As soon as we do that, we can see an error when we call the formatMoney function. And the message says that the argument is not of the right type. In particular, property currency is missing. So we get quite clear instructions on what we should do to fix this problem. We need to add a currency property here. And with this, our app should be working again, working as displaying the right information. And again, by using types, we get the additional benefit of the editor providing auto-completion. It knows that a money instance has these properties, and if we select amount, for example, of course, it also knows that amount is a number, so these are the available methods. This does make our life as developers easier. By the way, we could re-add the return type here as well. Okay, so this was a very quick introduction to TypeScript. There are a ton of other features in the TypeScript language. In this video, I really just wanted to give you a taste of why you may want to use TypeScript. We will be using TypeScript to build our next application starting from the next section, but we'll keep the strict option disabled so we don't have to declare types everywhere. You should be able to follow along even if you're just a beginner with TypeScript. However, I do recommend taking a full course specifically on TypeScript if you want to learn the full power of this language, because we only just scratched the surface in this video. In this section, we'll start developing a new app called Daily Moments. The idea is to let our users capture a moment of their life every day in the form of a picture and some text, and then let them review all their daily moments every once in a while. A sort of journal, but with pictures, if you like. This will be a more sophisticated example that will include multiple pages, backend integration, and more. For this reason, we'll build it over the course of a few different sections. In this section, we'll cover page navigation and routing. We'll see how to handle multiple pages in our app, navigate between them, restrict access to some pages, and so on. In the next section, we'll start integrating with a backend using Google Firebase. And in particular, we'll see how to handle user authentication. After that, we'll learn how to store data in the database provided by Firebase. That's called Cloud Firestore. Finally, we'll add the ability to take or upload some pictures to our app, and we'll save them into cloud storage. That's another service provided by Firebase. So let's get started. As usual, I'm providing you with an initial project as the starting point. This time, however, I created this project using the Ionic CLI, so it will have the same structure we've seen in the previous section. Now let's open a terminal and get the initial project. I'll go into my projects folder first, and like for our previous examples, we can use npx-get to download the project that's available on GitLab under the Ionic React course group, and it's called Daily Moments. Let's not forget to pass the local folder where we want to save it, which we can also call Daily Moments. And we should now have a Daily Moments folder here. So we can go into the project folder. This time I'm going to run npm install from here. Let's wait a minute or two. Okay, it has downloaded all the necessary packages. Now we can open the current folder in Visual Studio Code, and we can see our new project here. As I mentioned, this was generated using the Ionic CLI. So if we look at package.json, this already contains all the dependencies required by a typical Ionic project. I have moved some of the packages into dev dependencies, like we did in the previous section. I also removed the test dependencies just to simplify the project, and updated the scripts to use the Ionic command. Now, if we go and look into the source folder, here we have our index.tsx, so we are using TypeScript in this project. Here I moved all the CSS imports, added the code to hide the splash screen, basically done the same adjustments I suggested in the previous section. If we look at app.tsx, however, this will be a bit different from the code generated by the Ionic CLI. Here we have a simple self-contained Ion app component, similar to what we used in our previous examples. So this doesn't use the router yet, because I want to show you how to set up routing step by step, starting from the next video. I said we'll use TypeScript for this project, but I did disable the strict option in tsconfig.json. This way we're not forced to use type annotations everywhere. We'll declare variable types when they're most useful, but sometimes we'll omit them for the sake of simplicity. Now let's go and start our application from a terminal. Here we can simply run npm start. This will execute Ionic serve and launch the development server. Okay, we have our app running in the browser. Now let me arrange the windows to show the editor and Chrome side by side, and we're all set up. We're ready to start editing this code. In the next video, we'll begin by introducing the router. In all our examples so far, our app consisted of a single screen. All the functionality was visible in just one page. But in a more complex application, we may need multiple screens. Let's go and create a new folder called Pages, which is where we'll keep our page components. Now, each page is very similar to our existing app component. So let's copy this file, paste it into the Pages folder, and rename it to Home Page, for example. Let's change the component name. That's exported at the bottom. And let's change the title to say Home. Now, we cannot use multiple Ion app components. An Ionic app must have a single Ion app at the root of the React component tree. If we want multiple pages, we need to wrap each one in an Ion page component. Of course, we also need to import it and replace this closing tag. We can also remove Ion app now. We're not using it anymore. So this is what we mean when we talk about pages in an Ionic application. A page is simply a React component that renders a full page on the screen, and it must have an Ion page as its top-level JSX element. So now that we have a page, how do we use it? Let's start by importing it into our app component. It's under the Pages folder. And now we can take this home page component and display it inside the Ion app, replacing everything else. Let's remove these unused imports. And if we save this file now, you can see that the title in the app toolbar now says Home. So it's displaying our new home page. That's good, but we still have only one page. Let's go and add another one. I'll just duplicate the home page and rename it to Settings page, for example. Most apps have a settings screen where users can edit their preferences. Let's change the title, so at least there's something different about this page. And now we can go and import it into our app component. Just to make sure that it works, let's display the settings page instead of the home page. And of course, we now see settings as the title in the browser. But so far, we're still showing just one page. It's either the home page or the settings page. To actually use more than one page, we'll need to use a router. If you're an experienced React developer, you probably used the React router before. And that's what Ionic uses as well. If we go and look at the package.json file, you can see that here we already have the React router packages installed. Any project generated with the Ionic CLI already has these libraries. So we can simply use them in our code by importing some components from React Router DOM. The DOM package provides the implementation that works with standard web browsers. First of all, we need the browser router component, and we can add it inside our Ion app. The router will contain some route definitions, so let's import the route component, and we can add a first route inside browser router. On the route, we want to set the path attribute, that is the URL path. Let's start with /, that means the root of our application. And we also want to set the exact attribute, meaning that we want this route to be applied if the path is exactly /. Without exact, it would match any path starting with /. That's not usually what you want. We can leave out the attribute value, which means it's set to true. It's nicer to read this way. Anyway, inside the route, we can put the component we want to display, for example, the home page. So this route definition says that if the path in the browser URL is /, then we'll show the home page. Let's save and see if this works. There you go. We see the home page. Now let's add another route. Just duplicate the existing one. This time we want to map it to the /settings path. And in this case, we want to display the settings page component. If we save now, we still see the home page because that's mapped to the root URL. But if we change the location to /settings, then we see the settings page. And if we go to the root again, of course, we see the home page again. So that's the essence of what a router does. It displays a different component depending on the path in the browser location. Now, let's see another small feature. Perhaps we'd like to map the home page component to the /home path, just to have consistent naming between components and paths. If we do that, then of course we'll need to enter /home in the URL if we want to see the home page. And that's fine, but if we go to the root path, we just see an empty page. That's because we have no route mapped to the root path. What we can do in this case is use a redirect that's available as another component. We can use it a bit like the route component. So we add it as another router child, and like a route, we can set it to match an exact path, in this case / or the root path. But then we can set a to attribute, which means where to redirect to, for example, /home. And if we apply these changes, then we see the home page. And note how the browser location went to /home. Let's try again. If we request /, we get redirected to /home, which maps to the home page component. So that's how redirects work. Now, entering the path manually in the browser location is not very user-friendly. So let's go and add some links. In the home page, we can say go to, and here we can use a link component. That's exported by React Router DOM, as you can see. We can link to /settings. That's the settings page. Now we see a link on the page, and if we click on it, of course, we go to the settings page, and the location updates as well. And we can use the back button to see the previous page. Now, it's important to understand that this is all happening on the client side. It's not like a regular HTTP link where the browser requests a different page from the server. With this link tag and React Router, we are always on the same server page, but we're using JavaScript to change the browser location and to display a different React component. So when I talk about Ionic pages, they're not different HTML files coming from the server, they're just different React components, but they're all rendered inside our app. Anyway, let's put a similar link in the settings page as well. I need to import the tag first, and from here we can link to the home page. And now we can go from home to settings, and to home, and to settings again. And of course, we can also navigate backwards. So it works exactly like you would expect multiple pages to work in the browser, but it's all happening inside our React app, thanks to these route definitions. We added a couple of pages to our app and set up some routing, so we can navigate between the home page and the settings page, and the browser back button also works as you would expect. We started by using the React Router library that works with any React app. But Ionic also provides some additional features on top of React Router if you use a component called Ion React Router. Let's see how that works. First of all, it's worth mentioning that the necessary libraries are already installed if you generate a project using the Ionic CLI. You can see that in addition to Ionic React, there's a package called Ionic React Router. If you have a project that was not generated with the Ionic CLI, obviously you'll need to install those packages yourself. Now let's import that Ion React Router. That's in the Ionic React Router module. And we can use it instead of the browser router. The Ionic router is built on top of the regular React router, and we can use it in a similar way. There is one difference though. With the Ionic router, we need to wrap our pages, or better, the routes containing our pages, in another component called Ion Router Outlet. It's an outlet in the sense that it's the place where Ionic pages will be inserted. And as we'll see, what this Ion Router Outlet does is it adds some transition effects whenever we navigate from one page to another. Let's remove this unused browser router import, and then we can see the Ionic router in action. Let's save this file. And there's no visible change so far, but if we navigate to the settings page, did you notice that little animation? it's like the new page slides up from the bottom. And if we go back, we should see pretty much the reverse. The settings page slides down to reveal the previous page. These animations simulate what native mobile apps do. And if we select an iOS device, we should see some other transitions different from those used on Android. If we go forward to settings, you can see that this time the new page slides in from the right, while if we go back, it slides out to where it came from. Not only that, but on iOS, you can also swipe the page with your finger, and this gesture causes it to go back to the previous page. So all these nice animation effects are what the Ionic router provides. Now, with React router, we used this link component. This works fine, but Ionic also has its own component called Ion Router Link that does the same thing but uses the Ionic styles. And instead of a to attribute, it has one called router link. So this replaces the React router link. The only visible difference is the style. The link text has no underline now. Let's use this Ion router link in the other page as well, just to be consistent. We need to import it, change the link to /home, and remove the old import. Okay, that's it. Obviously, it works just like it did before. So this is the Ionic React router in action. On the surface, it looks very similar to the standard React router. We just need to use Ion React router instead of browser router and add an Ion router outlet. But under the hood, it's actually quite different because it provides all those transition effects when we navigate between pages, and that's not as easy as it seems. So we have two pages in our app, and we can navigate from one to the other by clicking these links on the page. However, in a typical mobile app, there is usually a more structured way to access different screens. In this example, we'll use tabs as the main navigation mechanism. Ionic provides an Ion tabs component that you should also have seen in action when looking at the different project templates available with the Ionic CLI. In any case, we'll now see how to add it to our code. We can add the Ion tabs component inside the Ion React router. The router comes first because Ion tabs also needs to use the router functionality. But the Ion router outlet will be inside the Ion tabs because the outlet is where Ion pages are inserted, and we want each page to be displayed as the tab contents. In addition to the outlet, we want an Ion tab bar, and this component accepts a slot attribute where we can say if we want the bar at the top or at the bottom of the page. Usually it's at the bottom. Inside the tab bar, we can add Ion tab buttons. And on each button, we need to set a tab attribute. This tab is actually just an ID that's used internally by Ionic to identify each tab. So we could pass any string as long as it's different for each tab button. But let's put something meaningful like home. And then we can set a href attribute that's the link to this tab. So here we can put /home. This obviously needs to match the path of the home page route defined above. And finally, we have the button contents, where we can use an Ion label to show some text saying home. So this is one button. Now let's add another one. This time we want both the tab ID and the href to be settings. And the label will also say settings. Okay, let's save and see what this looks like. We can see the two tabs at the bottom of the page, and Home is currently selected. If we tap Settings, of course, we go to the Settings page, and if we select Home, we see the home page again. Good, that works. Now, we can make it look nicer by using some icons for the tab buttons. So let's import the icons from Ionicons/icons. Don't forget that part. And Ionicons include a home icon and also a settings icon, because they're so frequently used in pretty much any mobile app. Okay, now that we've imported the icons, let's go and use them. We can add an Ion icon component inside the tab button, passing the right icon. Here we want the home icon. And then we can do the same thing for the other tab button as well, except that this one will show the settings icon. Okay, let's save and see what the results are. It definitely looks better now. Note how the text is now below the icon in a much smaller font. Of course, navigating to the tabs should still work exactly as before. Good. Now that we have tabs, we don't really need those links inside the page, so we might as well remove them. Let's get rid of this Ion router link. I'll just write some placeholder text for now. And we can remove the import. Let's quickly do the same on the settings page as well, just to be consistent. Remove Ion router link. And that's it. All done. And everything works. So this is how we can use tabs in our application. Ion tabs contains the Ion router outlet, so the router will decide which page to display as the tab contents depending on the URL path. But we always display the Ion tab bar at the bottom. Okay, we added tabs to our app. Now it's time to display some content in this home page. In many apps, we frequently need to display lists of items. So let's go and create some dummy data, just as an example. Let's keep it in a data.ts file for now. And here we could export a variable named entries, that is an array. Each element in the array will be an object with an ID that uniquely identifies each entry. Then we could have a title property saying, for example, first entry, and a description that's usually some longer text. The entries array might contain a few of these objects. Let's change the values to have ID 2 and second as the text for the second entry, and ID 3 with third for the last entry. Usually we'll fetch this sort of data from an API, but in any case, once we do have this data, how do we display it on the page? Let's start by importing our entries from our data module. And we use ... because we are inside the pages folder, but data.ts is up one level. Anyway, we do have the data, now let's use it. In the page content, we can use an Ion list component. And inside Ion list, we want to iterate through each entry in the entries array. And for each entry, render an Ion item component. As the item content, we could simply display the item title. And if we save this, we see the entry titles on the page. If we show the JavaScript console, there's just one small problem though. React is complaining that each child in a list should have a unique key prop, which is a reminder that whenever we render a list of React components, we need to set this key prop to be a unique value. And thankfully, each entry has an ID that's unique. So we can use that one as the key. If we check the console again, the error has gone away. So always remember to add the key prop on list items. Now, what if we want each item in the list to link to another page showing the details for that entry? At the moment, these items are not clickable. If I try tapping them, nothing happens. To make an Ion item clickable, we simply need to add the button attribute. And if we do that, you can see that each item now shows a little arrow or chevron on the right, a list using the iOS style. This is a hint that we can select each item to see more details. Of course, to actually make each item do something when we click it, we'll need to add an event handler, like onClick. But if we simply want to link to another page, we can use the router link attribute instead and pass the URL of the page. For example, we could have a path for each page that is /entries/ and the entry ID, like 1. But the ID should be different for each entry. So let's use a template string instead and insert the entry ID as a template variable. Let me just split this into separate lines. Okay, so this should work. If we go and try tapping on an item now, it's not immediately obvious, but the path in the location bar has changed to /entries/1. We still see the home page because we don't have any route mapped to the /entries/1 path, so the router cannot display a different component. Anyway, if we select the second entry, we'll go to /entries/2 and so on. So each item is linking to the right URL. Next, we'll need to add another page to show the entry details and map it to the right path. But we'll do that in the next video. For now, this code shows how to use an Ion list that contains clickable Ion items. Our homepage is now showing a list of entries, and if you click on an entry, it should show you another page with the details for that entry. But we haven't created that page yet, so that's what we'll do in this video. We'll need to add a new route, similar to what we did for the homepage, matching the URL path for an entry. But first of all, we need to add a new component page. I'm going to clone the settings page as a starting point and rename this copy to entry page. Let's update the name in this new file and change the text to say entry as well. Okay, now let's go back to our app component where we set up the routing, and we want to import the new page that's called entry page. Let me collapse the imports again. Now we want to add another route that renders the new entry page component when the path is /entries/1, for example. And if we save these changes, we can see our new entry page because the browser location is exactly /entries/1. However, if we go back to the list and select the second entry, that doesn't work so well because the path is now /entries/2, not /1. But in our route definition, we only match /1. To do a wildcard match, we can use this special notation. We write colon and then a parameter name. In this case, we can call it ID. And if we save this, you can see that it's showing the entry page even for /entries/2. And if we go back to home and select the third entry, that also shows the entry page. Of course, it should still work for first entry as well. We can enter literally any string like XYZ and it will still show the entry page because the wildcard matches anything. Now let's go back to home and see how we can use that parameter passed in the path inside our entry page. Because here we want to know which entry to display, right? We can call the useParams hook provided by React Router, and this will return an object containing any parameters passed in the URL. In this case, we know that we expect an ID, and just to check if this works, let's display the ID in the title, like this. If we select an entry now, this says entry 1. And if we select the second one, now it says entry 2. Again, we can even ask for /entries/xyz, and it will happily show xyz as the param value. Whatever we pass in the URL will be available to our page. Of course, if you open the entry page from our home page, you can only request a valid ID, not something like xyz. Anyway, when using TypeScript, we can also declare an interface that describes which params we expect to receive in this page. So here we simply expect an ID that is of type string. And once we have this interface, we can pass it as a type argument to useParams. This way, the TypeScript compiler can check that we are using the right params. It also gives us auto-completion in the editor, and just makes it easier when looking at the code to see which params are expected. Now, in this page, we're showing the entry ID, but we should really display all the entry details like title and description. So let's go and import the entries array from our data file, and then we can use this data. We know the entry ID, so we can get the right entry by using the find method on the array. And we're looking for the entry with the same ID as the one we get as a route param. Once we have the entry object, we can display the entry.title here. There's an error though. TypeScript is complaining that the object is possibly undefined. That's because when we call find, this method can return undefined if there is no entry with the right ID. So as a quick fix, let's check if there is no entry, then just throw a new error saying no such entry and the ID. This code is only temporary anyway. We're using some dummy data at the moment. We'll replace it with some real data later on. But this should work. Entry will always be defined at this point in the code. And we can also replace this content with the entry description. Okay, let's save and go and test it. Let's start from the first entry. We can now see both the right title and description in the entry page. Good. And if we try another entry, of course, we see a different title and description. All right, so that's how we can use parameters in our route definitions. Using React hooks, we can access the values simply by calling useParams. But of course, we need to make sure that the parameter name that we use in the page must be exactly the same as the one we use in our route definition, using this special notation with colon followed by the param name. We added an entry page, so we can select an item in this list and see the details for that entry. And we've seen how to use route params to get the right entry ID. Now, there's just one minor issue. If you notice, the Home tab is currently selected, and that's good because we access this entry page from the Home page, so it makes sense that it's under the same tab. However, if we load this page directly, then the Home tab is no longer selected. That's a bit weird. The reason is that if we look at our app component, the Home tab button is associated with the /home path, but the path for the entry page does not start with /home. So if we go directly to that page, the Ion tabs component has no way of knowing that it should select the Home tab. We could change the home page to be visible at /entries. And in that case, we also need to redirect to /entries from the root path and use /entries for the Home tab button. This way, when we load /entries/1, the Home tab is marked as selected, because basically anything under /entries is now considered part of the Home button. If we go to the root path, we now get redirected to /entries that shows the home page. That's just a small thing, but our tab button works better this way. Now, there's another improvement we can make. When we go to the entry page, it's not immediately obvious how we can go back if we're using an iOS device. Because if we build our app for iOS, when it's running in a web view, we don't see the browser back button, and iPhones don't have a physical back button either. Now, you can go back by swiping the page, but that's not so obvious. What we can do is add a back button to our page using this Ionic component. Let's see how this works. If we go back to our entry page, we can add the back button inside the Ion toolbar. First, we need an Ion buttons component that represents a group of buttons, and we need to specify a slot, meaning if we want it at the start or at the end of the toolbar. The back button should be at the start. And finally, we can add the Ion back button component. This doesn't need any attributes. Okay, so if we go to the entry page now, we can see a back link in the top left corner. And if we tap it, we go back to the home page. As always, Ionic will use different styles depending on the platform. So if we run it on Android, we'll see a different sort of back button. In this case, it's just an arrow without any text. But that's pretty much all there is to know about the back button. Just add it inside the toolbar to let your users know when they can navigate back to the previous page. At this point, our app has a few different pages, and we can navigate between them in an intuitive way. In the home page, we see a list of entries. We can select an entry and see its details, go back, and we also have a Settings tab along with the Home one. So we're making good progress in building a generic app skeleton. What we're still missing is any sort of authentication. If these entries are personal data entered by the user, then we probably want the user to log in before they can see any of these pages. So let's see how we can add some login functionality. Let's start by creating a login page. I'll clone the settings page since it's almost empty, and then just change the component name and the title to say login. As for the content, let's add a button in this case, saying login. And let's style this button a little bit by setting expand to block. Okay, this is a mock version of a login page. Normally, you would ask the user to enter their email and password, but just to test our navigation flow, for now we'll let our users log in simply by clicking this button. Now let's go and import this new page into our app component. Let's import the login page so we can map it to a path in our routing configuration. Let's add another route with a path of /login that renders the login page. Okay, let's save these changes and do a quick test. If we go to /login, we see our new page and there's a login button, but if we click it, nothing happens yet. Now let's add some functionality. What we want to do is keep track of whether the user is logged in or not. So let's add a state variable for that, initially set to false, meaning that the user is not logged in. I'm also going to print this logged in state to the console to help us understand what's going on. So what we're trying to do is prevent the user from accessing, for example, the home page unless they are logged in. One way to do that could be just to check this logged in flag here, and if logged in is true, then we display the home page. Otherwise, we could redirect the user to the login page that's at the /login path. We used this redirect component before, but in this case we're using it as a child of a route. Let's save and see what happens now. If we start from the root path, we get redirected to the login page, because logged in is false, as we can see in the DevTools console. Next, we need to be able to actually log in, so let's add some functionality to this login page. When the user clicks the login button, we want to set logged in to true. But the logged in state is not in this component, it's in the app component. Let's add an interface declaring which props we accept in this component. What we want to do is pass an event handler function from our app component to this login page. So we could have an onLogin prop that's a function, and it returns void, meaning that it doesn't need to return anything. The reason why we define this interface is so that we can parameterize this React FC type, where FC stands for function component. We can pass our props interface as a type argument, and this way TypeScript knows which props are allowed here. You can see that it suggests onLogin. It also shows children as an option because all React components can have children. But onLogin is the only custom prop. Now that we have this prop, we can use it in response to the onClick event. We can pass onLogin directly here because it's already a function. So whenever the user clicks this button, the onLogin function will be called. Now the page shows a compile error, but that's just because we haven't updated our app component yet. We need to pass the onLogin prop that's now required. And what we want to do in this case is set logged in to true. This should update the component state and treat the user as logged in. Let's see what happens if we start from the root path again. We see the login page, and if we click login, if you look at the console, you can see that logged in is now true. However, we still see the login page, so we're not quite done yet. If the user is logged in, then we shouldn't display the login page. We could use the same trick we used for the home page, check the logged in flag, and if it's true, then redirect to /entries, that's the home page. Otherwise, render the login page. In other words, the login page should only be displayed if logged in is false. Let's see if this works. Let's start from the root again. Click login. And this time we can see the list of entries in the home page. Of course, we can also navigate to the other pages as well. There's just a message in the console saying no Ion page was found to render. That's a warning, it's not an error, but it happens because the Ionic router always expects an Ion page, but at some point we return a redirect component instead. It's not a real problem because the redirect will simply forward to another page. But warning apart, I don't really like having this conditional logic inside the JSX code. Let's try moving that functionality inside the login page. We could add another prop here with the logged in status, that's a boolean. So we'll receive this logged in flag, and we can use it to check if we are already logged in, then return a redirect from here, sending the user to the /entries page. Ideally, we could pass the path where to redirect to as another prop instead of hard-coding it here, but this will do for now. Next, let's update the app component. Here we can remove this condition and always display the login page inside this route. But we also need to pass the logged in state as a prop. There you go. Let me split this line because it's too long now. All right, let's see how it works now. Let's start from the root path as usual. We get the login page, click login, and we go to the home page. And of course, we should still be able to see all the other pages as well. Okay, I think we achieved our main goal. That was forcing users to log in before they can access the home page. We're doing that by keeping a logged in state variable and redirecting to the login page if the user is not logged in. In the next video, we'll make some improvements to this basic structure. We started adding support for authentication to our navigation flow. So now, when the user first opens the app, they'll be presented with a login page before they can do anything else. It's not quite perfect though, because on this page we'll still see the tabs at the bottom, even though we shouldn't be able to go anywhere without logging in first. There's also a bigger problem. Only logged-in users should be able to see an entry details, but if somebody goes directly to this page, there is no login required in this case. It should work like it does if we try opening the /entries path and redirect to the login page. Let's see how we can fix these issues. To protect the other pages, we could use the same logic that we have on this route. Check the logged in flag first, and if it's false, then redirect to /login. However, that wouldn't solve the other problem. That is, that we see the tabs at the bottom of the login page. We could hide the tabs somehow, maybe using CSS styles, but there's another approach that I think is more elegant. We can have a clear separation between pages that anybody can see, like the login page, and pages that only logged-in users can see, like the home page. If we make all the paths we want to protect to begin with the same prefix, I like to use /my, so it reads my entries, which immediately gives the idea that this is a personalized page. And we want to use the same prefix for the entry page and for the settings as well. Of course, we'll also need to update all references to those paths, the root redirect and the tab button links. Okay, I think that's it for this file. To test it out, I'm going to change logged in to be true by default, so we don't need to go through the login page every time. Let's start from the root path. We now get redirected to my entries, which is good. We should probably check the other pages to see if there are more paths that need updating. The login page should redirect to my entries. In the home page, we link to each individual entry, so we need to add /my here. And in the entry page, I don't think we have any links. Nothing to change there. Okay, so the home page is fine. Now let's go to an entry page. That works as well. Let's try settings. All good. The home tab also works as expected. Okay, all the private pages start with /my. What this allows us to do now is to move everything that uses tabs into a separate component. Let's duplicate the app component and create an app tabs component. Let's update the component name first. Here and the export at the bottom. Now, in this component, we want to keep only what's inside the tabs, so no need to keep any state, and we don't want Ion app and the router either. Let's remove the closing tags as well. And now I'm trying to reindent this whole block. Right. Next, we don't want the login page here because when you log in, you shouldn't see the tabs. And also remove this condition. We'll always display the home page if you get to this point. Okay, I think that's it. Now we need to remove all the unused imports though. Otherwise we'll see a lot of warnings every time we load the app. Okay, that's everything. So this component provides the Ion tabs and all the private pages that can be displayed as tab contents. Now let's go and use it in the app component. We'll need to import it first, of course. It's called app tabs. And it's not under pages because it's not a page component. Now what we want to do is remove Ion tabs from here and adjust the indentation accordingly. We'll keep the /login route here, but let's remove all these private routes that are now inside app tabs. And we don't want the Ion tab bar either. We don't want the tab buttons to always be visible. This way, when we go to the login page, it will not show the tabs. But now we're going to add a new route with a path set to /my. And note that I'm not setting the exact attribute in this case, because we want to match any path starting with /my, because this route will render the app tabs component. So hopefully now it should be clear why we renamed all those paths to have the same prefix, because that allows us to group all the private pages into this app tabs component that is mapped to the /my prefix. At this point, we'll have quite a few unused imports in this file. Let's remove them all. Last one. All done. All right, so we now have two levels of routing, if you like. The top level is here, and the second level in app tabs, handling everything under the /my prefix. Let's give it a try. As always, we want to start from the root of our application, and we get redirected to the home page as expected. If we go to an individual entry, we see the details for that entry. We can go back, go to Settings, go to the Home tab. It's all working as before. So our changes didn't break anything, at least. Now, if we change logged in to be initially false, as it should be, in theory we expect to see the login page, but that doesn't work now because we removed the redirect. Let's take the same approach we used for the login page and pass the logged in state down as a prop to the app tabs component. And then we'll need to update app tabs accordingly, of course. Let's declare logged in as a Boolean prop and parameterize this component with the expected props interface. Then we can actually extract logged in from the props argument and use this to check if the user is not logged in which case we want to redirect to the /login path. And if we save this change, you can see that now we get redirected to the login page. And notice how we no longer see the tabs on this page. Let's check the console messages and start from the root path once again. If we log in, then we can see the home page and also the entry page. But if we try opening this entry directly, then we get redirected to the login page again. So there's no way to bypass the login now. All our private pages are properly secured because we're now checking if the user is logged in this app tabs component. So the check applies to any route under the /my path. Incidentally, you can delete this redirect as well. I only realized that while editing the video, sorry. But the root path will never be matched here because it does not start with /my. Anyway, The important thing is that the Ion router outlet in this file decides exactly which page to display between these three routes. Also, it always displays the tabs at the bottom, while the app component has another Ion router outlet that handles the top-level paths. And for all the paths starting with /my, it just delegates to the app tabs. This way, we have a clear separation between the pages that are visible to all users, like /login, and the pages that are only visible to users who are already logged in, all managed inside app tabs. In the previous video, we split our pages into two groups. Those that are visible to anyone, like the login page, are at the app top level, while all those that should only be visible after logging in are now in this app tabs component. Now back to the app component. Here we keep the logged in state, and it needs to be at the app level because it applies to the whole application. But then we pass it down as a prop to any other component that requires it. This is fine as long as we only need it in a couple of places. But if we need to use some state across many components, we can use the React context instead of passing it down as props. In our app, we'll need to use some information about the user in almost all our pages, so it's worth putting it on the context. Let's start by creating a new file. Let's call it auth.ts, since it will contain code for authentication. To use the React context, we'll need to import React first, unsurprisingly. And now we can define our own auth context by calling the React create context function. As argument, we need to pass a default value, and we can pass an object with logged in set to false. I'm using an object here so we can add other properties later on if we want to. In fact, as we'll see, we will need at least the user ID to be able to fetch data for a particular user. But let's not get ahead of ourselves. For now, we just want to use our new auth context. So let's import it into our app component, and then we can use it in this file. Since we want the context to be available to all our components, we want to wrap pretty much everything in an auth context provider. It's a provider in the sense that it provides the context to all the components inside it. Now, TypeScript is telling us that we're missing the value property here. So let's go and add that property. And here we need to pass the value of our context. So let's pass an object containing the logged in state variable. Okay, now this context should be available to all other components. So in the login page, for example, instead of getting the logged in state as a prop, we can get it from the context, provided that we import auth context first from our auth module. Now we can use a React hook called useContext, passing our auth context as argument. And this hook will return the current value for the auth context. TypeScript has inferred that it's an object with a logged-in Boolean property. So let's extract that logged-in property from the object returned by useContext. Now we have two logged-in variables, so let's remove the component prop that's no longer needed. And we can save these changes and test if everything still works. If we start from the root, we are redirected to the login page because logged in is false. And if we click login, we see the home page because logged in is now true. So it's all working as expected. We can now remove logged in from this props interface, which means that in the app component, we shouldn't pass this prop down to the login page anymore. This simplifies the code a little bit. Now, I'd like to make another bit of refactoring and write a custom hook to replace this bit of code, because the login page only needs the logged in state. It doesn't need to know if it's kept in the React context or somewhere else. We can hide the implementation here in our auth module by writing a custom hook called useAuth. Here we can simply return the result of calling useContext, passing auth context as argument. So we simply moved the same logic we had in the login page in a custom React hook. This way, instead of importing auth context, we can import the useAuth hook and simply call useAuth instead of useContext. This way, this component no longer has to worry about React context. It just calls useAuth and gets the value it needs. Now, let's use the same approach in app tabs as well. This component also uses the logged in state. We can remove it from the props. I'll need to import useAuth though. Okay. We can also delete this props interface, since we're not using any props now. Let's save the changes and go and update the app component. Here we don't need to pass the logged in prop anymore. And that's it, I believe. There's just a warning in the console saying that useContext is never used in the login page. So let me go and remove that unused import then. Here it is. Let's see if that fixes it. I'll probably just need to reload the page. There you go, the warning is gone. Now let's test the login flow again. We are logged in, we can see an entry, but if we open this page directly, we're sent back to the login page. Good, everything is working fine. Just to recap, in the app component we make the auth context available across our app by using the auth context provider and passing the current value to keep in the context. This way, all other components, like app tabs, can access that value by simply calling our useAuth hook, which is defined in our auth module. Here we use React create context to initialize the auth context, and then useAuth simply calls useContext to retrieve its value. Our app skeleton now includes a convenient way to share the authentication state across all components. In this video, we'll make one final improvement to our routing setup. At the moment, if somebody requests a page that doesn't exist, like XYZ, then all they see is a blank page. And note that there are no errors in the DevTools console either. This is just the way the router works. If there are no routes matching the path, then no components will be rendered. If we want to display a message saying page not found or similar, then we'll need a page component to handle that case. Let's add a not found page. And as usual, I'm using the settings page as a starting point and then rename it. As for the title, well, maybe we don't need a header at all in this page. Let's keep it very basic. Let's just display a simple message saying page not found. Okay, so this is our page. Let's save. And then we can go to our app component and add it to our route definitions. Now, at the moment, we're using an Ion router outlet here, but it's more convenient if we use a switch component from the standard React router. With a switch, we don't get the Ionic animation effects provided by Ion router outlet, but it has the advantage that it always renders a single route, even if there are multiple routes matching the requested path. That's useful because we're now going to add a new route without specifying a path. So this matches every possible path. And here we're going to render our new not found page. Now, because we're using a switch, this last route will only be used if none of the other routes matches. So it will only be used as a last resort. And in fact, you can see that we now get the page not found message, because no other route matches this XYZ path. If we request the root path instead, we're sent to the login page as usual. And everything else should work as before, meaning that all the other routes are not affected by our latest changes. So this is how we can handle the page not found case. We use a switch component here because we want to match a single route exclusively, and before the user logs in, we don't really need the page transition effects that are what the Ion router outlet provides. We still use an outlet in app tabs, so we will see the animations when we navigate between the pages defined inside this component, that is effectively on all pages after the user has logged in. In this section, we'll start integrating with a backend, and to avoid having to write our own server applications, we'll use Firebase as a hosted backend platform. Firebase is offered by Google, and it provides a number of services that can be useful to develop mobile or web apps. You can see the full list here, but what we're going to use in our own app is the authentication service for managing users. We'll use Cloud Firestore, that's a database where we can store pretty much any data we like, and we'll use Cloud Storage, that's for hosting larger files such as images and videos. Now, Firebase is a commercial product, but it does include a free plan. So you can use it to follow along with the course without having to pay anything. There are some limits with the free plan. For example, in the Firestore database, you can only store up to 1 GB of data. But that's more than enough for our sample application. Now, Firebase obviously comes with its documentation pages. And you can use Firebase from different languages and platforms like native Android or iOS. But we want to use it in a web application. Even if we can build it as a mobile app, our Ionic app is still written in JavaScript. So to get started with Firebase, we'll basically need to follow this guide. And the first step is to create a Firebase project, something that we can do from the Firebase console. There's a link to the console up here. If it's the first time you use Firebase, you'll need to sign in with a Google account. And then you should get to this welcome page. The Firebase console is the dashboard where we can manage our Firebase projects. Let's start by creating a project. In this wizard, we need to enter our project name. Let's write Daily Moments, since that's what we used for our Ionic app. And then we can customize the project ID if we want to. That's a unique identifier for our project. But it doesn't really matter because it won't be visible to our users anyway. So let's continue. Next, it's asking us if we want to enable Google Analytics for this project. This is very useful to get user statistics, but since we're building a sample application, I'm going to disable it. And we can proceed with creating the project. This can take a minute or two, so I'll speed up this video. Okay, your new project is ready. So let's click Continue. And we get redirected to our project dashboard. Now, if we start from the top-level console page again, here we can see our new project in the grid. And if we open it, we go back to the project dashboard. Now, on the left sidebar, we can see all the features we can use, like authentication, database, and so on. But first, we need to add Firebase to our app, as it says here. And we want to follow the instructions for a web app. First, we need to register our app with this Firebase project. As the app nickname, we can enter Ionic App. This name is only visible in the Firebase console anyway. And then we can register the app. Okay, now it's giving us some more instructions. There's a code snippet here with some configuration that we can copy into our project. But let's not do that from here. Let's continue to the console instead, because I want to show you where to find that configuration from here. If we click on the gear icon, we can open the project settings. And if we scroll down a little, here it shows your apps. Note that we can have more than one app associated with the Firebase project, because you could have, for example, a web app and a native Android app that both use the same backend database, but we only have one Ionic app. And here we can find the code snippet with the configuration. In fact, if we select config rather than CDN, we get some code that's more appropriate for a modern JavaScript app. So let's copy this block of code with the Firebase configuration and see how we can use it in our project. Let's create a new file inside the source folder called firebase.ts, since it will contain our Firebase code, and then paste that snippet with this Firebase config object. As you can see, it contains a bunch of properties with IDs and keys that we'll need to connect to Firebase from inside our app. Normally, you should keep this information private, of course. Otherwise, somebody else could connect to your Firebase project using your own keys and potentially cost you money or get your account suspended. I'm showing you my config here, but I'm going to delete this Firebase project when I'm finished, so these settings won't work anymore. Now, to actually use Firebase, in addition to the configuration, we'll need to install an npm package that will be added to our dependencies. And the package we want to install is called simply Firebase. Let's wait for npm to do its thing. That's finished, so let's close this terminal. You can see that Firebase is now one of the dependencies. So we can use it in our firebase.ts file by importing star as Firebase, where star means import the whole module, from Firebase/app. There are several submodules that come with Firebase, and we want the app module here, because with that module we can call Firebase initialize app. And when initializing the app, we need to pass our Firebase config. So that's what that config is for. Now, this will return an app object that, if we inspect it, is an instance of Firebase app. As we'll see, this app object will give us access to all the Firebase services like authentication, database, and so on. Let's save this file and stop here for this video. We created a Firebase project that we can manage from our Firebase console, and we installed and configured the Firebase JavaScript library inside our Ionic app. In the next video, we'll start using the authentication service. We started integrating our app with Firebase, and we initialized the Firebase app here in our code, but we're not actually using any Firebase service yet. In this video, we'll look at the authentication service. This allows us to authenticate and manage users, like it says on this page. Before we can start using this service, we need to configure the sign-in methods. On this tab, you can see that there are a number of sign-in providers, so we could let our users sign in with their Google or Facebook accounts, for example. But we'll start with the first option, that is email and password. Let's enable this provider and just click Save. It takes a couple of seconds, but it's enabled now. So let's go back to the Users tab. This table now says that we have no users for this project yet, but we can manually add a user by clicking this button and entering an email address. I'll put test1@example.org, so it's clear that this is just a test user. And then we need a password that I'll set to test1234, just so it's easy to remember. Obviously, it's not very secure at all. Don't do this for a production app. But we can now click Add User, and we can see our new user listed in the table. Note that each user is assigned a UID or user ID that uniquely identifies this user. As we'll see, we'll frequently need to use that UID. Now, let's go back to our code and see how we can use the Firebase authentication functionality. For a start, we need to import the Firebase auth module. Note how we're not importing any specific class or variable, we just import the whole module, and this will dynamically enable the auth functionality. Now we can use our app instance that was created by initializeApp to access the auth service that, as you can see, is just one of many services available. And this is a method, so we need to invoke it, and it returns an auth instance that we can export as the auth variable from this module. This way, from our other files, we can simply import auth and we get a fully initialized instance. Note that if we use app.auth, we first need to import the Firebase auth module at the top. Otherwise, we'll get an error at runtime. Now, let's go and start our application because it's not running at the moment. And while it's starting the dev server, I'll just set up these windows so we have the editor and the browser side by side. Here's our app. Let's open the DevTools as well. And we're ready. So since we manually created a user in the Firebase console, we could try signing in as that user. We already have a login page in our application. That's in fact the page we're currently seeing in the browser. So here we want to start by importing the auth service that we just exported from our own Firebase module. And let's collapse the imports. Now, at the moment, when the user clicks the login button, we call the onLogin function that's passed in as a prop to this component. But we'll now want to take some action right here. Let's add a handleLogin function. And this is what we want to trigger when the user clicks the button. And here we want to use the Firebase auth service that should provide a sign-in method. In fact, it has quite a few of them because you can sign in different ways. The one we want is sign in with email and password. Now, if we inspect this method, it expects two parameters that are email and password. So just as a first step, let's pass test1@example.org as the email and test1234 as the password. Let's check the method signature again. What it returns is a promise that resolves to a user credential object. Since it returns a promise, let's make this function async, so we can then await the result that will be some credential object. Now, let's just log this object to the console so we can see what it contains. Let's save and go and test it. We want to see the console messages. Now, let's try clicking the login button, and we can see that it logged something in the DevTools. Let me expand this window so we can look at this credential object. It has a user property with lots of fields with funny names, but we can see the email address here. And if we scroll down to see the rest, there's also the UID or user ID. We'll use this user object later on, But for now, just the fact that we do get that object means that our sign-in was successful. So that's the first step. We managed to log in with Firebase by calling the sign-in with email and password method provided by the auth service. Obviously, we don't want to hard-code the email and password forever. In fact, in the next video, we'll create a simple form to let the user enter their own email and password. In the previous video, we wrote some code to log in a user using Firebase authentication. So if we click this login button, this will call the Firebase API and log something to the console. However, we still see the login page. That's because we're not calling this onLogin function that's passed in as a prop. If we do call it right after we receive the response from Firebase, this should notify the app component that in response will update the logged in state to be true. So let's save this change to the login page and quickly check that it works. Let's click Login and we can now see the home page as expected. Note that if we reload the page, we're sent back to the login screen. That's because at the moment we only keep the logged in state in memory. We'll see later on how to remember the authentication state. Right now, let's begin by letting the user enter their own email and password. Because at the moment we hard-coded test1@example.org when calling sign-in with email and password. So we'll need to add some form fields to our user interface. Let's wrap them into an ion list just so that they are arranged into rows. And each row is represented by an ion item element. Then we want an ion label. And I'm going to set the position to stacked. We talked about label positioning earlier in the course, if you remember. And the first field will be the email. Next, we want an ion input that is basically a text field. But actually, we could set the type to email in this case. This helps mobile browsers to show the right kind of soft keyboard to make it easier for the user to enter an email address. Okay, this is our first field. Now let's add another one that's pretty similar, but this one is for the password. And the type will also be password, which means that whatever the user enters will be hidden for security reasons. Okay, let's see what this looks like. We have a simple form where the user can enter email and password. That's all we need, really. Now, to actually use the values entered by the user, we'll want to add some state variables. Let's start with the email and call the useState hook that we need to import. As the initial value, we can simply pass an empty string. Next, we want to do the same for the password. Again, keep it as a state variable. And now we can bind these variables to the form elements by setting the input value to the email variable. And then, whenever the user types something, do you remember which event we need to use with ion input components? It's called onIonChange, as we saw earlier in the course. So here we respond to the event by setting the email to the event.detail.value. This makes sure that our state variable is in sync with the value entered by the user. Next, we need to do exactly the same thing for the password field as well. I'm going to copy the change handler from the other element, but we'll call setPassword in this case. Okay, that should be it. Next, we'll want to use those values entered by the user in this handle logging function. To test it out quickly, I'm going to comment out the existing functionality and just log to the console a message showing the email and password values. So we can check that it's using the right values before we send them to Firebase. Let's enter the email test1@example.org and the password is test1234. Click Login and we see the expected values in the DevTools console. Alright, now that we're sure that the form is working fine, let's remove this log statement and uncomment the previous code. But instead of passing these hard-coded credentials, we want to pass the real email and password values entered by the user. Okay, now we can save these changes and do another test. Let's enter the usual email, test1@example.org, and the usual password, that is test1234. Now we can click Login, and after a small delay, we are redirected to the home page. Okay, so our login page is fully working now, at least for the happy path. We added email and password fields, making it a simple form, and then we're using the values entered by the user when calling the sign in with email and password method. We added a login form where the user can enter their email and password, and those values will be used when signing in with Firebase authentication. But what happens if a user enters the wrong password, for example? Let's type just X and click Login. You can see that there's an error printed in the DevTools console. There is a POST request sent to googleapis.com that returned a 400 as the status code. And by the way, this shows how the Firebase SDK is simply making HTTP requests to some Google servers. Then further down, we have an uncaught exception with a message saying that the password is invalid. So how can we handle these errors in our code? Since we're using async await to deal with the promise returned by sign in with email and password, we can use a try statement and wrap all the existing code in a block. So this is what happens if everything goes well. But then we can catch any errors, and for now, let's just log the error to the console. Okay, let's save these changes. Now let's try logging in again as our test1 user and with a wrong password. We can see pretty much the same error in the console, but this time we are catching this error object in our code, so we could use it, for example, to display a message to the user. Ideally, we should look at this code field returned by the Firebase API and display a different message based on that code. In this case, the problem is wrong password, but there are other possible errors like invalid email or simply a network error. Let's start by looking at how we can display an error message. We could simply use an Ion text element, so we can apply the Ionic styles like set the color to danger. And to keep things simple, let's always display invalid credentials as the error message. Like I said, it would be better to show a different message depending on the specific error, but I don't want to complicate this example too much. Anyway, we can now see the error message in red displayed before the login button. But obviously, we don't want to show that message all the time. We only want to show it when there's an error. So we'll need another state variable to keep track of whether there's an error or not. And we initialize it to false, meaning there is no error at the beginning. Now we can use this error variable to conditionally display the message. So only if error is true, then we render the Ion text element. And if we save, the message should not be there initially. Now we'll need to call setError at some point. We need to call it if there's an error, of course, and set its value to true. Okay, let's see how it works now. Let's type the usual email and X as the password, and we see the invalid credentials message on the page. Now, if we type the right password, that is test1234, of course, we should be able to log in successfully. Okay, now there are still some improvements we can do. We set the error to true here, but we never reset it to false. Ideally, we should reset it as soon as the user clicks login, so before we make the Firebase call. And thinking about it, there is some delay between when the user clicks login and when we get the Firebase response. So it would be nice to give the user some indication that there is an operation in progress. Otherwise, if nothing is happening on the screen, the user may try clicking the button again. There is an Ionic component designed specifically for this. It's called Ion Loading. This will display a spinner if we set isOpen to true. If we save, we can see the spinner and everything else on the page is disabled. While if we set isOpen to false, then it's like if the component doesn't exist. Okay, so we'll want to conditionally display that loading indicator, which means that we'll need a state variable, like we do for the error condition. We could add another variable called loading in exactly the same way. But thinking about it, loading and error really go hand in hand. So let's do something else. Let's use a single variable for both loading and error. I'll call it status for want of a better name. So this variable will now be an object with a loading property and an error one. Both of them will be initially false. This way, before making a sign-in attempt, we can call setStatus and pass an object with loading set to true and error set to false, because we want to show the loading indicator but not the error message. While when we catch an error, we want to set loading to false and error to true. And finally, if we log in successfully, so at this point in the code, then we want to leave loading as false and set error to false as well. So this should cover all cases. Now we need to use that status. Instead of error, we can write status.error, and then we can set the Ion loading to be open if status.loading is true. Okay, I think that's it. Let's save. And now let's do some tests. Let's type the usual email. And let's start with a wrong password. We've seen the loading indicator for a fraction of a second, and now we see the invalid credentials message. Let's try with the correct password now. We see the spinner again, but this time we log in successfully. Good. It's all working exactly like we wanted. So this pattern of having a loading and an error flag whenever you make a request to the server is very common. It doesn't matter if you use Firebase or some other API, there's always some delay when calling a remote server. So we need to tell the user that they need to wait a little bit by showing a loading indicator, like this Ion loading component provided by Ionic. And also, there's always the possibility of the server request failing, in which case we need to display some sort of error message, like with this Ion text. And that's why we need to keep two flags for the loading and error states, even though we can combine them into a single object, since we always update both of them at the same time. At this point, we have our login form, so we can enter our email, the password, tap login, and we're logged in. However, if we reload the page, we're not logged in anymore. It's quite annoying for the user to have to log in every time they open our app. In fact, Firebase already supports remembering our authentication state out of the box. If we look at the Application tab in the Chrome Developer Tools, we can find indexed.db that's essentially a database embedded in the browser. If we expand this, we can see that Firebase has created its own database here. And if we look at its contents, it has saved something with a key that starts with Firebase auth user. Now, we don't need to worry about the details of this data, but this is what Firebase uses to remember our authentication. Let's see how we can take advantage of this feature in our code. Let's open our app component, that is where we keep the logged in state. And for a start, we want to import the auth service from our local Firebase module. At this point, we can tell Firebase to notify us whenever the authentication state changes by using the onAuthStateChanged method. And for now, I'm calling this method here outside of the component code, so it will only be executed once when the app is first loaded. Anyway, if we look at the signature of this method, the first argument it accepts is called next or observer. That's because we can pass either an observer or a next function. The simplest option is to pass a next function that takes a Firebase user object and returns any, which means we can return whatever we like. So let's see how this works in practice. We pass a function that receives a user parameter, and in the function body, let's start by logging something to the console. Let's print out the user object so we can see what it looks like. Now let's save and see what we get. You can see that onAuthStateChanged fired and it printed a user object. Let's not worry about what that user object actually contains. But if we do get a user object, that means we are already authenticated according to Firebase. Now, let's see what happens if we delete this database that's used by Firebase to persist our authentication state. Let's show the console again and go and start from the root of our app again. You can see that this time onAuthStateChanged still fires, but we get null as the user. So if we get a user object, that means we are authenticated. If we get null, that means we are not authenticated. Now that we know this, we can use it to set our logged in flag appropriately. We'll need to move the onAuthStateChanged call inside our component code to be able to access the logged in state variable. But we need to make sure we only call onAuthStateChanged once, not every time this component is rendered. So we need to use the useEffect React hook. Here we pass a function where we'll call onAuthStateChanged, but we also want to pass an empty list as the second argument, meaning that this effect should only run once. The second argument to useEffect is a list of values that this effect depends on. So if one of those values changes, then React will run this effect again. An empty list means the effect doesn't depend on anything, so never run it again. Now, let's move the onAuthStateChanged code inside our useEffect callback. And instead of logging to the console, here we want to set the logged in flag. Now, we've seen that the user we receive here will be an object if we are logged in, or null if we are not logged in. So we can simply convert the user to a Boolean value like this. This way, when user is null, we set logged in to false, and when it's an object, we set logged in to true. All right, let's save these changes and do some tests. At the beginning, we can see that logged in is false. Now let's try logging in with the usual credentials. And we get redirected to the home page, which means we're logged in. But there's also a warning in the console. Let's see what's going on here. First of all, we can see that the logged in state switched from false to true after we submitted the login form. So that's what we expected. But right below, there's this warning saying, can't perform a React state update on an unmounted component. And the component it's talking about is the login page. We'll come back to this issue in a minute. First, let's do another test and see what happens if we reload our application. You can see that this time we are automatically logged in because it's remembering our authentication state. Interestingly, the logged in flag is false the first time, and then it becomes true in a separate render update. It's initially false because that's the default value we pass to use state, and there will be a small delay before we get the Firebase on-auth state changed notification. Okay, now let's go back to that issue we saw earlier, where React said it could not update the login page component state. I'm going to delete the Firebase DB so we can start again from a state where we are not authenticated. Okay, now let's go and look at our login page code. So the problem is with this line. Here we are updating the state, but at this point this component has already been unmounted. That's because as soon as the Firebase sign-in succeeds, the on-auth state changed event fires, so our app component will unmount the login page and display the home page instead. So what we should do is simply remove this line and also the onLogin callback. This was used to notify the app component that the login was successful, but now the app component already knows that by listening to the on-auth state changed. So we don't need this anymore. And we can also remove it from our props, which means we don't need the props interface at all, and therefore remove this type argument as well. All right, let's save and let's go and update the app component. Here we simply don't need to pass this onLogin prop anymore. And that should be it. Let's save. And let's test if it works now. Let's go and enter the usual email and password. Click Login. And we're logged in successfully and there's no warning in the console this time. Good. Let's test if it still remembers our authentication state. It certainly does. Okay. So we're now using the Firebase on-auth state changed listener to update the logged in state in our app, which also means it automatically remembers our authentication state even if we reload the app. We are now listening to the Firebase on-auth state changed event, which means that once we are logged into our application, our app will remember our authentication state across app reloads. However, there's still a minor issue. Our app assumes that initially we are not logged in, and only after a small delay it detects that we are in fact already logged in. If you noticed, this results in the login page being displayed for a short moment before we're redirected to the home page. This is just a small annoyance, but let's see if we can fix it. The key point here is when we call useState, we initialize logged in to false. But in reality, at this stage, we don't actually know if the user is logged in or not. We'll only know once we get the first auth state changed notification. So what we could do is keep an object in the state where we still set logged in to false, but we add another property that is loading and is initially true. This is similar to what we did in our login page. So let's rename this variable, since it's not just the logged in flag anymore. Let's call it auth state maybe. And now, instead of calling set logged in, we call set auth state, passing an object with loading false, and logged in will be the same as before. It depends on the user value we receive in this callback. Now we'll need to use auth state everywhere. Let's still log it to the console so we can see when it changes. And as the auth context value, it will still be an object with a logged in property, but we need to take its value from the auth state. Okay, I think that's all we need to change. Let's save and see if it works. We still see the login page briefly. We haven't changed that yet. But in the console, we can see that initially loading is true, and then the app is re-rendered with loading false and logged in true. Okay, so we have this state object that includes a loading flag. Now we can use it to check if auth state is loading. Then we can temporarily display an Ion loading component. And I'm going to set isOpen because we always want to show it in this case. So while we're loading the authentication state, we'll simply display the loading indicator instead of the Ion app. Let's see how this works. It does just what we expected it to. We see the spinner briefly, then we go straight to the home page. Now let's test what happens if we are not authenticated. So I'll delete the Firebase local database, and now we can try loading the app from the root path. We could see the loading indicator again, but then we're sent directly to the login page. And as a final test, let's try logging in once more. The logged in flag correctly transitions from false to true. And of course, if we reopen the app later, we're still logged in. All right, everything works as expected. So this is a simple approach to handle this case where initially we don't know if the user is already authenticated or not. We just display a loading indicator temporarily. If you're building your app for Android and iOS with Capacitor, you could take advantage of the native splash screen instead. So only hide the splash screen once the authentication state is available. But that doesn't work if you want to deploy your app as a regular website. So you may still want to show an Ion loading component for when your app is running in a regular web browser. At this point in our application, users can log in, and if they come back to the app, will remember their authentication state. But to log out, so far we've been manually deleting this database using the dev tools. That's obviously not a user-friendly solution. So let's see how to add a logout button to our app. We could add this logout functionality to the settings page, since it's still pretty much empty at the moment. It's not uncommon for mobile apps to have the sign out under settings anyway. So instead of this dummy content, we want an Ion button element, and we can set expand to block so it takes up the whole space horizontally. And the label will simply say logout. That's what our logout button looks like. Maybe the primary color is not the best choice in this case. Let's try with color set to medium. That should be a medium gray. That's better. We don't want this button to be too prominent because it's not like we want to encourage our users to log out. Anyway, let's think about the actual functionality now. We'll want to add an on-click handler here. But before we do that, let's go and import the auth service from our Firebase module. Because we'll need the Firebase auth service if we want to log out, of course. So now we can handle the on-click event. And the auth service should have a method called signout. Here it is. If we check the signature, signout simply returns void, wrapped in a promise because it's asynchronous like all API calls. So we could leave our code like this, really. We just call sign out and let it do its thing. Let's save and try it out. If we go and click the button, we are pretty much immediately logged out. That's because the Firebase sign out method will cause an auth state event to be fired, so our app component sets logged in to false and is therefore re-rendered showing the login page. Let's do one more test. Let's sign in again with our usual credentials. Now we're logged in, and if we go to settings, we can log out again. I didn't really need to test that twice. Of course, it works in the same way. But I just want to make sure you understand that it works because here we are listening to all auth state changed events. So we get notified by Firebase as soon as we sign out from our settings page. And that's how you can implement the logout functionality with Firebase. Pretty straightforward. In the previous step, we added the logout functionality, so our users can now sign out from the settings page. And of course, they can log in from this page. But what if they don't have an account yet? So far, we always used this test user that we manually created using the Firebase console. But it's about time we add the ability to register a new user from within our app. We'll want to add another route that anyone can access, similar to the login one, but for a registration page. So let's go and create a new page component. Now, the registration page will be pretty similar to the login page. So let's just duplicate that and rename it to register page. In this file, we need to change the component name here and at the bottom where it's exported. And let's change the title as well. There are a few other things we'll need to change, but first let's go and add a route for this page so we can load the page in the browser. Let's set the path to /register, and instead of the login page, we'll render the register page. Okay, let's apply these changes, and if we manually change the location to /register, we can see our new page that says register in the title. Now that we can see it in the browser, let's go and implement the user registration functionality. Let's have a look at this code. To do the login, we called auth sign in with email and password. But obviously, to register a user, we'll need to call a different method. The auth service should have something called create user. In fact, create user with email and password is the full name. And this method expects email and password as arguments and returns a promise of a user credential object. So it turns out that we can use it exactly like we used the sign in method, which is convenient. We're already passing email and password and awaiting a credential object that we just print to the console anyway. Now let's change this function name to be more descriptive of what it does in this case. And we'll also need to update the place where it gets called. On button click, we call handle register. Now let me show the browser again so we can look at the results. Obviously, we'll want to change this button text. Let's say create account here for a change. It already says register in the title. And let's see what this looks like. Okay, the form looks fine. Now let's try registering a user then. Let's enter test2 at example.org. And I'll still use test1234 here. Let's click create account. And we can see in the console that we received a credential object. So the Firebase operation succeeded, but also the logged in state changed to true. And in fact, we got redirected to the home page. So not only we registered as a new user, but we are automatically logged in as well. Now let's go and check the Firebase console. If we refresh this user table, we can see that our second user is now in the list. So that's all good, but we're not quite finished yet. Let's go and log out so we can do some other tests. One thing to notice is that when you open the app, you're presented with a login page, but there's no way to go to the registration page unless you manually enter the right URL in the browser location. Also, what happens if you try registering with an email address that's already registered? We already have a test1 user, so we see a red message on the page saying invalid credentials. That doesn't really make sense in this case. If we look at the console, the real problem is that the email we entered is already in use. So let's go and change this error message that was just copied over from the login page. I'm going to write a generic registration failed message here, just to keep things simple. Let's quickly test this again. Let's try registering test1@example.org for a third time, and at least it now says registration failed. Like I mentioned for the login page, ideally we should look at the error code returned by Firebase and display a different message accordingly. But I'll leave that as an exercise for you if you like. Now let's tackle the other issue we identified. When a new user opens our app for the first time, they just see a login page. But if they don't have an account, how are they supposed to log in? We'll just need to put a link to the registration page in this login page. We could have another button in addition to login, but with some different text. Let me just split this line. So here we could say don't have an account, and instead of the onClick handler, we simply want to link to the register page using the router link attribute. Okay, let's see what this looks like. If we click don't have an account, we go to the register page. So that works, but having these two blue buttons doesn't really look great. Let's change the style a little bit. We can set fill to clear to remove the button background. If we save, we can see what that means. This is a lot nicer. It also makes it clear that login is the primary action. Of course, even if the style is different, it still works like a button. In fact, we may want to add a similar link to this registration page as well, in case the user got here by mistake and they want to go back to the login. So let's copy this button and add it to the register page. This time we could say already have an account and link to the login page. Okay, this button should take us to the login page. We can navigate from the login to the register page and vice versa. So when a user first opens our app, they'll see the login page, but they can choose to register instead. We could decide to show the registration page first if we wanted to. It depends on whether you want to make life easier for new users or for registered users. If we wanted to change it, we would need to do that in the App Tabs component, because here is where we redirect to the login page. You could change this to /register if you prefer, but I'm going to leave it as it is. Anyway, we've seen how to create a new user with the Firebase authentication service, and our app now has all the main user management features. You can register, you can log in, and you can log out. In this video, we'll see how to keep some additional information about the user in our authentication state. When we log in as our test1 user, and always with the same password, we get something back from the Firebase API. There's a credential object that contains a user, and this user object has a few properties we could use, but at a minimum we'll need this UID, or unique identifier. Now, this user object is returned by the sign-in operation, but it's really the same type of object we receive from onAuth state changed as well. Now, we wrote our own auth module, where at the moment we create an auth context and export a useAuth hook. That hook is used, for example, in the login page to retrieve the current logged in state. So what we'd like to do is be able to get the user ID in addition to the logged in flag. Because in the next section we'll need the user ID to store and retrieve data for a specific user. Now, before we add that extra field, I'd like to do some refactoring because at the moment we have some authentication logic here in the app component and some other functionality in auth.ts, but it's all strictly related. So I'm going to create another custom hook here. Let's call it useAuthInit because it's to initialize the authentication state. And here I'm going to paste the same code we had in the app component. Now we'll need to import a few things like useEffect and useState. Then we'll need the Firebase Auth service, the one exported from our Firebase module. To avoid confusion, let's alias this as Firebase Auth, because auth is also the name of this file. So we use Firebase Auth to listen to auth state changed events. Okay, now from this hook we want to return the auth state, because that's all we really need in our app component. Now, if we save and go to app.tsx, here we can import our new hook, that is useAuthInit, and we can use this hook instead of calling useState. Instead of an array, this just returns the auth state, and at this point we don't need the useEffect anymore, because our useAuthInit hook already takes care of all that. We should now remove some unused imports. Okay, this simplifies our app component code, and in theory everything should work exactly as before. There are no errors in the console, so we didn't break anything. The advantage is that we now have all the authentication logic inside the same file. Now, we could add some explicit types here. If we look at useAuth, TypeScript can infer that we return an object that contains a logged-in property that's of type Boolean, because that's the kind of object we pass to React create context. So auth context will be parameterized with that object type, and therefore that's also the return type for useAuth. TypeScript is pretty good at inferring types, but sometimes it's better to declare them explicitly. So we could define an interface, let's call it auth, since this will be the type returned by useAuth. And this represents an object that has a logged-in property of type Boolean. Once we have this interface, we can pass it as the type argument for the React create context call. So this means that this React context contains a value of type auth, and therefore useAuth also returns an auth object. But we can write it explicitly here. So if anybody looks at this code, they'll immediately see that useAuth returns an auth object. Types are useful not just for the compiler, but also as documentation. Now, we could do the same for the type returned by useAuthInit. Let's define another interface. In fact, it will be very similar to the auth one, but let's call this one authInit. And in addition to logged in, it has a loading property that's also a Boolean. Now let's use this interface. In this case, we want to parameterize the useState call. So authInit describes the shape of the object kept in the state. And that's also what useAuthInit returns. But again, we can write it explicitly as code documentation. Okay? Now, for consistency, we may want to rename authState to authInit, so it's the same as the type. Okay, this should do. Now, there's something else we should do here. When we call onAuth state changed, this returns an unsubscribe type. Let's go to this method definition, so maybe we can see what this unsubscribe is. You can see that it's simply a function that takes no parameters and returns void. So this is a function that we can call if we want to stop receiving auth state changed notifications. Ideally, we should return this function from our useEffect callback. This way, if React unmounts the component that started listening to auth state changes, it will also stop the subscription. In our case, we're using this hook in the app component that will never be unmounted. That's why I didn't worry about unsubscribing before. But since this is now a separate hook that could potentially be used by other components, it's good to handle this scenario. Let's save and quickly check that we didn't break anything. No errors in the console, so that's good. At this point, we have these two hooks that return two slightly different interfaces. The only difference between them is that auth init has an additional loading flag. We could revise this slightly by saying that auth init contains the auth value plus the loading flag. But the auth value will only be available when loading is false. So let's make it optional by adding a question mark. Now there's an error down here because auth init no longer has a logged in property. So we should simply remove it. As the initial value for useState, we can only set loading to true. There is no auth object available yet. Now we need to update the object passed to setAuthInit. At this point, we do have an auth object, and it will contain the logged in property with the same value as before. So once again, useAuthInit now returns an object with a loading flag and possibly an auth object if it's available. Let's check how we're doing. We do have an error now, and it's in app.tsx. Of course, we'll need to update our app component since we changed the shape of the object returned by useAuthInit. As the value passed to auth context provider, we could now simply pass the auth object contained inside auth state. Let's see if this fixes the error. Yeah, our app is working again. Now, we can actually simplify this code a little bit. We could unpack the object returned by useAuthInit, extracting its loading and auth properties. This way, here we can simply check if loading is true. And as the auth context value, now this is just auth. There's still a problem with this logging statement. What I'll do is move it down and get it to print only the auth object once it's available. No need to log it while it's still loading. We tested that case enough times. This way, in the DevTools, we can see that the auth object contains logged in true. Okay, so our app component is even simpler now. Next, it's time to do what was our main goal actually, that is add the user ID to the authentication state. And this is a lot easier now that we cleaned up our code. We can simply add the user ID as a property of the auth object. It's an optional property because the user ID will only be available if logged in is true, and it will be a string. Now we want to actually set that user ID property if it's available. I'm going to rewrite this line because I think that's easier. Also, let's change this parameter to be Firebase user. So it's clearer that it's not our own user object, it's something that's part of the Firebase API. Now, here we can prepare the auth object, and this depends on the Firebase user value. If Firebase user is not null, then auth will be an object with logged in set to true. And we can also set the user ID. That will be the Firebase UID value. while if Firebase user is null, then the auth object will have logged in set to false. Now that we have the auth object, we can call setAuthInit, but here we need to pass an authInit object. That's the one with the additional loading property that will always be false once we receive an auth state change. And then it will contain the auth object defined above. So I hope it's clear the distinction between the auth and authInit types. Auth is what most components will use. It says if the user is logged in, and if so, what's their user ID. While authInit is only used by the app component when initializing the Firebase authentication, so it has an additional loading property. Alright, time to see if it actually works. We do see the user ID printed to the console inside the auth object. Okay. So any component could now access that user ID. For example, in the login page, just like we get the logged in flag, we could extract the user ID from the object returned by useAuth. Now, we don't actually need it in the login page, but as we'll see, we will need this user ID in some other components when we start storing data in Firestore. That's the database provided by Firebase. Our app can now handle user registration, login, and logout using Firebase authentication. In this section, we'll see how to store data in Firebase. In this home page, we display a list of entries. If you remember, this entry data comes from a local file called data.ts. This data is only temporary. We put some dummy values in this file just so that we could display something in the user interface. Now it's time to start using a real database, and we'll use the one provided by Firebase. If we open our project again in the Firebase console, in the left sidebar, after authentication, that's the first service we used, there's also a database service. This database is called Cloud Firestore. Unlike other databases such as MySQL or MongoDB, you cannot run Firestore on your machine. It's a fully managed service that only runs in Firebase. Before we can use it, we'll have to create a database for our Firebase project. This starts a wizard. In this first step, we can choose which security rules to apply, meaning who should be allowed to access our database. Let's accept the default option, that is production mode. We'll look at security rules in more detail later on. The next step is asking us to choose a location for our database. Like all Firebase services, Firestore is hosted on Google Cloud. In this list, we can see all the available locations. If most of your users live in a specific part of the world, you may want to choose a location that's closer to where your users are, so there's less latency when fetching data. But for this example, I'll stick with the default location, that is US Central. So let's go ahead and click Done. This will create the database, and it will take a few seconds. Once the database is ready, we get redirected to this page where we can manage the data. We'll see how to use this dashboard later. First, let's set up Firestore in our application code. We have our firebase.ts file where we initialize the Firebase app and the auth service. To enable Firestore, we first need to import the Firebase/Firestore module. Just like with auth, we simply import the whole module here. And this allows us to use the app.firestore method that returns the Firestore service, and we can export it so we can use it in the rest of our app. Note how we need to enable each Firebase service by importing the right module first. That's why I prefer not to export the whole Firebase app instance, but only export individual services like Auth and Firestore, making sure they are enabled first. Okay, so we created a Firestore database. Now, how do we use it? Obviously, Firebase provides some documentation for that. If we go and look at the guides, here we can find Cloud Firestore, and you can read these pages if you want to learn about all the various features available with Firestore. But of course, we'll see some examples in the next few videos as well. Now that we have created a Cloud Firestore database, we'll want to store some data in it. And to do that, we'll first need to understand the Firestore data model, which means how to structure our data. In Firestore, we can store documents, where each document can have a number of fields, and documents are grouped into collections. For those of you familiar with relational databases like MySQL or Postgres, you can think of collections as being like tables, and documents will be like rows in a relational model. But we'll see an example soon anyway. We can manage our data using this admin interface. But first, let's see how we should structure our data. Let's keep using this example where we have a list of entries. I'm going to open another editor panel where we'll see how this data will look like with Cloud Firestore. You can think of a Firestore database as like a giant JSON object. And I'm setting JSON in the editor just so we get syntax highlighting. So, like I said, imagine we have a JSON object and we want to store all our data in here. The first level of properties in this object will be what Firestore calls collections. For example, we can have a collection called entries. Now, unlike our data on the left, this will not be an array, but another object. And the reason is that we want each entry to be indexed by its ID. One is the ID of the first entry, and this maps to an object that contains the data for that entry. So here we'll have the title with the value of first entry and a description, again with the same value as our original data on the left panel. So ID and data form what Firestore calls a document, and we can have multiple documents in the entries collection. Of course, each document must have a different ID, so this will be 2, and it points to the data for the second entry. Likewise, the last document has ID 3, and its value is the data for the third entry. So this is how we could represent the same entries we had before in a format that's conceptually the same as the Firestore data model. Of course, Firestore doesn't simply keep a giant JSON object in memory. It's a very optimized and distributed system, but this should give you an idea. In the same database, we can have more than one collection. So in addition to entries, we could have, some countries, for example. And each country will be identified, for example, by the 2-letter country code and have some data with maybe the country name, like Australia. Then we can have other documents in this collection representing other countries, like say France and so on. But in our application, we actually just need to store some entries, so we'll use a single collection. Also, it's worth mentioning that rather than us assigning specific IDs to each document, we can let Firestore auto-generate the IDs, in which case they will be like random sequences of letters and numbers. So you might see something like this, where each ID is guaranteed to be unique. Okay, so this is a conceptual representation of what our data will look like when stored in a Firestore database. Now let's go and actually insert some data using the Firebase console. The first thing to do is to create a new collection, and we want to call it entries. Next, we can add a document inside this collection. As mentioned, each document must have an ID, but we can let Firestore generate a unique ID for us. Then we can add some fields, and here we want a title with a value that says first entry. Note how each field also has a type, just like each JSON value has a type. In this case, string is absolutely fine. Now let's add another field for the description, and as the value, let's write the usual "this is the first entry." Let's save this document, and after a small delay, we can see the data we just inserted. Note how the user interface reflects the data model we described earlier. There's a collection called entries on the left that contains a document with that random ID in the middle, and the data for the document is on the right. Now let's add another document, again with an auto ID, a title with a value of second entry, and then another field with a description that will be the usual boilerplate text. Let's click Save again, and we can see a second ID here that we can select to show the data. I'm going to add a third document as well, but since it's always the same process, I'll jump straight to the filled-in form, so you don't have to watch me type everything. And now we have 3 documents with the same test data we had in our application, but they are saved in Firestore. So in the next video, we'll see how to read that data from our app. In the previous video, we manually inserted some data into our Cloud Firestore database. So we're now ready to see how to fetch that data from our application code. This untitled file is just what I used to explain the Firestore data model. We don't need to save it, but I'll keep it open for the moment. In our firebase.ts file, we are already exporting the Firestore service at the end. So let's go and start fetching some data. Let's begin with the home page, since that's where we display the list of entries. Here we want to edit our imports and add the Firestore service that we export from our Firebase module. Okay, now we can use Firestore in this file. And we want to fetch the list of entries from the database. This means we'll need to store our entries in a state variable that is called useState. We can pass an empty array as the default value, meaning that our list of entries will initially be empty until we get the data from Firestore. Since we now have entries in the component state, that also means we don't need to import the dummy entries data anymore. So let's get rid of that. Let's save the changes so far so we can check if we made any mistakes. It's all good. The home page looks empty just because we're displaying an empty array. So it's time to actually fetch the data. We can use the useEffect hook to wrap our data fetching logic. And we want to pass an empty array as the second argument to tell React that this effect should only run once when this component is mounted. Now, in this function body, we want to fetch the data and update the entries variable accordingly. So we'll use the Firestore service. And Firestore has a method called collection that we can call passing the ID of the collection we want. And in this case, we want the entries. That ID needs to match the one we used when we created the collection in the Firebase console. That's probably obvious, but we can call our collections whatever we like as long as we use the same ID when fetching the data. Now, this method returns a collection reference. It's called a reference because it doesn't contain the actual data. Let's assign it to a variable. Let's call it entriesRef, short for reference. And now we can use this entriesRef to get the actual data by calling this method. This returns a promise because fetching the data is an asynchronous operation. and it's a promise that resolves to something called a query snapshot. So let's invoke this method, and since it returns a promise, we can call then. I'm not using async await here because it's tricky to do with useEffect. So the promise will give us a query snapshot, and let's just log this snapshot object to the console so we can see what it contains. Alright, let's save and see what we get. That didn't work very well. There's an exception in the console. It's a Firebase error that says missing or insufficient permissions. So this means we're not allowed to fetch our data from Firestore. Let's go and open the Firebase console again. So far we only looked at the data here, but if we select the Rules tab instead, here we can see the security rules that specify who can access what data. At the moment, these rules say that for all documents, read and write operations are allowed if false, which basically means they'll never allowed. Nobody can read or write any documents. These are the default settings for security reasons. To learn more about the syntax for defining these rules, you can look at the docs that are linked from this page. And we'll come back to these rules later in this section anyway. But for now, let's do a quick and dirty fix and simply change false to true, which means that anybody can read or write any documents in this database. If we click Publish, these rules will become effective. Note how Firebase also keeps track of all the changes to the security rules, so you have a complete audit log of what's changed and when. Now, allowing anybody to access our database is obviously very insecure, and you should never do that in a production application. We'll only do that while we're learning how Firestore works. We'll come back and configure some more secure rules later on. Now, our app wasn't working because it could not fetch the data. Since we changed the rules, we should be able to just reload the page, and this time there are no errors. In fact, we can see our snapshot object returned by Firestore. This has a docs property that is an array with 3 elements, so we can guess that these are our 3 entries. It's not easy to see because they have all these strange properties, but there is an ID here, that is the document ID. Anyway, let's see how to extract the data we're interested in from our code. Instead of logging to the console, let's take the snapshot docs property. This works a bit like an array, so it has a for-each method that we can use to iterate through each Firestore document. Let's print out each document now. In fact, we can log the document ID, and then each document has a data method that returns all the fields in that document. So let's see what happens now. You can see that it printed 3 lines, one for each entry, and each document has an ID and an object with its data containing our title and description fields. So we can see all the data we want to display on our page. Now we just need to structure it in the right way. If we go back to our JSON object that represents the Firestore data model, each document we get from Firestore looks a bit like this. It has an ID and then a separate data object with the title and description fields. But to display it on the page, it's easier if it's more like our original dummy data, where each entry is a single object with ID, title, and description properties all at the same level. So let's convert the data returned by Firestore into a more convenient structure. We'll want an entries array, so we can take the snapshot docs and use the map method to transform each document into a JavaScript object. Note that we need to wrap the curly brackets in parentheses in this case, so that it's interpreted as an object expression and not as the function body. Anyway, Each object will have an ID that will be the same as the document ID. And then we want all the fields that are in the document data. So we can use the object spread syntax to expand all the properties in the object returned by the document data method. To make sure you understand what's going on here, let's log the entries array to the console and save this file so we can see the output. Entries is an array with 3 elements, and you can see that each element is an object with an ID, a title, and a description. So that's exactly what we wanted. Now that we have the data in the right format, all we need to do to display it on the page is update the entries state variable to be the array we just prepared. And if we save now, we can finally see the entry titles in the home page. Okay, so this is how you can fetch data from a Firestore collection. It's an asynchronous operation, just like fetching data from any web API. But we usually also want to convert the documents returned by Firestore into JavaScript objects that are easier to work with in our code. In the previous video, we got our home page to display data loaded from the Firestore database. Since we only updated the home page, if we try viewing the details for an entry, that doesn't work, because the entry page is still trying to use the data from our local file, but there is no entry there matching the requested ID. The ID is a long string starting with 5U, and if we look in the Firestore console, that ID should be the same one as the first document in the entries collection. So we'll need to update our entry page to fetch that document from Firebase, similarly to how we fetch the entries collection in the home page. So let's open the entry page. Here we are currently using the entries from our local data file, which is this one. Now we'll want to replace that data with the one coming from Firestore. So let's import that Firebase service. Let's collapse the imports again, and we can remove all this old code. We want to fetch the entry from Firebase, and we already have the entry ID passed in as a route parameter. Incidentally, in this video, the code is calling useRouteMatch to get the parameter. But if you've been following along with the previous videos, your code should call useParams instead. Please ignore this small inconsistency and just keep using useParams, that's simpler. Anyway, to fetch the entry from Firestore, we'll first need to keep it as a state variable by calling useState. And if we don't pass an initial value to useState, that should default to undefined, meaning that we don't have any entry data yet. Now, like in the home page, we want to call useEffect to trigger the loading of the data, passing an empty array here, so it will only run this effect once. And here we'll want to start from the entries collection, just like we did in the home page. So let's copy this bit of code, but in this case we don't want the collection, we want a single document inside that collection. For that, we can use the doc method that returns a document reference. And when we call this method, we need to pass the ID of the document we want. That in this case is the ID passed as a route param to this page. Okay, so this returns an entry reference. Like with collections, a reference is just a pointer, if you like. To get the actual data, we need to call the get method, and this returns a promise of a document snapshot. So we can call then on the promise to receive the document. And here we want to convert the Firestore document into an entry object that we can display on this page. Just like we did in the home page, where we converted each document in the collection to an object containing both the ID and all the data fields. The only difference is that in the entry page we don't have an array but a single entry object. So here we'll set the ID to be the document ID and expand all the data fields to be part of this object. At this point, we just need to call setEntry passing the entry object. Now, there's an error here. TypeScript doesn't like that we're passing an object with an ID property as argument to the setEntry function. I think that's because when we called useState, we didn't pass any value, so TypeScript somehow is guessing that the type of the entry variable is always undefined. Anyway, we can explicitly pass a type argument to useState, and if we pass any here, that means we can set the entry to be any object we want. That's just a quick way to fix this issue. Now, there's another problem highlighted by the editor. It says useEffect has a missing dependency, the ID. And that's quite correct, because if the ID changes, then we need to fetch a different document from Firestore. So we should do what that warning suggests and add the ID as a value that this effect depends on. Okay, let's see if things work now. Clearly not. There's an error saying cannot read property title of undefined. Okay, it's trying to read the title property, so it must be at this point. And entry here is undefined because that's its initial value before we get the data from Firestore. So what we could do here is use the optional chaining operator. This question mark means if entry is defined, then use its title. Otherwise, this entire expression will evaluate to undefined, which means it will not display anything. And we should do the same for the description as well. Let's see if this fixes it. We can now see the entry details on the page. If you noticed, it did show some blank values initially before loading the data. We could display an ion loading indicator while it's loading the data, but I'll leave it as it is for now. Let's start from our home page again and see if the other entries work. We can see the second entry, and if we go back, we can try the third entry as well. It's all working fine. So our entry page is now fetching its data from Firestore, which means that we don't need this local data file anymore. Let's just delete it since we no longer use it anywhere in our codebase. Okay, so this is how you can fetch a single document from Firestore. It's pretty similar to fetching data for a collection, except that in this case we request a single document with a specific ID. In the entry page, we're now loading the data from Firestore. In this component, we keep an entry state variable, and when calling useState, we set any as the variable type. It will be better to create an interface and define exactly what an entry should look like. In fact, we use the same kind of object in the home page as well, where we keep an array of entries. Therefore, each element in the array is an object of type entry. So let's go and create this interface. I'm going to create a new file at the same level of app.tsx and call it models.ts, because here we'll keep our data models. Here, let's export an interface called entry, and each entry object must have an ID, that is a string, a title, that's also a string, and a description, always with the same type. Okay? So this interface simply describes the kind of objects we've been using all along. Now let's go and use this interface. Let's start with the entry page. Here we want to import our new entry interface from our models file. And then we can use entry as the type for our state variable. This way, TypeScript will ensure that whenever we use this state variable, it must be an object that conforms to our interface. In fact, it's showing an error now when we call setEntry. TypeScript says that we're passing an object that only has an ID property, so it's missing title and description. That's because when we create this entry object, we don't explicitly set title and description. We just expand all the properties from the document data. And TypeScript has no way of knowing what's in this document data. But we do know that each Firestore document has a title and a description. So what we can do in this case is cast the object to be of the right type. By writing as entry, we're basically telling TypeScript, trust me, this object really is an entry. And this will persuade TypeScript to treat this value as of type entry. Okay, so we updated the entry page to use our new interface. Now let's save and make sure our app is still working. Okay, we didn't break anything. Now, thinking about this bit of code again, here we are converting a Firestore document into our own entry object. And this is something we do both here and in the home page. So we could extract it into a common function. Let's copy this code, and we can keep it in our models file since it's related to our data model. Here, let's write a new function. Let's call it toEntry. It will take as parameter a Firestore document and return the object we copied from the entry page. Now, we should also explicitly say that this function returns an entry. And that's all it needs to do, really. Take a Firestore document and convert it into an entry. Now let's go and use it in our entry page. First, we'll need to import it. We can add toEntry here. And now we can go and use it. We can replace this bit of code by calling toEntry, passing the Firestore document. In fact, since it's now so simple, we can do that directly when we call setEntry. And since we now have a single statement in this function, we could even keep everything in a single line. Okay, that's simpler. Let's make sure everything still works. All good. Now that we've done the entry page, we'll want to do the same in our home page. Let's go and copy the right imports from here. So we can simply paste them into the home page. Let's add the imports here. And now we can declare that the entry's state variable should be of type entry array. The square brackets after entry means it's an array where each element is an entry. And then we can simplify the code that converts the Firestore documents by applying the toEntry function to each element in the docs array. We can pass the toEntry function directly to the map method because that's exactly the same thing as applying the function to each element in the array, like this. So we might as well go with a simpler syntax. Okay, now we could simplify this code a bit further by doing this when we call setEntries. And since we're only using the docs property from the snapshot, we could use the object destructuring syntax and remove snapshot altogether. At this point, we could also keep everything in a single line. Okay, that's more compact. Let's save and do a quick test. We want to look at the home page now, since that's what we modified. It all looks good. No errors in the console either. So that's it. We've done some refactoring. We defined an interface describing our entry objects and extracted this toEntry function to convert a Firestore document into an entry object. As a final tweak, this doc parameter currently has type any. This is fine, you can leave it like this, but as an optional step, if you really want types everywhere, then the correct type for this will be a Firebase Firestore document snapshot. But at this point we have an error here, because if doc is a document snapshot, then TypeScript doesn't believe that expanding doc data will give us the right properties for an entry. So we'll have to cast the object as an entry, like we did earlier in the entry page. Up to you if you want to get to this level of type definitions or if you prefer using any here and there. At this point, our app is displaying the data loaded from the Firestore database. So in the home, for example, we see our list of entries. However, these entries are the same for all users because they're stored in a top-level entries collection. This database structure does not allow us to keep separate entries for different users. But in our application, we'll want each user to have their own list of entries, not share the same data with everybody else. So how can we achieve that? Let's remind ourselves of what the Firestore data model looks like. We said that conceptually we can think of the Firestore database as a big JSON object. And at the moment, we have a top-level collection called entries that contains various documents indexed by their ID, and then their data object that contains fields like the title. I'm not going to write the full data again, but we'll have multiple documents in this collection. Now, the challenge is how can we structure this data so we can have separate entries for different users? Well, first of all, we could have another collection called users, where the ID of each document is the user ID. Now, we know that each document can have simple fields. For example, we could store some user preferences here, like what's their theme, and maybe this user selected the dark theme. Imagine that our app lets users customize the user interface by selecting one of a few predefined themes. So this theme would be a simple field in Firestore with the type of string. And of course, we could have multiple documents in the user's collection, each one with a different ID. And maybe the second user prefers the light theme. So this is a simple way to have different values for different users. Now, what I haven't told you yet is that in addition to simple fields like strings, a document can also contain a collection. So the first user could have its own entries collection, and the second user could also have its own separate set of entries. So this is how we can have entries that belong to a user. To fetch the right data, we'll simply use different paths. So, for example, users U1 entries will reference the entries collection for the user with ID U1, while users U2 entries means the entries for the second user. Okay, so this is the approach we're going to take to separate the data by user. And as the user ID, that is for each document in the user's collection, we'll want to use exactly the same ID that we get from Firebase authentication. This way, we can match up the data we keep in Firestore with the users in Firebase authentication. In fact, let's go and open the authentication console in a separate tab. So these are the user IDs we'll want to use in Firestore. Now let's go and create some data using this new approach. First, we want a new collection called users. And like we said, the ID of each document will be the same user ID that we can copy from the authentication panel. So this is the ID of the first document in the users collection. Now here we can add some fields, but this only works for simple fields like strings. So let's save this document without any fields to begin with. And from this view, we can now add a collection under the new document. Now, as the collection ID, we want to put entries. Click Next. And here we can add an entry document. So let's use an auto-generated ID. Then we can add a title field with a string value that says first for test1. So it's easy to see which user this belongs to. Next, we also want a description field because that's required by our entry interface. Now we can click Save, and we have the first entry document for the first user. Now, to be able to test that each user has their own entries, we'll need at least another user. So let's go and copy the ID of the second user and go and paste it as the document ID. Then save without any fields. Now we can add a collection for this user, always called entries. Go to the next step. And again, let's auto-generate an ID for the entry document, then add a title. In this case, it's the first entry, but for user test2. Now we need a description as well. So this is the first entry for the second user. Save this document. And we now have an entry for the second user as well. Okay, so we are in a position to go and update our app. We want to change our code to get the user-specific entries. And to do that, we'll need to use this user ID that we already keep in our authentication state. So let's start from the home page. We need to get the user ID in this component. Let's remind ourselves quickly how our authentication logic works. In this auth.ts file, we export a useAuth hook that returns an auth object containing logged in and user ID properties. For example, in the login page, we call useAuth and extract the logged in flag. So we'll want to do something similar in our home page. Here in the component function, we can call useAuth that we need to auto-import, and this returns an object from which we can extract the user ID. Next, we need to change what we request from Firestore. Instead of the entries collection, we want to start from the users collection. Then we want the document inside that collection with the ID that's the same as our user ID. And finally, from this document, we want to get a nested collection called entries. And this whole method chain will still return a reference to a collection, so we can leave the rest of our code unchanged. There is, however, a warning here. It says that useEffect is missing the user ID dependency now, which is a valid point. If the user ID changes, then we need to run this effect again in order to fetch the data for that user. It's a good thing that the React developers provided these automated checks to make sure we use hooks correctly. Now let's save our changes and see what happens. We can see a single entry with title first for test1. So it's clearly fetching the data specific for the test1 user. But to double check, let's log this user out and then log in again, but as test2 this time. Let's type the password, click login, and now we see the entry for test2. So we achieved our goal of keeping the entries separate for each user. We're not quite finished though. If we open the entry details, nothing happens. We just see a blank page. That's because we haven't updated the code in the entry page yet. So it's trying to load a document from the top-level entries collection instead of the user-specific one, and therefore it doesn't find any data. We'll need to do what we're doing in the home page, call useAuth to get the user ID. And we need to import useAuth first. Then we want to start from the document that represents our user. I'll copy this bit so we can replace the first part like this. Start from the users collection, find the document with the user ID, then the entries collection, and finally the document with the entry ID passed as a route parameter. Okay, now there's another warning. Again, we need to add user ID as a value that this effect depends on. And I believe that should be it. Let's save and do some tests. We can see the right entry in the home page. Now let's try selecting it. And this time we can see the correct title and description. So it's loading the right entry specific for this user. Okay, so the entry page is working. Note how with Firestore we build a path to our data by alternating collection and doc, collection and doc. It's the same in the home page, except in this case we stop at the entries collection. And with this, each user can keep their own separate list of entries, which is a fairly important piece of functionality for our app. We reorganized the data in Firestore so that each user has a separate list of entries, and we tested that our app displays the right data for each user. However, it's still possible for a malicious user to view other people's entries. If somebody is trying to hack our app, they could figure out a way to query the user's collection and get all the user IDs, and once they know a user ID, there's nothing stopping them from getting all the entries for that user. That's because in our security rules, we're still allowing anybody to access any data. We allow to read and write any document if true, which means always. So it's now time to revise these security rules and implement some more restrictive checks. If we look in the Cloud Firestore guides, there is a section about security rules, and in this page we can see a few examples of how to restrict access based on user authentication. If we want to only allow authenticated users to access the data, then we can use this condition, checking that request auth UID is not null. So there is this special variable we can use called request auth UID, that is the ID of the authenticated user making the request. But in our case, we don't simply want any authenticated user to access all documents. We want each user to only be able to see their own data and not other users' data. So to do that, we can first use a match pattern like this. That means this rule applies to all documents inside the user's collection. But also it captures the request document ID as a user ID variable, and then we can use that user ID in the condition logic. So this is saying you can access this document only if your authenticated user ID is the same as the document ID. In other words, each user can only see their own documents, which is exactly what we're looking for. So let's go and write a rule like this. Now, the other question is, how do we test these security rules? How can we make sure that what we write here in this strange language actually works as we expect it to? Thankfully, this console provides this rules playground. We can use this tool to simulate some Firestore requests and see if they are allowed or not according to our security rules. In this location box, we can enter the path to a document. For example, we could enter users U1, meaning the document with ID U1 inside the user's collection. And note that this document doesn't need to actually exist in our database, it's just a simulation. Now, if we click Run, this tool will tell us if we are allowed to get that document based on our security rules. And in this case, we are allowed because our rules allow everything. But if we change the condition to always be false, that should deny everything. And if we click Run Now, you can see that our request has in fact been denied. So now that we know how to test these rules, let's go and follow this example to allow each user access to their own data only. Let's copy this pattern and use it instead of matching all documents. So this way, we only match documents inside the user's collection. Now let's look at the condition. We want this bit where we check the user ID. So we want to allow access if the user making the request is the same as the document path. Now let's test this rule. Strangely, we get an error this time. It's complaining about a null value, And if you notice, there's a little arrow pointing at the request variable. So I think the problem is that since we're not an authenticated user, then request.auth is null. In any case, if the request fails, it means we're not allowed to access the data. We can simulate an authenticated user by toggling this switch. And then we can also enter a Firebase UID here. Again, this doesn't have to be a real ID that already exists. So we can write U1 here so it matches what we have in the location. We are pretending to be an authenticated user with ID U1. Let's try getting the data now. And you can see that our request is now allowed, which is what we wanted. But if a different user tries to access the same document, that should not be allowed. And in fact, it doesn't work, because the user in the request is not the same as the document we're trying to fetch. Only user U1 can access this document. Now, in our own data, we actually want to fetch the entries collection for a given user. But we cannot simulate getting a collection. This path must be document level. So let's get an imaginary document inside the entries subcollection. And let's see if this works. We are denied, which is surprising. We are authenticated as U1, so why can we not access this path? Well, that's because this pattern only matches documents in the users collection. It doesn't work with sub-collections. If we want to match any documents starting with this path, then we need to add a wildcard like this, where ** means match everything. Let's try the same request again, and this time we are allowed. Just to be sure it works, let's try as user U2 as well, and this time we are correctly denied, because U2 cannot access the entries for U1. So we can be confident that this rule does exactly what we want, and since we're happy with it, let's publish these changes. Once the new rules become effective, each user will only have access to their own entries. Now let's close this playground. Here we can see the change history. Let's close this message as well. And this is the final version of our security rules. Let's go back to our data. And by the way, we don't need this top-level entries collection anymore, because we now keep the entries inside each user. So let's go and delete this collection. And we need to confirm by typing the collection ID. Go ahead and delete it. And now we only have a users collection. Okay, now let's go and test our app to make sure it still works. We didn't actually change anything inside the app, but the Firestore security rules can also affect it. So let's reload this page. And everything looks fine. We are logged in as user test2, and therefore we see the entry for test2. What we could test is that we should not be allowed to see other users' entries. Let's go and copy the other user ID. We need to open the authentication console. And we want to copy the ID for the test1 user, because we're currently logged in as test2. So to see if we can access the other users' entries, we can paste their user ID here. Save these changes and see what happens. We get an error, which is good. It says missing or insufficient permissions. So this confirms that you cannot see somebody else's data. We can now revert this change and get our app back to a working state. Okay? It's important to test these security rules properly, because if your app is insecure and doesn't protect your users' data, the consequences can be pretty bad. But using this rule, we can be sure that each user can only see their own data. Okay, each user can see their own entries, and only their own entries. But so far, we can only see the data that we manually inserted into the database. Our users will not have access to the Firebase console, of course. we should really provide a way for users to add new entries from within our app. Let's start by creating a new page component, and I'll clone the entry page just as a starting point. But let's call this the add entry page. And then, as usual, we'll need to change the component name here and at the bottom of the file. Next, we can actually delete all this functionality and also remove all these imports. This add entry page will actually be quite different from the entry page. Let's change the title to say add entry, and I'll just write to do as the content. Now we should add our new page to the router mappings. In fact, it won't be in app, but in the app tabs component, because here is where we have all the pages visible to logged in users. So let's duplicate this route, and instead of my entries ID, it could be /add maybe. And this will render the add entry page that we need to import. Okay, let's go and test this new route. We'll need to manually enter the right URL for now. And surely enough, we can see our new page. So it's all looking good, right? But appearances can be deceiving. There's actually a problem with what we just did. And to show you what the problem is, let's add some logging to our new page. Here we can simply log a message every time this component is rendered, which means every time the component function is invoked. And we're printing which page it is, because we want to add a similar message to the entry page as well. But here it will say entry page occurs. Now let's save and see what happens. You can see that the add entry page was rendered, but then the entry page was also rendered. That's strange. Let's try again by starting from the root path. Obviously we see the home page. Now let's try selecting this entry. And we can see that the entry page is rendered. That's expected. It's actually rendered multiple times because we fetch the entry data from Firestore. So initially the component is rendered with the default state. Then once we receive the data, it's re-rendered with a new state. That's normal. That's just the way React works. But now let's see what happens if we go to the /add page. Again, this renders the add entry page as expected, but then it also renders the entry page. Why is that? To understand what's going on, let's look at our routes again. When we request /add, this matches the add entry page path, but it also matches the entry page path, because the ID placeholder in the second path is like a wildcard. It matches any string, including add. Now, you may think that only the first route that matches should be used, but that's not how Ion Router Outlet works. If there are multiple routes matching the requested path, all those components will be rendered, even though only one page will be visible because it's displayed on top. If we want to do an exclusive match where only one route can be selected, then we need to use a switch component like we did when we added the page not found case. But unfortunately, we cannot use a switch inside an Ion Router outlet. So how do we fix this tricky issue? Well, we can simply work around it by changing this path to be view/id, for example. This way, it will no longer match entries/add. There is no possible overlap between these different paths now. This is a simple solution that doesn't look too bad, even if you want clean URLs. So let's see if it works. Let's reload the page just in case. And you can see that now only the add entry page is rendered, because that's the only route that matches the requested path. Now, before we test the entry page, we need to update the link here in the home page to say view and the entry ID. Let's start from the home page again, so we can select the entry from here and make sure that link works. Okay, so that's our routing sorted. The way the router works is not super intuitive. It allows multiple components to be rendered for the same path because that can be useful in some circumstances, but most of the time it's not what you want or expect. So that's why I wanted to make you aware of this potential pitfall to be avoided when defining the routes for your application. We created a new page to let the user add a new entry, and we mapped it to the entries/add path. But now we'll need to add a way to navigate to that add entry page from the home page. To do that, we're going to use a new Ionic component. If we search the docs for Ion Fab, we should find the right page. Fab stands for Floating Action Button, and it's a sort of round button showing only an icon, like the ones we see here on the right side. We could show a Fab button in our home page with a plus sign, meaning it can be used to add an entry. So let's go to our home page. We'll want to add the button here at the end of the content. So we want an Ion Fab that needs to be imported. But this element is just a container. For the actual button, we need the Ion Fab button element. And then each Fab button must have an icon. So we also want an Ion icon. And here we'll need to set the actual icon, but we'll need to import it first. We want to import something from Ionicons/icons. And here we should find an add icon that I'm going to alias as add icon because add sounds more like a function. Now let's set the icon attribute to be the add icon we just imported. And if we save, we can see our Fab button on the page. Next, we want to position the button, and that's what this Ion Fab element is for. Here we can set the vertical position. That can be one of these three options, and we'll put it at the bottom. And then we can set the horizontal position, where the value can be one of these choices. In this case, let's use end. So our button should now be displayed in the bottom right corner. That looks good. Of course, we can go and click this button, but nothing happens because there's no functionality attached to it yet. What we want this button to do is simply open the add entry page. So we can use the router link attribute linking to my entries add. Okay, let's see if this works. If we tap this button, we go to the add entry page. Simple enough. So that's it. This is how we can use fabs or floating action buttons. They are intended to be used for the primary action of a page, and they're floating, meaning that their position is fixed. So if we had a lot of entries in this page, you could scroll through the list, but the fab button will always stay in the same position. We now have a fab button that lets the user open the add entry page. It's now time to add some content to this page. So let's go and open its code. For a start, we can remove this logging statement. Now we can go and replace this to-do placeholder. And what we want to do here is create a simple form where the user can enter the entry details. Since we did create a few forms before, like for the login page, I'll go pretty quickly in this video and only show you the major steps. So here we start by creating the visible elements of the form. We have two fields for the title and the description. The only element we haven't seen before is the Ion text area used for the description. That's just like an Ion input, but it allows to enter multiple lines. And we can see the form displayed on the page. Let's move to the next step. To make it easier to see the relevant parts, I'm going to collapse the Ion header. So what we did here is bind the form fields to state variables. We use the useState hook to initialize two state variables for title and description. On the title input, we set the value property and handle the onIonChange event. And then we do the same for the description field as well. Again, the only difference here is that this is an Ion text area component. So at this stage, we have a form and we can use the values entered by the user. The next step is to add a save button. You can see it in the browser. And if we look at the code, here's the Ion button element, and on click, we call a function called handleSave. That's defined up here. At the moment, it simply logs the form values to the console. So this is our basic form. If we do a quick test, we should be able to enter a title, a description, click Save, and we can see the values we entered logged to the console. Pretty simple stuff. Now we can add the real functionality. Instead of just logging something, we want to actually save the entry into the Firestore database. So we need to start by importing the Firestore service, because we don't have it here yet. Import it from the Firebase module, so we can use it to save the entry to the database. Now, we'll also need the user ID, because an entry belongs to a user, and we can get it by calling useAuth that we need to import. Now, in the handleSave function, that is when the user clicks Save, here we first want a reference to the entries collection. Using the Firestore service, we can get the collection named users. And then we want the document for the current user ID. And finally, we can get the sub-collection called entries. Next, we need to prepare the entry data that we want to save into Firestore. So this will be an object with title and description properties. Those variables will contain the values entered by the user. At this point, we can use the entries ref to add the new entry. If we look at this method's documentation, it says that it adds a new document to the collection, and it also assigns a document ID automatically. We just need to pass the data as argument. Okay, so let's call it with our entry data. Now let's check what it returns. As usual, it returns a promise and it resolves to a document reference. So we get a reference to the new document. Since it returns a promise, let's make this function async so we can get the entry ref if we await the result. And for now, let's just log something to the console, saying that we saved the entry ref and we can get its ID. So this should print the Firestore document ID. Let's save and test it out. We want to add a title, say test1, and a description like description1. Click the Save button and we see the ID of our new entry printed to the console. Now, in the browser, we're still on the same page. We'll want to send the user back to the home page. But for now, let's manually reload the app, starting from the root path. And we can see our test1 entry in the list. If we go and open it, we see the description as well. And the ID will be in the URL. It's this long string here. It should be the same ID we saw in the console after saving. Okay. Now, we said that on this page, after the user saves the entry, we should send them back to the home page. Let's see how to do that in our code. To navigate to another page, we need some router functionality. React Router provides a hook called useHistory that we can call to get access to the browser history. And we can use this history instance after the entry has been saved to call the goBack method that will send the user back to the previous page. Assuming that the user opened the Add Entry page from the home page, sending them back will show them the home page again. Let's see if this works. Let's start from the root of our app. Now let's go and add a new entry. Let's enter test2 and description 2 this time. Save. And we're back in the home page. So the navigation part worked as expected. However, we don't actually see our new entry in the list. There is no test2 entry here. Let's try refreshing the page. Look, the test2 entry is there now. So the entry was saved successfully, it just wasn't showing up in the list. It seems like the home page is not refreshing the data if we simply go back after saving a new entry. We'll find out exactly what's going on and how to fix it in the next video. We added the functionality to save a new entry, but we have this problem where when we go back to the home page, we don't see the new entry in the list unless we reload the page. Let's look at our home page code and find out why that's happening. We can start by adding some logging here. Let's print a message every time this page is rendered, saying which page it is, and let's also show the entries data. Okay, now let's see what happens. We can see in the console that entries is an array with 3 elements, where each element has all our usual entry properties. The home page is rendered twice, the first time with an empty entries array, but that's just the default value we pass to useState while we wait for the actual data to be loaded from Firestore. Now let's see what happens if we go and add a new entry. Let's write test3 as the title and description 3. Last time we created test2, so I'm just incrementing the number. Now what we see in the console is that our entry was saved. The add entry page printed the new document ID, but there are no messages from our home page, so it hasn't even been re-rendered. No wonder we see exactly the same list as before without the new entry. Now, if we reload this page, then it will fetch the data from Firestore again, and we see 4 entries now, including test3. But why is the home page not rendered when we go back to it after saving an entry? That's because of the way the Ionic router works. When we open the add entry page, the home page component is not removed. It's just not visible, but is still there in the background. So when we go back to the home page, the Ionic router simply reveals the existing home page component. And it keeps multiple component pages alive in order to display those nice transition effects whenever we navigate from one page to another. So how can we make sure that the home page displays the latest data from Firestore? At the moment, we're calling the get method on the entries ref. Get only returns the current values in the collection, but there is a way to listen for changes in the data. This entries ref instance also provides a method called onSnapshot, and we can call this method to receive a new snapshot whenever the data changes. This snapshot variable is of type querySnapshot, which is in fact the same type we get from the promise returned by the get method. So this snapshot object will also have a docs property, which we might as well extract directly here. And in fact, we can use it exactly like we did with the get method. So we can delete this old line. Just one last thing. OnSnapshot returns a function, and if we look at the documentation, it's an unsubscribe function that we can call to cancel the snapshot listener. So this is a cleanup function that we should return from our useEffect callback. Because if React ever unmounts this component, we should stop receiving onSnapshot updates. Okay, with this, we are ready to test our application again. We have 4 entries at the moment. That's what it logs in the console as well. Now let's go and add another entry. This time it's test4 and description 4. Let's save. And we can immediately see the test4 entry in the list in the home page. If we look at the console, the home page was re-rendered with 5 entries. In fact, the home page was updated even before add entry page logged its saved message. So by using onSnapshot, we receive the new data as soon as it's available. The Cloud Firestore database sends real-time updates, and this feature can be used to do some interesting stuff. Just as a quick demo, I want to show you what happens if we add a new entry from the Firebase console rather than from within our application. So I set the title to test 5 for this entry. And if we save this document, you can see that test 5 shows up pretty much immediately in our app user interface as well. So you could use Firestore to build, for example, a chat or some sort of real-time collaboration functionality. By using onSnapshot, we get notified as soon as there is new data, even if it was inserted by somebody else from another app. There are many possible uses for this feature, but at a minimum, we can use it to make sure that our app always displays the most recent data. By listening to onSnapshot updates, our add entry functionality is now complete. And by the way, we can remove this log message now. So at this point, we can view all our entries and we can add new entries. But there's currently no way to modify the entries. At a minimum, we should add the possibility to delete an entry. To keep it simple, we could add a button on this page. So after you select an entry, you can decide to delete it. Let's go to the code for the entry page and see how we can add a button to the toolbar. Like we have an Ion Buttons group at the start of the toolbar that displays the Ion Back button, we can add another Ion Buttons group inside the Ion toolbar, but this time filling the end slot. And here we can show a normal Ion button. I'm going to put an X as the label for now. You can see in the browser that it displays the X in the top right corner. But instead of some text, we could display an Ion icon that should be nicer. As usual, we'll need to import the actual icon image from the Ionicons package and its icons folder. Now, there should be a trash icon. That's a good metaphor for deleting something. Let's go and use this image as the icon property of this element. And we also want to set the slot to icon only. This will style the button correctly for when it contains only an icon. At this point, let me delete this log statement, by the way, but we can now save this file. And we can see our little trash icon at the end of the toolbar. Of course, this is a button, so we can click it. And now we'll need to add some functionality by handling the onClick event. Here we can invoke a function, let's call it handleDelete. This function doesn't exist yet, but we'll go and create it now. Let's keep it separate from all the React hooks at the top. So we'll define our handleDelete function. And here we should delete the entry from Firestore. To do that, we'll need a reference to the entry document. So we can just copy this code, and the entry ref provides a method called delete, which does exactly what it says. It deletes this Firestore document. If we look at the signature, this method returns a promise of void. So it doesn't actually return any value, but it's still asynchronous. So let's declare our function as async, and then we can await this operation to complete successfully. Now, after we delete the entry, we may want to send the user back to the home page, like we did in the add entry page. For that, we'll need to use the router history. In fact, let's go and copy that line of code from the other page, since it's already there. But we'll need to import use history in this file. Now we can use the history service to call history go back, sending the user back to the home page. Let's see if this works. Let's start from the beginning. The first entry in the list is test4. Let's click our new delete button, and test4 doesn't exist anymore. Let's try with one in the middle, like test2. If we delete this one, of course, it disappears from the home page. Now, in a real application, you may want to ask the user to confirm before deleting, to make sure they don't delete something by mistake. Either that, or provide a way to undo the operation. But as usual, in this example, we'll keep things simple. So this is how you can delete a document from Firestore. Simply call the delete method on the document reference. We added the ability to delete an entry. So if we select an entry from the home page, we see a trash button at the end of the toolbar. Now, if we go back to the home page, you can notice how these entries are not in any particular order. They are certainly not sorted alphabetically, but they're not even in the same order we entered them. Otherwise, test 5 should be last. If we want the entries to be sorted in some way, we need to tell Firestore when we make the query. But how do we want to sort our entries in this specific application? Since this app is for capturing daily moments, we should really add a date field when creating an entry and use the date for sorting the entries in the home page. So let's modify the add entry page. Here we want to add a new form field for the date. So let's duplicate an existing field. Let's change the label to say date. And instead of an Ion input, we can use an Ion datetime component. We used that in the biorhythm calculator example, if you remember. Now we'll need to add a state variable to keep the date value. Again, just like for the title, but this variable will be called date. Next, we can go and use the state variable. So this will be the value of the Ion datetime, and we also want to call setDate here. Okay, we have a date field in the form. Now we want to use its value when we create an entry, and we can simply add the date to the data object we saved to Firestore. Let's save and test if it works. Let's start from the home page, just in case. Go and add an entry. We have a date field that shows the Ionic date picker. We can accept the pre-selected date, that is today. We need a title, let's say date test, and some description. This is the one with the date. Now, if we save, we see our date test entry in the list. We're not actually displaying the date yet, but if we open the Firebase console, we should be able to see it in the Firestore data. It's not this one though, this is test 3. Not this one either. I should have checked the document ID. But this is the right one, it's our date test entry. And you can see that it has a date field with an ISO string as its value. This also shows how we can add any field we like to a Firestore document. Since Firestore is a schemaless database, if we need a new field in our data, we can simply add it to our objects when we save them. Now, it's also worth mentioning that, like this, our date field will be a string value. Firestore also supports timestamp fields. If we go and add a new field, in the type selection, you can see that there are a number of options here, including timestamp. And the timestamp has two separate date and time values. Using a timestamp instead of a string may be more efficient. However, to work with Firestore timestamps, we would need to use a class that we can find in the reference. If we look at the JavaScript section, here it shows all the Firebase modules and we want Firestore. Down here there is timestamp. This is a class we can import into our code, so we will need to pass an instance of this class as the field value in the data object we send to Firestore. In other words, we will need to convert a JavaScript date object into a Firestore timestamp using one of these methods. For example, to convert an ISO string to a timestamp object, we could parse the ISO string into a JavaScript date object and then call timestamp from date to get a timestamp instance. So we will need to do this conversion before we save an object to Firestore. But then, when we read some data from Firestore, we may want to do the opposite and convert the timestamp back into an ISO string. This is not difficult, but it would be quite tedious to do in our code. So for this example, we'll keep the date as a string. But please be aware that in a real application, it may be better to use a timestamp. Now, let's go and display the date in our homepage. At the moment, we only display the title for each entry. Let's add the date here, maybe as an H2 heading. Now, TypeScript doesn't like this because our entry interface does not declare a date property. So we'll need to go and update our interface in models. Here we want to add a date property that's always a string. Let's save this file and go back to the home page. It's not showing an error anymore. Since we now have 2 lines in each item row, we could wrap the title in an H3 heading, so it's smaller than the date, and also wrap everything inside an Ion label. That should give it some spacing. Okay, we can see the result in the browser. The only problem is that it's showing the full ISO string for the date, so we'll want to format this date more nicely. Let's add a function to format the date, taking an ISO string as input. We could install a library like day.js to help with dates, but since we only need to do this one thing, we could simply create a new JavaScript date object from the ISO string. So this will parse the ISO string into a date instance. And now we can use the toLocalDateString method. This takes 2 arguments, a locale string and an options object. So for example, to use the US date style, we can pass enus as the locale and then an object with some options. Here we can specify that the day should be numeric, the month should be in the short format, and the year should be numeric as well. So this should return the same format as the one used by Ion datetime by default. Let's go and use this formatDate function. We want to format the entry date. And we can see that the entry in the middle shows April 16, 2020 as the date. Interestingly, the other entries show invalid date. That's because they don't have a date. We created them before adding the date field. So the date property on those entries is undefined, and creating a new date object from an undefined value gives an invalid date. But this actually shows an important point. With Firestore, we can add new fields to our data whenever we want, but we need to be careful in our code to handle old data that may not have the new fields. In this case, we can simply delete the old entries because we're still in the early stages of developing our app and we only have test data. But once you publish your app and people start using it, of course, you need to be a lot more careful. So we added a date field when creating a new entry, but now we have this problem where all the entries created before we introduced the new field are displaying invalid date. So let's open the Firebase console and remove the old data. We could simply delete the entire entries collection for this user. And we need to confirm by typing the collection ID. Okay, so we still have a user document, but without an entries subcollection. At this point, even if we reload the page, the home page is blank because we have no entries. Ideally, we could display a message to the user in this scenario, saying something like there are no entries, instead of just showing the content as blank. But I'll leave that as an exercise for you. What we wanted to do in the first place, if you remember from the previous video, was to sort our entries by date. So let's add a few entries for testing. I'll write 16 here, same as the day, and just copy the same as the description as well. Now let's add another entry. Let's select the 15th this time and write the same number for the title and the description. Let's create a third entry as well. Let's pick the 17th now and write 17 as title and description. Okay, so we have 3 entries, and you can see that by default, when we get them from Firestore, they are in an apparently random order. So let's go and see how we can sort them the way we want. Here in the home page, we call entries ref on snapshot to receive the data. We can customize the query before calling on snapshot by calling some methods on the collection reference. In particular, there's an order by method that we can use to sort the documents in the collection. The way it works is that we pass a field path saying which field to use for sorting, and optionally a direction, meaning if we want to sort in ascending or descending order. So as the field, we want to sort by date, and as for the direction, we can set this short for descending, which in this case means more recent dates first. Okay, let's save and see what's the result. As expected, we see 17 first, then 16 and 15. So it is in reverse date order. Note that since our date field is stored as a string in Firestore, it's actually sorting the ISO date strings alphabetically. But this works fine because of the way ISO date strings are designed. Their alphabetical order is the same as their order in time. Anyway, in addition to order by, there are other methods we can use on a query. For example, we can limit the number of documents we fetch. Let's say we only want the first 2 entries. You can see that we only get 2. And of course, they're the first 2 after ordering them by date, so we can combine these query options together. Now, for this app, maybe we can get the last 7 entries. So we show the last week, assuming the user adds a new entry every day. It's usually a good idea to put a limit on the number of documents you fetch from a collection, because otherwise you may end up fetching maybe thousands of documents, which can make the query very slow and also use a lot of memory in your app. Anyway, let's try opening an entry now. On this page, we're not showing the date yet, so let's go and update our entry page as well. We could actually show the date instead of the title, because our app is about capturing a moment every day. So in a sense, the day comes first. But we'll still want to show the title somewhere, maybe as a secondary heading in the content. In this case, let's wrap the description inside a paragraph tag as well. This way you should add some spacing between the title and the description. Now, of course, we have the same problem as before. It's showing the date as the full ISO string, so we'll need to format the date like we did in the home page. And in that case, let's extract this function into a shared module somewhere. Let's add a new file called date.ts. And here we can paste the format date function that we also want to export. So then in the home page, we can delete it. And where we use it to format the entry date, we need to import it from our new module. Okay, let's check that the home page still works. It's looking good. Now let's open the entry page again. And we can use the format date function in this file to format the entry date here. Of course, we also need to import the function. And we can now see the date properly formatted on the entry page as well. Okay, that's it for this video. The main thing we learned is how to customize our Firestore queries. We can use order by to sort the documents in a collection, limit to fetch only a certain number of documents, and there are other options as well that you can find in the Firestore documentation. For example, you can filter only those documents where a certain field is equal to some value or greater than some value, and so on. All the typical functionality you can expect from a database. In this section, we'll add the ability for our users to set a picture on each entry. A picture is a file that users will need to upload somehow to our backend. And our backend is Firebase. So let's start by understanding where we can save images. We could store the image data in the Cloud Firestore database, but that's not really a good idea because images can be quite large. So this would make our database queries slow, and it could also increase our costs if we need a paid Firebase plan. There's another service called Storage that's intended precisely for storing user-generated files like images, audio, and video. Since we haven't enabled this service yet, we need to click the Get Started button, and we'll be guided through setting up cloud storage. In this first step, it's informing us about security rules. These work very much like the rules we've seen for the Firestore database. But for storage, the default rules allow all reads and writes from authenticated users. That's fine, we'll customize the security rules later. Next, we need to choose a location, but actually it's already pre-selected here. I guess we must use the same location we used for the other services, that is US Central. Let's just click Done then. This will take a few seconds. Okay, we now have some storage ready to use. This interface allows us to manage the files stored in this bucket. It works a bit like other file storage services you might have used before, such as Amazon S3 or even Dropbox. We can create a new folder, for example. Let's say we want to store some pictures in here. Now we have a pictures folder that will initially be empty, but we can upload a file. And if I go to Projects Daily Moments, under Public and Assets, here there is an image file called placeholder.png that I provided as part of the initial project because we'll use it later in our app. But we can upload this file to cloud storage as a test. So now we can see placeholder.png in the list, and if we select it, we'll see some more details, including a preview of our picture. There's also a link we can click to see the full image. And this also shows how each file in the storage has a URL that we can use to view it in the browser, which will be useful when we come to displaying the images inside our app. Okay, so cloud storage is essentially a file system in the cloud. Now, we do want to store pictures in this bucket, but just like with the data in Firestore, we want each user to have their own pictures. We don't want a global pictures folder for all the users. So let's delete this folder now. That was just to show you how storage works. The bucket is empty again. And now we can think about the security rules. As I mentioned, the rules for storage are similar to the ones we used for the database. These initial rules apply to all paths, and they allow read and write access to any authenticated user. But we want each user to only be able to see their own files. So we could organize the files in the same way as the database data. We can have a users folder at the top, then a subfolder for each user using the user ID as the path, a random string like ABC123, This way, we can have a separate Pictures folder for each user, and inside Pictures we'll have the actual image files, identified by some other random string like XYZ789. So how can we write some security rules that match this folder structure? Well, we said it's going to be similar to what we did for the database, so let's look at what we have there. If we select the Rules tab, here we match any document under /users/ and the user ID. So let's copy this bit and go and paste it into the storage rules. Instead of all the paths starting at the root, we want to match all paths starting with /users/user ID. Next, we need to change the condition. For the database, we allow access if the UID of the user making the request matches the user ID in the path. So let's copy this condition and use exactly the same for the storage. Okay, this way users can upload and download any files they want as long as they keep them in the user's private folder. Let's publish these rules. There is a rules playground here where you can test the rules if you want to, but they are very similar to those we used for the database, so I'm confident that they are correct. Alright, we have storage set up and the security rules configured. Now let's enable storage in our application. In this project we have a firebase.ts file where we initialize Firebase and all the services we use. Just like for auth and firestore, we'll need to import the Firebase storage module. So this will enable the storage functionality at runtime, which means that we can export a storage instance that we can get by calling app.storage. And with this, we are making the storage service available to the rest of our application code. In the next video, we'll see how to let users actually upload a picture. In the previous video, we enabled the Firebase storage service that we're going to use in our app to save the pictures uploaded by our users. To let a user add a picture, we'll need to modify this add entry page and provide a way to insert an image somehow. So let's go and open the add entry page in our code. At the moment, we capture 3 values for date, title, and description. We'll need to add a 4th field for the picture. So let's modify this form and add another ion item row. This one will be for the picture, so let's set that as the label. Now, in this case, we don't want an ion input because the user will not type some text here. Instead, we'll want to display an image, so we can use a regular image tag. Now, as I mentioned in the previous video, this project already includes a placeholder.png image inside the public assets folder. So we can display this image as the initial source before the user selects their own picture. And that image will be available at the /assets/placeholder.png path, because any file under the public folder will be simply copied into the web output folder. This is the way any project generated by Create React App works. Now, there's a warning here saying that image elements must have an alt prop. This is for accessibility. Let's just add an empty alt attribute for now. Okay, let's save and see what this looks like. We can see our picture placeholder, but there's no space between the label and the image. This is probably because the image is not a form field, so the Ionic styles don't add the usual amount of padding around it. We could add some custom styling, but I'm going to do a quick and dirty fix for now, and simply add a BR tag here to force a line break. This will do. It's not ideal, but I don't want to spend a lot of time tweaking the styles, because it's not really what this example is about. Now, if we want the user to provide their own picture, we'll need another state variable where to keep the picture URL. It will be a URL because we just want to know where to load the image from. Now, as the initial value, we can still use our placeholder PNG. Okay? At this point, we can use the picture URL variable as the source of the image tag. And of course, the result is the same. We still see the placeholder image. Now, how do we allow the user to actually use their own picture? If we only wanted to build this app for Android and iOS, we could let the user take a picture with their phone camera using the native mobile functionality provided by Capacitor. But if we want our app to work with regular web browsers as well, then we could start by letting the user upload a file using a traditional input type file element. Since we don't want users to upload just any file but only images, we can set the accept attribute to image/star. So this will allow image/png, image/jpeg, and so on. Let's save and see what we get. We can see the choose file prompt, and if we click it, we can select an image from our local file system. I'm not actually going to do that because we're not doing anything with the file yet. So how can we access the file selected by the user in our code? We can handle the onChange event, and let's say we'll write a handle file change function. Now let's go and create this function. We can write it before handle save. So here we have handle file change. As argument, we'll receive an event object. Now let's go and look at exactly what type of object this is. We can actually copy the parameter declaration from here and then go and paste it into our new function. So it's a React change event that applies to an HTML input element. By declaring the type, we should get some auto-completion. This event has a target object, like all events, but since the target is an input element, it has a false property that we can use to access the selected file. Let's log this false object so we can look at it in the console. Let me show the dev tools. Now let's pick a file. I have a few test images in my local pictures folder, so let's select one, and we can see that files is an instance of file list, and it has length 1 because it contains one file, where the file is another object that has a name and other properties. So this looks simple. We could simply get the first element in that file list, and we have the file we want. However, what happens if we open the file selection dialog, but then we change our mind and click cancel? We can see another message logged to the console, which means the event fired anyway. But this time the file list length is 0, so it's empty. We'll need to take this into account in our code. When looking at these event target files, we don't need to log them anymore, but we need to check if the files have length greater than 0, and only in this case we can get the selected file. That will be the item at index 0, that is the first in the list. While if the file's length is 0, we don't do anything, because it means the user cancelled the file selection. Okay, now that we have the file, what do we do with it? Ideally, we'd like to display the selected picture to the user, but we can only do that if the image has a URL. Thankfully, there's a convenient method on the global URL object called createObjectURL. If we pass the file as argument to this method, it will generate a URL that we can use to access that file. I'm going to log this picture URL value to the console so we can inspect it. But we can pass this value to setPictureURL, So this will update our state variable and hopefully display the selected image. Let's see if this works. Let me show the DevTools first. Now let's pick a file again. And voila, we see our picture on the page. How does this work exactly? In the console, we can see the URL generated by createObjectURL. And it's a strange URL that starts with blob, then has our local server address, and finally what looks like an auto-generated ID. So this blob URL is a special kind of URL, if you like. A temporary URL that we can use to access some data that's in the browser memory. That's what a blob is. It's just some data in memory. Now let's see what happens if we select another file. I'll pick the second one this time. We see a different image on the page, and in the console we can see that the browser generated another object URL with a different identifier in the path. So for every file we select, the browser gives it a temporary URL that we can use to load that image directly from the browser memory. This is a neat trick that lets us display a local image that the user has just selected even before we upload it somewhere. However, we need to be careful when using the createObjectURL method, because this can result in our app using a lot of memory. We'll see how to avoid this problem in the next video. So in this Add Entry page, we added the ability for the user to insert a picture from a file. And we immediately display the selected image on the page. We are doing this by using createObjectURL that generates a temporary URL for the image using this special URL protocol that starts with blob. Now, we've also seen that if we select another picture, this will create another object URL with a different identifier. But this also means that now we have created two blob URLs, which means we are keeping two images in the browser memory. If we keep creating new blob URLs, our app will use more and more memory. Let's have a look at the documentation for the createObjectURL method in the Mozilla docs. If we scroll down, at some point there should be something about memory management. So here it says that each time we call createObjectURL, a new object URL is created, as we can see in our logs. But also each of these URLs must be released by calling URL revoke object URL when you no longer need them. So to avoid memory issues, we need to clean up those blob URLs. Let's see how to do that in our code. Since we need to revoke a URL when it's no longer needed, we can use the useEffect React hook that takes a function with our effect code. And we want React to run this effect whenever the picture URL changes. Now, in the function body, we actually want to execute some code after the picture URL has changed, or if this component is unmounted. So here we want to return a cleanup function where we will revoke the object URL. In fact, we could simplify this code a little bit by returning the function directly, like this. So we call useEffect, passing a function that returns a function. Now, to clean up the URL, we can first check if the picture URL starts with blob. And in that case, we can call URL revoke object URL, passing the picture URL as argument. Now let's add some logging so we can see when this code is executed. Let's save these changes, show the console, let me clear it as well. And now we can select a file as usual. And this creates a new URL with a path that starts with 49. Now let's choose another file. and we can see that it created another URL. This one starts with 54. But then it also revoked the previous URL, the one that starts with 49. So that's our cleanup code doing its job. Whenever we select a new picture, we revoke the URL of the previous one. Now let's see what happens if we go to the home page, for example. Since we moved away from the Add Entry page, React unmounted the Add Entry page component, and in the process it called our cleanup function again. So we revoked the second URL as well, the one starting with 54, which is good, because if we are no longer on that page, we don't need that image anymore. Okay. So this way we are making sure that we revoke all the URLs we create and avoid using more memory than we need to. We can remove these logging statements at this point, and let's go back to the Add Entry page. The next thing I'd like to do is don't show this file input element that just looks ugly. We could simply let users click on the image itself if they want to change it. Let's see how we can do that. We could programmatically control this file input element if we get a reference to it. With React, we can use this ref property if we want to manipulate the HTML input element directly. But to use it, we'll first need to create a ref instance. And we can do this by using another React hook. So we'll want a file input ref that we can get by calling useRef. And for better type checking, we can specify that this is a ref to an HTML input element. Now we can use this file input ref by passing it as the ref value on this element. What this allows us to do is manipulate that element from our code. In this case, when the user clicks on this image, we want to execute a function that uses the file input ref to get its current value, that will be the file input element, and trigger a click on that element. So basically what we're doing here is whenever the user clicks on the image, it will be as if they clicked on the file input element. Let's save so we can see this in action. If I click on the image, you can see that it opens the file selection dialog, exactly the same as if I clicked the Choose File button. So with this little trick, we don't really need to display the input element anymore. We could simply set it as hidden, which means it will not show up in the page anymore. But we can still click on the image, and this does the same thing. But it looks nicer without that file input element. Now there's a minor tweak we may want to do. If we disable device mode, so we look at it as a desktop web page, if we move the cursor over the image, there's nothing telling us that we can click here. So let's quickly add some styling to this image element. And I'll use the style property just because it's quicker than adding a separate CSS file. Anyway, here we can set the cursor style to be a pointer, which means that now, if we move the cursor over the image, it shows a nice little hand, suggesting that we can click on this image and something will happen. Just a small improvement to our user interface. Let's re-enable device mode. Of course, on mobile there is no pointer, because users will tap the phone screen with their fingers. Anyway, we can now select a picture simply by tapping on the placeholder image. And of course, we can change the picture by tapping on it again and choosing a different file. I think this is a nice and intuitive way to let our users insert a picture on this page. With this, our form is looking good, and in the next video we'll see how to actually upload the file to Firebase. Okay, at this point in our app, when we add a new entry, we can select a picture and it's immediately displayed on the form. However, we're not actually saving the image yet. When the user clicks the Save button, we execute this handle save function. And at the moment, the data we save to the FARStore database only contains date, title, and description. We could add the picture URL here, but this is not enough, because that picture URL is just a temporary blob URL. We cannot save this URL because it's not a permanent one. What we need to do is save that image to cloud storage first and get a permanent URL that we can use to load that image from the Google servers. So here we can check if the picture URL starts with blob. Then we'll need to overwrite the picture URL value with a permanent URL that we'll get by saving the picture. And we'll need to write this save picture function, of course. But we'll need to pass it the current value of picture URL. That will be the temporary blob URL. Also, saving the picture will be asynchronous, so we'll need to await the result here. Now let's go and write this save picture function. That, as mentioned, will be async. We take the picture URL as parameter, and actually let me change this to blob URL. So it's clearer what sort of URL we expect here. Okay, now in the method body we want to save the image to cloud storage. But how does that work exactly? Let's have a look at the Firebase documentation. To upload a file to storage, first we need to create a reference to the full path of the file. But to actually upload the file, we can call the put method on the reference, passing the file as argument. And this returns a promise that resolves to a snapshot object. We'll write our own code in a minute anyway, but there's also a full example here if you need it in the future. Now let's go back to our app and implement this file upload functionality. Since we need to use cloud storage, we need to import the storage service from our Firebase module, and then we can use this in our function. So here we first want to create a reference to the file we're going to store. Here we can pass the full path as a string. As we discussed when configuring the cloud storage security rules, we want a users folder at the top, followed by the user ID that we actually don't have here, so we'll need to pass it as an argument to this function. But we want a separate folder for each user. And inside that, we'll have a pictures folder. And finally, we need to give a name to our image file. As a quick way to generate a different file name for each image, I'm going to use date now here. This returns the number of milliseconds since January the 1st, 1970. It's not strictly unique, but since each user has their own pictures, it's pretty much impossible that they will upload two images at exactly the same millisecond. A better approach would be to generate a UUID, but I don't want to go and install another library dependency for this example. Anyway, this will return a picture ref, that is, a reference to the file we'll save to cloud storage. This picture ref provides a put method that we can use to upload the file to Firebase. We need to pass it the file data in the form of a blob object. So how can we get a blob object? All we have so far is the blob URL, that is the source of the image we see on the page. Let's see how we can get a blob object from this URL. So we have this string, but since it's a URL, we can fetch it using the fetch API. And this will return a response object that we need to await because it's an asynchronous call. So we can fetch a blob URL just like we make normal HTTP requests. And we get a response object that's like an HTTP response. For example, it has status 200, which means it succeeded. Now, the response object has a blob method that we can call, and we need to await because, again, it's asynchronous. But this returns a blob object, which is exactly what we're looking for. The blob contains the image data, a bit like a memory buffer. So now that we know all this, let's do the same in our application code. We'll get a response by calling the asynchronous fetch method, passing the blob URL as argument. Next, we can get a blob object by awaiting the result of calling response blob. And now that we have the blob object, we can pass it to the put method. So this will be the data uploaded to Firebase. What this put method returns is a snapshot object, but as usual, it's asynchronous. Now, this snapshot object has a ref property, that is a reference to the file we just saved. And on this, we can call getDownloadURL. If we look at this method, it gives us a long-lived download URL. Long-lived in this case actually means that it never expires, unless we manually revoke it using the Firebase admin tools. And it returns this download URL wrapped in a promise, like all asynchronous methods. So we can get this URL by awaiting the result. And this is the value we want to return from this method. But let's log it to the console first, so it's easier to see what's going on when we test it. And now let's return the URL. Okay, let's save and see if it works. It doesn't compile because I forgot to pass the user ID here when we call save picture. We already have the user ID defined in this component. We extracted from the auth object. Okay, let's try saving again. No errors this time. Now let's fill in the full form, starting with the date. Then we need a title. And let's say I went to Endcliff Park today, because I'm going to upload a picture of Endcliff Park. And as the description, I'm going to write that I went for a run in the park this afternoon. Let's start entering some real daily moments. Now, if we click Save, it takes a little while. Ideally, we should display a loading indicator while it's in progress. But anyway, it has now saved our new entry dated May the 13th, and in the console we can see the URL it assigned to the picture. It's on a domain called firebasestorage.googleapis.com. Now, we cannot actually see that image in our app yet, but let's go and look at the Firebase console and see if it's been saved there. There's no refresh button, so I'll just reload the page. And we can see that it created a users folder that contains another folder with the user ID that in turn contains a pictures folder. And finally, we can see our file named with this long number. That's what the dateNow method returned. And here we can see a preview of the image along with other details like the size and file type. If we click on this link, we can see the full image. And the URL in the browser location is similar to the one we got after calling getDownloadURL in our code. Okay, so we successfully uploaded our picture to cloud storage from within our app. The only task left is showing the picture for each entry in our home page and in the entry page as well. And we'll do that in the next video. For now, this is how you can upload a file to Firebase storage. In the previous video, we added the functionality to save a picture to Firebase storage. So now, when we go and add a new entry, we can select a date. Let's pick the 14th, then type a title like Botanical Gardens. Select a picture of the botanical gardens. Enter a description saying I went for a walk in the gardens. And finally we can save this entry, and it shows up as the first in the list because it's the most recent one. However, we don't see the picture we uploaded anywhere. It's saved in cloud storage, as we can see in the console. If we refresh the pictures for this user, we can see a new image here. That's the one we just uploaded. The first image is the one we uploaded in the previous video. In addition to saving the files into cloud storage, we should also see the picture URLs in the data we saved to the database. If we select the right user and look at their entries collection, let's try opening this document. This one doesn't have the picture URL because it's one of our old tests. In fact, we should just go and delete these old entries. Let's try the next one. This is another old one, so let's delete it. Next. This one does have the picture URL field with a URL hosted at firebasestorage.googleapis.com. Let's finish cleaning up these entries quickly. This is our latest one, so let's skip it. The other one must be old, so let's delete it. Okay. So to display the pictures inside our app, we can simply use these URLs to load the images in a normal image element. Let's go and do that. Incidentally, notice how we only see our new entries now, after deleting the old ones. Anyway, let's start from an entry page and display the picture here. Let's go and open the entry page component, which is here. In this file, we get the entry data from Firestore, and then we display its fields in the page. Before we can use our new picture URL field, we'll need to add it to our entry interface. So here we can add picture URL, that is a string. Save this change and go back to the entry page. Now we can add the picture, maybe after the title. So this can be a regular image element, and the source can be the entry picture URL. We'll also need an old attribute to avoid warnings. We could set it to the entry title, since the title should describe what the image represents. Okay, it's time to save. And we can see the picture in the entry page. Simple enough. Now let's go to the home page and select the other entry. Of course, we see the other image. Ideally, we should specify the image dimensions in the component styles, so the browser knows how much space to allow for the image even before loading it. But I'll leave that as an exercise for you. Now, let's go back to the home page. On this page, we could display some image thumbnails. Let's open the code for the home page. Here we render an Ion item component for each entry. We could add an Ion thumbnail element, which is an Ionic component designed exactly to show small preview images. On this component, we can specify a slot, which means where the thumbnails should be positioned. In this case, we can put it at the end of the row. Inside the thumbnail, we can put an Ion image component. This is like a standard image element, but it uses lazy loading, which is better when you have lots of images like in a list. Here we can set the source to be the entry picture URL, and that should be it. Let's see how this works. We can see a thumbnail for each entry in the list. That's nice. I'll go and add another entry, just so we can see 3 of them. Let's select the 15th this time. And the other image I have is of the Whiteley Woods Trail. Let's go and select that picture. And as the description, this is where I usually go cycling among the woods. Let's save. And voila, we see a new entry at the top of the list, capturing another daily moment. And we could keep recording one entry every day, building a collection of daily moments. So far, we only tested our Daily Moments app in Chrome. We'll now go and build it as a mobile app with Capacitor and test it on Android and iOS. Capacitor is already configured in this project that was generated with the Ionic CLI. We also have the Capacitor core and CLI dependencies installed. Now let's stop the dev server in the terminal, So we can start by creating a production build of our web app with npm run build. This generates a build folder with all the static web files. At this point, we can tell Capacitor to generate an Android project with npx cap add Android. When this is finished, we should have an Android folder that can be opened in Android Studio by running npx cap open Android, and this should launch Android Studio. So here we have our Android project, and I've already started the Android emulator as well. Now we can run the app by clicking this button, and eventually we'll see the app in the emulator. Since it's the first time we run it on this device, we'll need to log in, and I'll use the usual test1@example.org user with password test1234. Click Login, and we can see the home page with all our existing entries. If we click on an individual entry, this page looks good. Now let's try adding an entry. I'm particularly interested to see how the picture selector works, because that's based on a file upload input field, which works fine in a regular web browser. But let's see how it works in a mobile app. If we tap this placeholder, it opens this screen where we can choose a file, and it shows our recent images, but unfortunately we have no items here. We can browse files in other apps like in Photos, but again we have no photos here because this is an emulator. In a real phone you would probably have some pictures. But in any case, as a user, I would expect to be able to take a picture at this stage, not just select an existing one. Could we add the ability to take a picture directly using the phone camera? Of course, we can do that using Capacitor. In addition to generating Android and iOS projects, Capacitor gives us access to a number of native mobile APIs. In fact, we already used one of them, that is the splash screen. But all we do with the splash screen is hide it when our app is ready. Now we'll look at the camera, that is a bit more interesting. So this camera API provides some methods we can call from our JavaScript code, and they will trigger some native functionality that's different on Android and iOS. But we don't need to worry about those differences because Capacitor gives us a single API. We can see an example here of how to take a picture. We basically call camera getPhoto passing some options. We'll see exactly how to use it in our own code in the next video. Okay, so we want to use the native camera functionality, because at the moment when creating an entry, if we want to add a picture, we can only select an existing image. But we'd really like to let our users take a picture using their phone camera. And we mentioned that Capacitor provides a camera API to do exactly that. So let's see how to use it in our code now. Since we want to edit our code while running it in Android, I'm going to add a new script here called Start Android that will be a shortcut for Ionic Capacitor run Android with the live reload and external flags. This way we don't have to type this long command every time. Instead, in the terminal, we can simply type npm run start Android, and this will launch the right Ionic command. Okay, so this started a dev server and opened Android Studio. Now we need to redeploy our app, and it should restart, pointing at our development server. In fact, since it's now running on a different server address, we'll need to log in again, which I'll do quickly because it's always the same step. At this point, we should be able to edit our code and see the changes automatically applied to the Android app. Let's do a quick test in the home page, changing the title to Daily Moments, since that's the name of our app after all. Okay, live reload works. Now, what we really want to change is this picture selector here. So let's open the code for the Add Entry page. Here we have a file input field somewhere. Here it is. There is this input of type file that is hidden, so we don't actually see it in the page. But this is what shows the file selection dialog, because when the user clicks on the image element, we trigger a click event on the file input element. Now, if we want to use the native camera API instead, we'll need to do something different when the user clicks on the image. Let's add a new function called handlePictureClick. And we'll need to write this function. We can put it here with the other event handlers. Let's just define this handlePictureClick function. To preserve the existing functionality, here we would need to call fileinputref.current.click. This works for regular web browsers, so we don't want to lose this functionality. But I'm going to comment it out for the moment, because we want to see how to use the native camera now. First of all, we'll need to add an import. We want to import the plugins from the capacitor core module. But we only need a single plugin, so let's extract it here. The plugins object gives us access to all the APIs provided by capacitor. But in this case, we only want the camera plugin. Now let's go and use this. Let me collapse the imports first. So in our handlePictureClick function, we can now use the camera object to get a photo. If we look at the signature of this method, we need to pass an options argument of type camera options. So we can pass an object literal. And there is one option we must always pass called result type. This specifies how we want the image to be returned. There is a camera result type enum that has all the possible values we can pass here. If we set it to base 64, for example, the entire image data will be returned as a very long string encoded in base 64. In practice, I recommend always using the URI option, meaning that capacitor will give us a URL from where we can fetch the image. Since this is the only mandatory option, let's start with just this one. Next, let's see what this method returns. It returns a promise that resolves to a camera photo. So as usual, since it uses promises, let's make this function async, and then we can await the result that is a photo object. Okay, now what do we do with this photo object? Let's start by logging it to the console so we can get an idea. But the photo object has these properties. And the one we're most interested in is the web path. So let's log this one. All right, let's save and do a test. If we go and select a picture now, we see this menu where we can decide if we want to open it from Photos or to take a picture. Let's try Take Picture. Now, since it is the first time we try taking a picture with this app, we need to give it permission to do so. And then we need to try again. This only happens the first time. Now we see the camera. And the Android emulator has this special camera mode where we can see a virtual 3D room and we can look around the room by holding the Alt key and moving the mouse. Of course, in a real phone, you would see the real world, but this is a cool way to let you take different pictures using the emulator. If we move around a bit more, there should be a nice dog here. So let's take a picture of the dog by tapping the camera icon. Then we need to confirm, and we're sent back to our app. In theory, we should have received a result inside our app code, so let's look at the logs in the logcat panel. We want to filter only our app logs and only those from capacitor. Otherwise, there's too much noise. Okay, so the last line shows the photo web path returned to our code. You can see that it's an HTTP URL starting with our dev server address, but then it has this path called capacitor file that suggests this is some sort of special URL created by capacitor. The file itself is a JPEG, as you would expect for a picture. Now, the nice thing about that URL is that we can use it as it is to display the image on the page. If we call setPictureURL passing the photo web path, it should load the picture from that special URL created by capacitor. And at this point, we can remove the logging. Now, let's save and see if this works. Let's go and select a picture again. Let's take a picture using the camera. The emulator even remembers that we were looking at the dog. Let's confirm. And here's our dog picture displayed inside our app, which shows how the image can be loaded directly from that URL managed by capacitor. So this is the most basic way to use the native camera API. Just call camera getPhoto and display the image using the web path returned by capacitor. In the next video, we'll look at some other options and also how to handle errors. In the previous video, we managed to take a picture using the native camera API by calling the getPhoto method. Now let's look at some of the options we can pass here. There are quite a few settings we can customize. For example, we could set the width of the image to, say, 600 pixels. All the options are explained in the capacitor documentation. If we look at the API section, here it shows the camera options interface with all the possible properties, and there are comments with some explanations. So you can read that page if you want to explore all the options. There is one property that I think is worth mentioning, and that's the source. This means where to get the image from. There is a camera source enum that gives us all the possible values. And you can see that we can choose between camera, photos, or prompt. Prompt is the default, so it's what we've been using so far. It asks the user if they want to select an existing photo or take a new picture. If we select camera, for example, then it will always open the camera without asking first. Let's try it out. You can see that this time it didn't show any prompt. It just opened the camera so we can take a new picture. From this point onwards, obviously it works in the same way. So you can use this setting if you want the user to always take a new picture. As I mentioned, the default value for the source is prompt, which will let the user decide where to get the picture from. If we tap on the picture now, we see this prompt giving us both options. Now, something we haven't tried yet is what happens if the user doesn't select anything. On Android, you can use the back button to cancel the operation. Let's have a look at the logs in Android Studio. You can see that there is an uncaught error in a promise. The error message says user cancelled Photos app. This is a condition that we should handle in our code. We don't want exceptions to go uncaught. So let's wrap all this code in a try-catch block. Here we get the error, and to be fair, there's not much we can do here, other than maybe logging it to the console. If what happened is that the user cancelled the operation, then we don't need to show them any message explaining what went wrong. Let's see what happens now if we start taking a picture, but then change our mind and go back. Let's check the Android logs again. We still see the same error saying user cancelled, but this time it's not an uncaught exception. It's just an info level log message. So at least it doesn't get logged in red as a severe problem. Okay, The next thing we want to do is see how we can save the image that we take using the camera. Because at the moment we display it immediately, but we cannot save the entry with that image as it is, because it uses this special capacitor URL that is only a temporary URL, if you like. In fact, if you notice, this file is kept in the app cache, which means that the Android system can decide to delete it if it needs to free up some disk space. So we should treat it as a temporary URL, which is in fact similar to what we did with object URLs in the browser. For object URLs, we check if the URL starts with blob, and in that case we call save picture that saves the image to cloud storage and returns a permanent URL. Could we use the same approach for the capacitor URLs? In fact, we can, because here we're using fetch to get the image data as a blob, and fetch just makes an HTTP request. So it works with any URL, even the special capacitor ones. So we can use this save picture code exactly as it is. But we'll need to call it not just when the URL starts with blob. In fact, we could always save the image when adding a new entry. The only exception is if a user doesn't select any picture, so they leave the default placeholder image. And in that case, there's no point in saving the file to cloud storage, because it's already available in our app. So what we could do here is always save the picture unless the URL starts with assets, which means it's the placeholder image, basically. This is one way to do it. Now let's test saving an entry. Let me start from the home page. To replicate the real flow, let's pick a date. Today is fine. Let's put doggy as the title, since we're going to take a picture of our virtual dog. Nice pose. Let's accept this. And we have our picture. Now we need a description. So this is the dog from the Android emulated camera. Let's save. And we can see the new entry at the top of the list. Here are the full details. It's all working fine, which means that our dog picture has been saved to cloud storage. Okay, let's stop here for this video. We looked at some of the options we can pass to the camera API, and also how we can fetch the image URL provided by Capacitor to upload the picture, in our case, to save it to Firebase. We modified our app to use the Capacitor Camera API when taking a picture for a new entry, but that won't work in a regular web browser. Here we started our app with Ionic Capacitor Run, so we could use live reload in the Android emulator, but this command also starts the dev server on the usual address. So we can try testing this app in Chrome, simply by opening a new tab at localhost 8100, and we can see our usual list of entries. Let me open the DevTools and maybe put them on the side. Also, let's enable device mode, and let's see what happens if we try selecting a picture. There's a big red error. Somewhere in the code it's trying to call camera model component onReady, but that's not a function. What this basically means is that we cannot use the phone camera API because this is not a mobile app, it's a regular web app running in the browser. So we don't have access to the native mobile APIs exposed by Capacitor. One way to solve this problem would be to check if we are running as a mobile app or as a regular web app. We can do that using the platform utils provided by Ionic. There are two functions. One is called isPlatform. We can pass it the name of a platform, like iOS, and this function will return true or false, depending on whether our app is running on iOS or not. The other function is called getPlatforms, and this returns an array with possibly multiple platform names, because the same device can be classified as multiple platforms. Let's try this out in our code so we can see exactly how it works. Let's just log the platforms in the app component, so we will print them as soon as we start our app. Let's add a log statement here. And we can call the getPlatforms function that is imported from the Ionic React module. Now let's go back to our web app, and you can see that as platforms it returns Android, mobile, and mobile web. So there are generic platforms like mobile that identifies any mobile device, no matter if Android or iOS. But it's also saying that this app is currently running on Android. That's because we are emulating an Android browser with the DevTools. If we change this to an iPhone, for example, in this case, the platforms are iPhone, iOS, mobile, and mobile web. So the last two are the same as before. Then it obviously says iOS instead of Android, but it also says it's an iPhone, which is to distinguish it from an iPad. Now, what if we disable device mode, so it's just a regular Chrome browser? In this case, it shows a single platform that is desktop. Note how it no longer has the mobile and mobile web platforms. So that's interesting, but what about when we run our app as an Android app? In this case, the platforms are Android, Phablet, Cordova, Capacitor, Mobile, and Hybrid. There's a lot of them, but what is unique in this case is that it includes Capacitor. So that's what we could look for if we want to check if the Capacitor APIs are available or not. I'm going to remove this getPlatform call now that we've seen how it works. Let's go back to our add entry page and change our code to use the right functionality for the right platform. So when the user clicks on the picture, we can check if the platform is Capacitor. Then we want to execute all this code here that uses the native camera API. Otherwise, we can use our old code that triggers a click on the file input element, so it will let the user select a file. Okay, let's test if this works. If we try in the Android app, we see the prompt where we can take a picture using the phone camera. This should work as before. So that's good. Now let's check in Chrome. This page should have reloaded automatically. So let's click the picture here. And in this case, we can select a file from our local drive. So it works again like a regular HTML file selector. Okay, so this is how you can support both native and browser functionality in your code. Simply use isPlatform to check if we can use Capacitor or not. Now, across this whole example, I've used Android, but everything is the same on iOS as well. I'll just quickly show you the app running in the iPhone simulator. I've already built everything. First I did an npm run build, then npx cap add iOS, and finally cap open iOS. So I've got the project open in Xcode, and from here I started it in the simulator. So here we have our app ready running in iOS. If we go and add an entry and go and tap on the picture placeholder, we see the usual prompt from photos or take picture. Now, if we try taking a picture, that won't work because the camera is not available in simulator. If you want to test the camera on iOS, you'll need to use a real phone, unfortunately. But thankfully, we can still select a picture from photos. And there are a few preloaded images available here. So if we choose one of them, we can see the picture in our app. And this proves that the app is working on iOS as well. In this section, we'll see how to release our Android app, including how to publish it to Google Play. Before we can actually make a release, there are some preparation steps we need to go through. And this page in the Android documentation has a helpful diagram showing some of the possible steps. This includes preparing an end-user license agreement, the application icon, remove debugging and logging, and so on. So let's start preparing our app for release. And we'll use the Biorhythms app again in this section, since we already prepared all the icon and splash images for this app. Let's start from the manifest file that contains the main configuration for our Android app. I said it before, but it's very important to set the package name, because this is what identifies our app. And once you publish your app, you can no longer change the package name. As a reminder, this is set in the capacitor configuration as the app ID, and it must be set before you tell capacitor to generate the Android project. Incidentally, note that I changed this value to start with io.encoded, because I own the encoded.io domain, so this is what I'll use to publish my app. You need to use your own domain name because it needs to be unique. Another thing we need to configure in the manifest are the permissions. As generated by capacitor, this file contains a number of commonly used permissions, but we should only declare permissions we actually need. So let's go through this list. The internet permission is if our app needs to connect to some server over the internet. For example, the Daily Moments app needs this permission because it connects to the Firebase servers. But in the Biorhythms app, everything works locally, so we don't even need internet access. The storage permissions are if the app reads and writes files, like images and stuff like that. Again, the Biorhythms app doesn't need these. Geolocation API is for GPS, and we don't need these either. Network state is if you want to detect when the internet connection goes up or down. The camera permission is to take pictures and videos, and the audio permissions are if you record sound, obviously. So it turns out that this particular app doesn't need any permissions at all. But I still wanted to go through the list to explain to you what they're for. Of course, in many apps you will need some permissions. Now let's look at version numbers. If we select the app module, right-click and go to Open Module Settings. Here we can find some more configuration. If we look at the default config of our app module, here we can find a version code and a version name. Whenever we publish a new version of our app, we need to set these values. The version name can be in any format we like. So instead of 1.0, we could start from 0.1.0, for example. You would typically follow the semantic versioning system here, but it's really a free-form text, so you could put whatever you want. Just as an example, today we could release a version named 0.1.0 with version code 1. Tomorrow we could publish an update named 0.1.1. But we always need to remember to increase the version code as well. So it could be version code 2. Then next week we could release 0.2.0 with version code 3 and so on. The version name is what's displayed to the users. So in Google Play, users will see, for example, Biorhythm Calculator was upgraded to version 0.1.1. But the version code is what's used internally by the Android system to detect when the app can be upgraded. So the bottom line is, before every release, remember to update both the version code and the version name. And the version code must be a number and must always be incremented. Okay, so that's how app versions work. And by the way, those values can also be found in the build.gradle file for the app module. You can see that it says version code 1 and version name 0.1.0, just like we entered in the module settings dialog. You can edit this file directly if you prefer, it's the same thing. the build.gradle file should normally be kept in your Git repository, so you can keep a history of all the changes made to that file. Okay, in addition to configuring permissions and version numbers, there are some other steps you may want to do before releasing your Android app. For example, remove debug logging statements from your code. Make sure that any URLs your app connects to point to production servers and not some dev server you were using just for testing. All the usual things that you would do before deploying a web app as well. But when preparing an Android release with Capacitor, make sure that after making any changes to your web app code, you make a production build of your React app and tell Capacitor to sync the Android project and use the latest web build. Okay, in the next video we'll see how to make a release build of an Android app. In this video, we'll see how to create a release build of our app that we can use for local testing or even to distribute the app outside of the Google Play Store. If we look at the Build menu in Android Studio, there's an item called Select Build Variant. This opens a panel where we can see that we're currently using the Debug Build variant. We can change this to Release, and this will cause Android Studio to create a more optimized build, which is what you want if you're going to publish your app. However, we cannot simply run a release build like we do with a debug build. If you notice, there's an error here saying the APK is not signed. Now, APK is the package format used by Android apps. It's a bit like a zip file. But the interesting part of this error is where it says that our app must be signed. And by signed, it means digitally signed using a cryptographic key. So let's see how to configure signing. If we select Generate Signed Bundle/APK, this opens a new dialog when we can choose between an Android app bundle or an APK. Let's select APK for now, because this lets us build a signed APK that we can deploy to a device. Let's go to the next step. To sign our app, we need a key, and keys are stored in a key store. Since we don't have a key store yet, let's create a new one. First, we need to select a path where to save our key store. And I'll create a new folder inside my home called Keys. Then inside this folder, let's save the key store as Android. I'll call it Local Release because we'll only use this for local testing. But you can name this file however you like. It typically ends in .keystore because it's in the Java key store format. Now we'll need to enter a password, which I'll do quickly. Then we need to enter an alias for our key. Let's call it local release as well. And the key needs its own password that ideally should be different from the key store password. The key store is a container that can store one or more keys. We can leave the validity to 25 years. And then we need to enter a few fields identifying yourself and your organization. But they're just descriptive, they're not super important. If we click OK, this will create the key store. And we can now use our local release key to sign our app. It already completed all the fields with the key we just created. So let's click Next. And here we can choose the build variant. We want a release build. Also, you can select the signature versions. It's a good idea to always select both V1 and V2 here. V2 is only supported on Android 7 or higher. By selecting both, we also support older Android versions. Now let's click Finish, and this will generate a package in APK format, signed with our cryptographic key. That's done. If we expand this message, we can locate the package. And you can see that it created a release folder inside our Android app module. And here there's a file called apprelease.apk. This is the package that contains our application. And there are ways to install APK files directly on an Android device. So we can use it to test it ourselves, or we could also send it to somebody else, maybe a tester that works in the same company, or one of our clients that want to test the app before we publish it to Google Play. In fact, if you're developing an app that's only used internally at a certain company, you could just install this APK directly into the employees' phones. It's not always necessary to publish an app to Google Play. Anyway, now that we do have this APK, let's see one way to install it directly on a device for testing. I'm going to open a terminal, and the current working directory is the biorhythm calculator project. So from here, the APK will be under Android app/release, and we can see the app_release.apk file there. Now, Android Studio should have installed the Android SDK that on macOS by default is at this path. The SDK contains some platform tools that include a command called ADB, which stands for Android Debug Bridge. Now, if you don't know where the Android SDK is installed on your machine, you can check in Android Studio by looking at Preferences or Settings. If you search for SDK here, you should see the location in the configuration. So that's the path you need to use when running the ADB command in the Platform Tools folder. Now, with this ADB command, we can see the list of available devices. In this case, there's just one device, that is the emulator. But if you attach a physical phone using a USB cable, you should see your phone in the list. And we can use ADB to install an app on a device. We need to pass it the path where to find the APK. And since we have a single device connected, we don't need any other option. Now, the installation failed, and that's because the signatures do not match the previously installed version. So what's happening here is that we already had our Biorhythms app installed in the emulator, but it was a debug version. Now we're trying to install a release version signed with our new key. So the signature is different from that of the existing installation. What you need to do if you ever encounter this problem is to simply uninstall the existing app first. So then if we go back and run the same command again, this time it succeeds, which means that we should have the release version of our app installed in the emulator so we can test it. Everything should work just like a debug build, but possibly slightly faster. It's always a good idea to test a release build before publishing it. Okay, so this is how you can create a signed APK with a release build. From the build menu, select Generate Signed APK. In the dialog, select APK, and then specify the key to use for signing. Be careful not to lose the key store file or forget the passwords, because you'll need them every time you make a release. Like I mentioned, you can distribute an APK directly to your users if you want to. But in the next video, we'll see how to publish an app to the Google Play Store as well. If we want to publish our app to the Google Play Store, we first need access to the Google Play console. If it is the first time you try publishing an app, you'll need to sign up for the developer console first. This requires accepting some terms and conditions, and then you need to pay the registration fee. There is a one-off cost of currently $25. Now, I'm already registered, so I don't need to sign up again. But once you have access to the console, you should see a dashboard like this, where you can manage your Android apps. The first step in order to publish a new app is obviously to create an application, and we need to give it a title. In this case, our app is called Biorhythm Calculator. Then we can click Create. and we're sent to the store listing page. Here we can enter all the information that will be displayed to the users if they look at our app in the Google Play Store. As you can see, there's a lot of information we need to enter here. Now, thankfully, we don't need to complete everything in one go. We can start filling in some of these fields. For example, I entered a short description, then I uploaded the icon image and completed a couple of other fields. But at any point, we can save our progress as a draft, which means that we can come back to this console later and finish entering all the details once we are ready to publish our app. In the meantime, we can prepare our app for uploading it to Google Play. Now, there are actually two different ways to build an Android app for Google Play. There's the old way, where you basically build an APK, you sign it with your own release key, which is effectively what we've done in the previous video, and then you upload the APK to the Google Play console. However, there's a newer and recommended approach where instead of signing the app with your own release key, you let Google sign the app. This is called app signing by Google Play, and it has a few advantages. Your app size is smaller, and it's also more secure because Google manages the signing key. You still need to sign the app with the key before uploading it, but in this case, your key is just an upload key. Then Google will apply the official signature to your app before distributing it to all Google Play users. This may sound a bit complicated, but it's not actually difficult in practice. Just like we did to create an APK, we need to select Generate a Signed Bundle, but this time, instead of APK, we need to select Android App Bundle. Let's go to the next step. Now, instead of signing our app with our release key, we need to sign it with an upload key. So let's create a new separate key store. And instead of the local release key store, this will be our upload key store. As usual, we need a password. This key will be the upload key, and again, we'll need another password for the key. The validity must be at least 25 years, which is the default, but this number is half hidden for some reason. Finally, we need all the descriptive fields, and we can create our new key and key store. So now we can sign the app bundle using the upload key. And we may want to export the upload key in case we need to upload it to the Google Play console. I'll save it into my keys folder, since that's where I have all the other keys. Let's move on. Here we already have the release build selected, so let's finish. And this generated a signed bundle. If we go and locate it, you can see that it created a file inside the release folder called apprelease.aab, where AAB stands for Android App Bundle. It's simply another package format. The difference is that APK packages can be installed directly on a device, while app bundles are just for uploading to Google Play. So we have a package ready to be uploaded to the developer console. In the next video, we'll see how to upload it and complete the app publishing process. In the previous video, we created an app bundle that we can use to upload our app to Google Play. So now let's go and actually upload the app. In the Google Play console, we can open our application, and let's start by looking at app signing. In this page, it says that to enroll into app signing by Google Play, we need to upload our app first. Okay, so let's go to app releases then. In this page, we can manage all the releases for our application. We can release to production, so the app will be available to the public, or we can release to alpha or beta tracks. That is useful if you want only some users to test your app. But for this example, we'll release straight to production. So from here, we can create a release, And since it is the first release we make, it's asking us to let Google manage the app signing key. You can opt out if you want to use your own key, but we'll go with the recommended approach and continue. The next step is to accept the terms of service. And now we can finally upload our app, either as an app bundle or as an APK package. So let's go and upload the app bundle we created in the previous video. I will need to navigate to the project folder. And from here, open Android app release. And here we have the AAB file that we can upload to Google Play. This will take a few seconds. Okay, the package has been uploaded. Note how Google Play automatically extracted some information from the bundle. For example, it detected that it has version code 1 and version name 0.1.0. These are the values we configured in build.gradle. If we scroll down, we also need to enter some release notes. So here we can describe what's changed in this version. In this case, this is just the initial release. Let's save these changes. And at this point, we can review this release. So here we just need to confirm that we're happy to roll out this release to production. However, if you notice, we cannot push the button yet. It's disabled because we still haven't finished entering all the store listing information. Before we can publish, we'll need to fill in not just this form, but also the content rating, the app content questions, and pricing and distribution, where we can set our app to be paid or free. There's a fair bit of red tape, and obviously I cannot show you how to fill in every single field, because that would take hours, and it's just about following the instructions on the page. But I am going to show you one thing that can be helpful. Among other stuff, you need to upload some screenshots of your app. You can easily do that using the emulator, simply by clicking this camera icon. This takes a screenshot of the emulator window, and by default it saves the images in your desktop folder. So here we can find the screenshot we just took, and you can upload these screenshots to the Google Play console. Okay, so I have now completed all the information required. You can see that all the sections have green ticks. I just entered the bare minimum required. Incidentally, here's where it needs the screenshots. But anyway, we should now be able to publish our first release. If we go and edit the production release, we can resume from where we left off and review our release again. If we scroll down, this time the Rollout to Production button is enabled. So this is the big moment. We are about to publish our app. Let's do this. This will make our app available to all users of the Play Store. Yes, we want to continue. This may take a few seconds. And it's published. Within a few hours, we should be able to find our app in the Google Play Store. And in this page, we can see the details for this release, like when it was uploaded and its version code. There is also a release dashboard where we can see stats like how many users installed it, ratings, crashes, and so on. Obviously, it's all empty at the moment, because we only just released our app. I am now coming back to the Google Play console after some time, and there's a notification here saying that the update we published is now live in the store. So let's go and look at our application again. We can now view it on Google Play, so let's do that. And here's our biorhythm calculator, available in the Google Play Store, where anybody can install it on their Android phone or tablet. To publish an iOS app to the App Store, or even just to run it on a physical device, you need to be enrolled into the Apple Developer Program. If you're not registered as an Apple developer, you can follow the instructions to enroll. Be aware that there is a membership fee of $99 per year at the moment. Once you are enrolled, you can access the Apple Developer Dashboard. Here I'm logged in with my company account. And from here, you can manage things like certificates, identifiers, and profiles. Certificates are necessary to sign your iOS app. If we open Xcode, here I have our Biorhythms app running in the simulator, like we've seen in a previous section. If you remember, at the time I mentioned that if we look at the signing and capabilities for our app project, at the moment we see this warning saying that signing requires a development team. And we're currently using a certificate called Apple Development that we can only use to run our app in the simulator effectively. Now, if we click this Add Account button, Xcode will prompt us to sign in with our Apple ID. In fact, we can also get to this dialog in another way. If we go to the Xcode Preferences, there's a tab called Accounts, among others. We currently have no accounts configured, but we can add one if we click on the plus icon. Here we can leave Apple ID as the account type, click Continue, and we're back to the same dialog. So here we need to log in with the same Apple ID that we used to enroll into the Apple Developer Program. Of course, we'll need to enter the password as well. And this way we have connected Xcode with our Apple Developer account. In this account, I have two teams. One is my company and the other one is my personal team. I believe it always creates a personal team automatically. Anyway, now that we set up the account, we can select a team in the app configuration. The personal team is only for local development, so let me select my company team. And if you notice, it's now creating a certificate. Then it failed for some reason. It says that it could not create a provisioning profile because there are no devices registered. So if we go back to the developer dashboard and reload this certificates page, we can see that it did create a certificate. It's a development certificate with my name on it. But then it was complaining about devices. So this page lists my devices, and you can see that there are a couple of them, but they're all disabled. In fact, I disabled them on purpose before recording this video to show you what happens the first time. So to continue, we'll need to add a device to our developer account. Since we'll need to use a real device, I'm going to close the simulator, and I'm going to use a real iPhone instead. So here's the screen of my iPhone. It's an iPhone SE I use for testing. And now I'm going to connect the iPhone to my computer using a lightning cable. The first time you connect a phone, you'll get this prompt asking if you trust this computer. Obviously, we need to tap Trust if we want to be able to use this phone for development. Okay, so now that we have the phone connected, if we look at the list of devices here, in addition to all the simulators, we should see a real device. So let's try running our app in the iPhone. There's another problem now. It says the device isn't registered in your developer account. So remember the devices page we've seen in the Apple Developer Dashboard. We need to register this device there by clicking this button, and this fixes the problem. If we go back to the developer dashboard and refresh this page, we should see the device here. There you go. There is an iPhone device that is now enabled. At this point, if we go back to Xcode, and I'll show you my iPhone screen again, we can try running the app on the device once more, and hopefully it should work this time. We see the splash screen. And finally, we see the app as well. Let's test it quickly by selecting some random birth date. And we can see our biorhythms plotted. Okay, so this is what you need to do to run the app on a real device. Connect Xcode to your Apple developer account, let Xcode create a certificate for you, and then register your device. Obviously, this only needs to be done once, then you can deploy your app to the same device whenever you want. In the next video, we'll see how to publish to the App Store. It's now time to submit our app to the Apple App Store. In the previous video, we looked at the Apple Developer Dashboard, in particular at the Certificates, Identifiers and Profiles section. Here I have a certificate created for me by Xcode. And we also look at Devices, where I registered my iPhone device. Now, if we open the Identifiers page, this lists all our app identifiers. I have a couple of existing app IDs here that I blurred out because you don't need to worry about them. What we want to do is create a new identifier for our Biorhythms app. This is an app ID, that's the pre-selected option, so let's click Continue. And here we need to enter our app details. As the description, we can write Biorhythm Calculator. Then we need a bundle ID. This must be the same bundle identifier that we can see in Xcode, here or in the General tab. And this is the same value we initially set as the app ID in the capacitor configuration. So let's copy the string and paste it as the bundle ID. I said it a few times before, but setting this ID correctly is really important because once you publish your app, you must always use the same identifier. Now, in the rest of this page, we can enable some capabilities. These are extra features we can integrate into our app, like access Wi-Fi information, Apple Pay payment processing, and so on. But our app doesn't need any of these capabilities, so let's continue. At this point, we just need to confirm that what we entered is correct, and we can go on and register this app identifier. Okay, we can now see Biorhythm Calculator as the first entry in this list. Once we have the identifier, we can go to App Store Connect. So this is a separate website from the Apple Developer Dashboard, because here you manage anything that has to do with the App Store. For example, we can see our apps, and here I have a couple of old apps that you can simply ignore. What we want to do now is create a new app to be published to the App Store. Here we need to select which platforms our app runs on. In this case, we just want iOS. Then we need a name that will be, as usual, Biorhythm Calculator. We need to select a language, and then we need to set the bundle ID. In this list, we should find the identifier we just created in the developer dashboard. So let's select it. If you don't see the identifier you expect, just wait a couple of minutes and refresh the page. Sometimes it just takes a little while for new identifiers to become visible. Next, we need an SKU. If you click on the question mark, you'll see an explanation for each field. The SKU is just an ID that we can assign to our app for our own purposes, so we can put whatever we want here. Let's write the project name. As for user access, we can leave the default, and let's go and create this app. Okay, now we would need to add some additional information, like enter a URL where to find the privacy policy for our app, and then some other things, like you can set a license agreement, and so on. We also need to set the pricing and availability. Again, there are a few different settings here. I won't go through each one of them, but the price is an important one, of course. For this example, let's set our app to be free. Okay? After making any changes, of course, we can save. Now, let's see how we can upload our app. You can see here that there's already a 1.0 prepare for submission link under iOS app. So let's select this. You can also create a new version by clicking the plus button on the left. But it already created the first version for us. So here we need to enter some more information, like promotional text, description, and so on. But also there should be a build section where we can upload the actual app. then we need an icon, and also here's where we can set the version label. We can change this if we want to. For example, we could set it to 0.1.0, and if we save, this should update the version label everywhere. And since we changed the version here, we should also update it in Xcode. Here there is a version property, so let's set it to 0.1.0. Okay, now let's see how to package this app so we can upload it to the App Store. If we look at the device list here, in addition to the simulators and possibly real devices, there's something called generic iOS device under build only device. We need to select this entry if we want to build our app for any possible device instead of running it on a specific device for local testing. With that device selected, if we run product archive, this will build a package with our app. Once it's finished, it opens this window where we can see the archive it just created. This window in Xcode is called the organizer. You can always go back to it directly if you go to Window and then Organizer. So again, this is the archive with version 0.1.0 of our app. From here, we can distribute our app or validate it. And it's usually a good idea to try validating it first. Here we can tweak a few settings, but we can simply accept the defaults. Now we need to choose how to sign our app, and it's simpler if we let Xcode automatically manage signing. So let's go ahead. Since it's the first time we publish this app, we need to generate an Apple distribution certificate. We just need to check this box and Xcode will do it for us. So it has created a new signing certificate and it recommends exporting the certificate and private key. So let's do that. I guess it's useful if you change computer, for example, and you need a way to copy your certificate across. Anyway, I'll save this as iOS distribution, and we also need to create a new password to protect the developer profile. Okay, so it's showing the file with our distribution profile. We just need to keep this file in case we need it in the future. Now let's continue with our validation process. This may take a little while. Here's a summary of our app archive. Let's validate it and wait a bit more. It's finally finished and our app was successfully validated. Good, we can now close this window. And we're ready to distribute our app for real. We want to distribute it through App Store Connect. That's already selected, so let's click Next. We do want to upload it and not just export it. Next. This part is actually similar to the validation. So again, we see the same options. Automatic signing is fine. Wait for the archive checks. Here's the summary, but now the button says Upload. So this will actually transfer the archive to the App Store. Eventually, we get the successfully uploaded message, so we're done, at least with Xcode. We still need to go to the App Store Connect site, and here, if we scroll to the Build section again, we should be able to add a new build by clicking the plus icon, and in this pop-up we see the build we just uploaded. So let's select it and add it. Alright. We have our build, version 0.1.0, and it also extracted the icon from the package. So let's save these changes. And our app package is ready. Now, we still need to fill in all these various fields, screenshots, and so on, and I'm not going to do that because it is quite time-consuming. And this is just an example app that I'm going to delete afterwards. But once you do complete all the forms, you can click this Submit for Review button, and then you need to wait a couple of days for Apple to approve your app before it's available in the App Store.